ever wondered how data science is reshaping industries and driving major decisions every day? If you are curious about how companies use data to make choices, you are in the right place. We'll begin by exploring what data science is and the data science lifecycle. We'll also clarify the different roles in this industry, comparing a data analyst, data scientist, and data engineer, helping you choose the right path. Next, we'll transition into essential Python libraries such as Numpy, Pandas, etc., and the core concepts of statistics that are crucial for data science such as Descriptive Statistics, Inferential Statistics, Hypothesis testing, and ANOVA. You will also learn about supervised versus unsupervised versus reinforced learning and get a primer on key machine learning algorithms. From there, we'll move on to the importance of SQL in managing and analyzing data before diving into the exciting realm of generative AI. Finally, we'll put theory into practice with data science projects and wrap up with some common data science interview questions to get your job ready. Now, we'll explore what data science is and walk through the data science lifecycle. And if you are curious about how a data analyst differs from a data scientist or data engineers, we'll break it down for you.
To start out with this session, first of all, let me give you a quick introduction to what data science is in itself, right? See, data science is one of these vast fields which again consists of so many different things on the inside, but as a whole, if you have to define what data science is, it is a study, it is a domain where we take in raw data and we apply some methodologies on it, use multiple tools, techniques, whatever it is, and we give out a result where the raw data that we took, you remember, gets converted into useful information, meaningful information, right? Now you might have a question saying, okay, so every data, isn't it at the end of the day information, right? True, there is information in the data, but on the whole, when you take a look at data, right, it is a raw entity, it remains unclean, it consists of things that you can use, things that you cannot, things that you wouldn't be of use to you basically. If you keep all of that as well, down the line, it's going to hurt your machine learning model when it's learning. We're going to get into all the nitty-gritty details, but for now, we have to realize that this is a study. We're going to be making use of a lot of tools, algorithms, and multiple different concepts to find whatever is hidden in the data. Data science, right? We're doing something sciencey with the data. We're trying to find out what's hidden in the data, all the patterns, whatever it is that data cannot tell us when we look at it with our naked eye, and we can find a wealth of information. To do that is what we use, guys, data science, right? So you can manipulate data, you can analyze data, visualize it, you can do a lot of things with data science, ladies and gentlemen. Here is a structured process that you see on your screen right now, which goes from left to right about how the data science architecture works. Now, the first thing, whenever you are trying to solve any sort of problems with data science, ladies and gentlemen, what do you think is the first thing? You have to know what is the problem that you're trying to solve, right? Understanding the business problem, knowing that you can use a concept of data science, knowing that there is something in this domain that you can use to solve the problem. Formulating an actual plan of action is something, right? It's called as a requirements document. To have all of that ready will be your first step about how you will solve a problem with data science. Once you've done all of this, the second thing is you will realize, okay, so here's my problem, this is my solution. To get to my solution from the problem, I'm going to require certain data for me to work on it, right? So if you're trying to say, hey, what is the amount of chocolates I might sell next month? Right? I might sell next month. I'm trying to predict the future here. To predict the future, I can just guess saying, hey, I'll sell 10, but eventually I could have sold 500 there. But to back it with certain proof and to give a good amount of accuracy, I say, okay, so let's analyze last month, 6 months, 1 year worth of data to see what we might find out about next month, right? So in that case, you have to acquire the data. Now, data acquiring can be from your own server, it can be from a cloud storage, it can be a little bit of public data from your competitors, it can be data from social media. Guys, data, you can find it everywhere. It can come from a million different sources, and as a data scientist or a person looking into data science, you must have the capability to bring in the data, acquire it and store it and keep it ready for pre-processing. Now, pre-processing is also involved in the second step itself, where what you try to do is you clean the data, right? At the start of the session, I told you that data is a raw entity. It consists of useful things and noise. We do not want the noise, we only want useful things, right? So once you clean all of this, data of course is like very unruly. Sometimes you have to add values, sometimes you have to delete values. There's so many different examples that I can give you. For example, if I ask what is your blood group, there can be a phone number given there. Well, doesn't make sense. I want your blood group, I do not want your phone number or your name or whatever it is, right? So in that case, you have to correct all of these things or remove them entirely. Because if you do not, look at the third step. The third step talks about EDA or exploratory data analysis, where you actually look into the data, apply these statistical methodologies that I'm about to teach you. And, there, if you do not clean the data, your data is going to be all wrong. It's going to give you incorrect result. And even then, if you cannot catch that your data is incorrect, and if you feed it to the next step, which is machine learning, right? It's going to be disastrous. Your machine does not understand a lot of things. It can be the fastest processing machine right now, your phone, your whatever it is, your iPad, your computer, your TV. These systems that we have today are millions and millions and millions of times faster than the entire spacecraft that took humans to the moon, right? So what happens is, at the most fundamental level, your computer only understands zeros and ones, and us talking to a computer in zeros and ones is highly inconvenient. Hence the reason we have high level user interfaces. We have Windows, we have iOS, all these operating systems. In that also we have a convenience. We use, whenever we are writing Python code, we need an integrated development environment for it. We need a user interface and all of that, right? So coming back to the point, what happens is that in machine learning, if you teach it wrong data, it will happily learn. It has no way to verify unless you sit and verify what's going on, right? So if you are trying to send pictures of cats and dogs to your machine learning algorithm and say, hey, okay, so which is a cat and which is a dog, if you train it incorrect, it's going to look at a cat and happily say this is a dog. If you send a picture of a dog, it's going to say, hey, what a cute cat, right? So we don't want things like that to happen. That's the reason why your data has to be really clean. That is step number 4, guys. When we're talking about step number 5, right? Step number 5 talks about prediction and deployment. Model prediction is a concept where we actually try to see, what's going on with the model. Has our machine learning output learned anything? Has all of our mathematical calculations, statistics powered machine learning algorithms done everything correct? So you're going to predict everything, see if everything is fine. And if it is fine, you send it for deployment, as in you actually use it to solve a problem. That is deployment, right? So this is a structured process. This is a life cycle. What happens after deployment is sometimes there arises another business problem which you have to solve with data science. So what do? So you go back, you circle back to step 1 and you do all the things that I just mentioned, right? So this is the data science life cycle.
Now we'll break down the key differences between 3 crucial roles in data world: data analyst, data scientist, and data engineers. Understanding these roles will help you navigate your career path or collaborate more effectively with your data team. Data analysts are the detectives of the data. They focus on interpreting and visualizing data to provide actionable insights. Using tools like Excel, SQL, and BI software, data analysts turn raw data into reports and dashboards, helping businesses make informed decisions. Data scientists, on the other hand, are like data scientists with a twist. They dive deeper into data using statistical models, machine learning algorithms, and programming languages like Python and R. Their goal is to uncover hidden patterns, predict future trends, and build models that drive strategic decisions. Data scientists often work on complex projects that involve advanced analytics and predictive modeling. Data engineers are the architects behind the scenes. They build and maintain the infrastructure needed to store, process, and manage data. Using tools like SQL, Hadoop, and Spark, data engineers design and implement data pipelines and ensure that data flows seamlessly from various sources to data warehouse. Their work ensures that data is clean, reliable, and ready for analysis. So data analysts focus on interpreting data, data scientists delve into advanced analytics and predictive modeling, and data engineers build the system that make data accessible and reliable. Each role plays a vital part in leveraging the data to drive business success. Which role aligns with your interest or career goals? Let us know in the comments below. Now that we have covered the essential of data analyst's role, let's shift gears a bit. Quick question, what's your favorite Python library for data analysis and why? Drop your thoughts in the comments below. Up next, we are stepping into the powerful world of Python libraries essential for data science. We'll explore how libraries like Numpy, Pandas, Matplotlib, and Seaborn can boost your data analysis skill. These tools are the backbone of any data professional's toolkit. So let's jump in and see how they can elevate your work.
Now we'll start off with this library called as Numpy, which stands for Numerical Python. And as it is stated over here, it is the core library for numeric and scientific computing. So whatever numeric or scientific calculations you'd have to perform, Numpy should be your go-to language. And this library called as Numpy consists of multi-dimensional array objects and a collection of routines for processing these arrays. So let's go ahead and create our first Numpy array. So you can have a single dimensional Numpy array or a multi-dimensional Numpy array. Now, we'd have to start off by importing this library. So to import Numpy, we'll type in import Numpy as NP. So this NP which you see over here is known as the alias. So we are importing the library Numpy with this alias NP. Now, this Numpy library has a lot of methods and one method is called the array method. And with the help of this, we will be able to create the Numpy array. All we have to do is type in np.array and inside this I am passing in the list of values starting from 10 going on till 40 and I'll store it in this object called as n1, and when I print it out I get the result 10, 20, 30, 40. Similarly, I go ahead and create a multi-dimensional array. So here we are passing in a list of lists. So here we had a single list. Here we are passing in a list of lists. So as you see, we have a list over here and inside this we have two more lists. The first list comprises of the elements 10, 20, 30 and 40 and the second list comprises of the elements 40, 30, 20 and 10. And when I print it out, this is how I get this multi-dimensional array. The first list is present in the first row and the second list is present in the second row. Now let me go to Jupyter Notebook and implement these two. Let me just add a comment over here. I'll name it as Numpy. Now I'd have to import the Numpy library. So I'll have import Numpy as NP and let's just wait till this library is loaded. Now that this is loaded, I can go ahead and create the Numpy array. So for this, I'll have to use np.array and inside this I'll be passing in a list of values. So I'll pass in 10, 20, 30 and 40 and I'm storing it in this object called as n1. Now let me print out n1 over here. And as you guys see, I have successfully created this Numpy array, which over here the values are 10, 20, 30 and 40. And just to be sure, I'll go ahead and check the type of this Numpy array. So I'll have type. Inside this, I'll pass in n1 and as you guys see, we get the result numpy.nd array. So nd array stands for n dimensional array. Now we'll go ahead and create a multi-dimensional array over here. So to create a multi-dimensional array, we'd have to pass in a list of lists inside this np.array method. So I'll have this outer list. Inside this, I will create two lists. So the first list, let's say, comprises of the elements 1, 2, 3 and 4 and the second list comprises of the elements 4, 3, 2 and 1. Now I'll just print out n2 over here and I have created this multi-dimensional array where all of the elements from the first list are present in the first row and all of the elements from the second list are present in the second row. Now that we have created these Numpy arrays, we'll now see how to create or how to initialize a Numpy array with different ways. So now let's say if I want to initialize a Numpy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the Numpy array, then we are using np.zeros and it takes in two parameters. So these two parameters basically indicate the dimensions of the Numpy array. So if I want to create a 1 cross 2 Numpy array where all of the values are zeros, then I can just go ahead and type in np.zeros and inside this I'll pass in the dimensions, which is 1, 2 and I get a 1 cross 2 Numpy array where the values are only zeros. Similarly, over here, I am creating a 5 cross 5 NumPy array where all of the values are zeros. So I'll just use np.zeros, and inside this, I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here, I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2, and let me go ahead and print out n1 over here. So as you guys see, I have successfully created this NumPy array. Now if I want maybe a NumPy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3 cross 3 NumPy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here, and we have a 3 cross 3 NumPy array which comprises of only zeros. Now if I want to initialize a NumPy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in 2 parameters. The first parameter is the dimension of the NumPy array. The second parameter is the value which we'd want to insert into this NumPy array. So here we are creating a 2 cross 2 NumPy array where the value is filled with 10. So as you guys see, it's a 2 cross 2 NumPy array where we only have tens. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in 2 parameters. Let's say I'd want a 4 cross 8 NumPy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4 cross 8 NumPy array where the value is only 5. Now similarly, if I want to initialize a NumPy array within a particular range, then I can go ahead and use the arange method. So here, as you guys see, I am using np.arange, and this again takes in 2 parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. And when I give in 20, so here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skip value. So the skip value is 5, which would mean that after 10, we'll have 15. So 15 plus 5 becomes 20. 20 plus 5 becomes 25. And that is how this keeps on proceeding. Now, when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement arange method over here. np.arange, and I'll store this in n4. Now I'd have to use np.arange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200, and I'll print out n4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I give the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this NumPy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a NumPy array with random numbers. And to initialize NumPy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. And over here we have three parameters. The first parameter is basically, and over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22 and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers. And this will take in 3 parameters. Let's say I would need values between 50 and 100. And I would need 10 random values over here. And let me store this in N5. Let me go ahead and print out N5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Now, similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. That was all about initializing a NumPy array with different methods. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list, we have 1, 2 and 3. In the second list, we have 4, 5 and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns. And this is what the n1.shape gives us. Now, if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list, I'll have values 10, 20 and 30. And in the second list, I'll have values 40, 50 and 60. And I'm storing this in n6. Now, once that is done, let me just print out n6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have n6.shape. And we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape. And over here, I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, head stack and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20 and 30. Then we are creating the NumPy array n2 where we have the values 40, 50 and 60. Now when we use vstack over here, this again takes in 2 parameters where we'll just pass in 2 NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1, n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack 2 NumPy arrays. So n1 and n2, we've got the same numpy arrays over here. And instead of using vstack, I'm using the head stack method. I'm passing in n1 and n2. And as you guys see, 40, 50, and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these numpy arrays into separate columns, so we have n1 and n2, and when I'm using column stack over here, as you guys see, n1 goes into the first column, n2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these two numpy arrays over here. I'll have n1, which will be np.array, and inside this I'll have 1, 2, and 3. Then I'll also go ahead and create n2. So this will be np.array, and inside this I'll have 4, 5, and 6. So I have my n1 and n2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in n1 and n2, and let's see what will be the result. So we have vertically stacked n1 with n2. n1 is at the top, n2 is at the bottom. You can also change how these are stacked. So instead of giving n1, n2, let's say if I give in n2 and n1, you guys would see that n2 is at the top and n1 is at the bottom. Now we can similarly work with the head stack method. So here I'll type in np.hstack, and inside this again I'll pass in n1, n2. And as you guys see, I have stacked n2 at the back end of n1. Now, if I want n2 first and n1 second, I just have to change the sequence. So inside np.headstack, I'll give in n2, n1. And I have 4, 5, 6 first, and n1 is attached at the back end of n2. Then we have column stack. So I'll just have np.column stack over here, and inside this I'll pass in n1, n2. And as you guys see, I have n1 in the first column, n2 in the second column. Similarly, if I give in n2, n1, you will see that I have n2 in the first column and n1 in the second column. So this is all about stacking the numpy arrays. Now we'll also work with intersection and difference methods. So here again we have two numpy arrays. So in the first numpy array we have the values from 10 to 60, and in the second numpy array we have the values from 50 to 90. And if I want the common elements between these two numpy arrays, then I can use the intersect 1D method. So here in the intersect 1D method, I would just have to pass in these two numpy arrays. And as you see in the result, we get a new numpy array comprising of the common elements in these two numpy arrays. Then over here I have n1 and n2. If I want to find out all the elements which are unique to n1, then I can use the setDiff1D method. So here in n1 we have the elements starting from 10 going on till 60. In n2 we have elements starting from 50 going on till 90. So here as you guys see, 50 and 60 are common in n1 and n2. And if I want the elements which are unique to only n1, then I would have to use setDiff1D, and I'll pass in n1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the numpy arrays. I can also change the sequence over here. So instead of passing in n1, n2, when I pass in n2, n1, then this will give me all of the unique elements which are present in n2. And since 50 and 60 are common in both the numpy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in n2. So let's go ahead and work with intersect 1D and setDiff1D. I'll just add a comment over here, intersect 1D. And I would have to create two new numpy arrays. I'll have n1 over here. So I'll have np.array, and inside this I'll pass in 1, 2, 3, 4, 5, 6. And I'll have n2, and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect 1D. So I'll have np dot intersect 1D, and inside this I'm passing in n1 comma n2, and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now if I want only the elements which are common to n1, then I can use the setDiff1D method. So here I'll have np dot setDiff1D, and inside this again I'll be passing in n1 comma n2, and as you guys see I have 1 2 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np dot setdiff1D, and I'll just change the sequence over here. Instead of passing n1 comma n2, I'll have n2 comma n1, and the only unique elements which are there in n2 are 7 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In n1 we have 10 and 20, in n2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum, and inside this as a list I'll pass in n1 comma n2, and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays, and let me create new n1 over here. So I'll have np.array, and inside this I'll have 10 and 20. Then I'll go ahead and create n2, and inside n2 I'll again have np.array, and over here I'll have 30 and 40. I'd have to pass this on as a list of values, so I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1 comma n2, and actually I'd have to pass this as a list. So I'll have n1 comma n2 over here, and as you guys see, the resultant comes out to be 100. If I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1 comma n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60 because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows, so here it will be np.sum, and over here I'll have n1 comma n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70 because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40, and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19, and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10, and 30 becomes 15. So this was some basic idea about NumPy. Now, let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array. And inside this, I'll have 10, 20, 30, and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35, and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. And 10 becomes 5, 20 becomes 15, 30 becomes 25, and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3, and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if we want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np.mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another NumPy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std. And if I want to find out the standard deviation of this particular NumPy array, so I'll pass in n2, and you would see that the standard deviation of all of the elements of n2 would be 2.397. So till now we've worked with some basic NumPy arrays. Now let's go ahead and work with a NumPy matrix. So here we are creating a 3x3 NumPy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this NumPy matrix, let's see how can we access individual rows and columns from this entire NumPy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1, and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1, and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this Numpy Matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here, and since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2, and I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in Numpy Matrix over here. Now that this is set, I'll have np.array, and over here I'll have a list of lists. So in the first list I will have 10, 20 and 30. In the second list I will have 40, 50 and 60. In the third list I will have 70, 80 and 90. And I will go ahead and store this in n1 again. Now I'll go ahead and print out n1 and let's see what would be the result. So this is our NumPy array which we have just created. Now if I want to access individual rows from this, I'll have to give in n1, and inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write n1, and over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows, and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows, and all of these rows need to be from the third column, and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here, as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows would be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np.transpose, and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30 which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row, which became the third column over here. Now we'll see how to perform two matrices. So over here we have n1 where we have the elements starting from 1 going on till 9. Then we have n2 where we have elements starting from 9 going on till 1. Now if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np.array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50 and 40. After this, I'll have 30, 20 and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here, we are saving this NumPy array with this name called as my_NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now, once that we save this, to load this NumPy array, we will have to use np.load. And over here, we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my_NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy. And we go ahead and store this in n2 and we print out n2. We see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save. And this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load. And over here, I'd have to give the name of the NumPy array. So it will be save_n1.npy. Let me actually remove this over here. And I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result. So Pandas stands for panel data and is the core library for data manipulation and data analysis. So if you want to perform any sort of data analytical task, Pandas should be your go-to library. And Pandas provides single and multi-dimensional data structures for the purpose of data manipulation. So the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as the data frame. We'll start off by understanding about the series object. So series object is a one-dimensional labeled array. So we have already worked with the NumPy array. So in NumPy array, we had no labels along with it. It was just a simple blank array where we had stored some values. But over here in a series object, as you guys see, we have labels, or you can consider them to be indexed with labels over here for these. So first we'd have to start off by importing pandas, which is the library, and we are giving this alias as PD. So import pandas as PD. Then if we want to create a series object, we'll have pd.series, and inside this I am passing in the values 1, 2, 3, 4 and 5. And when I print it out, I get this series object. So when I check the type of this, type of S1, this gives me pandas.core.series.series. Now over here, you'd have to keep in mind that S is capital over here. So if you're given a small s, you will get an error. So let's go ahead and create our first series object. So I'll just add the comment pandas. Now our first task would be to import the pandas library. So I'll go ahead and type in import pandas as PD. Let's just wait for this to be loaded properly. Now that we have loaded the library, I can go ahead and create the series object. So I'll type in pd.series where S is capital. Inside this, I'll pass in the list of values. So let's say I'll just have 10, 20, 30, 40 and 50, and I'll go ahead and store it in this object called as S1. Let me print out S1 over here, and as you guys see, I have created this series object. Let me also check the type of this. So inside the type method, when I pass in S1, you guys would see that this is a series object. And over here, we have the labels. So the labels are 0 to 4. So by default, the label or the index starts with 0 over here. So 10 is present at label or index 0, 20 is present at index 1, 30 is present at index 2, and that is how it proceeds further. Now, since we have labels in a series object, we can change how the label of the index looks like. So over here, we just had numbers starting from 0, but instead of numbers, let's say if I wanted alphabets over here, then I can add a new attribute called as index. So over here with this index attribute, I am setting the values to be equal to A, B, C, D, E. So here initially we had index 0. 0 has been changed to A. Then we had 1, 1 has been changed to B. We have 2, 2 has been changed to C, and that is how it proceeds. So now over here, let me go ahead and change these index values. So it is the same command over here. And with this same command, all I'm doing is adding a new attribute called as index. And I'll pass in a list of values for the indices. So I'll have A, B, C, D. Let me have D over here, and I'll have E. Now, when I click on run and I print out S1 over here, you guys would see that I have changed the indices from 0 to 4 to A to E. Now we can go ahead and see how to create a series object from a dictionary. So we have already worked with dictionaries. We know that the dictionary is a key value pair. So here we'll just give in pd.series, and over here we have 3 key value pairs, A10, B20, C30. So here automatically the keys are taken as the labels, and these values are taken as the series values over here. Let me create a new dictionary. So I'll have D1, and inside D1, let me have 4 key value pairs. Maybe I'll have A and 10. Then I'll have B and 20. After that, I'll have C and 30. Going ahead, I'll have D and 40. Now I'll just go ahead and print this out. As you guys see, I have successfully created this dictionary. Now I would have to create a series object out of this. So I'll just have pd.series, and inside this I'll pass in D1, and let's see what would be the result. So these 4 keys which were present became the labels, and these values over here in the dictionary became the series values as well. Now we can also go ahead and change the index position. So similarly, as we had actually changed the index values from numerical to alphabetical. So when I given the index values as B, C, D, E, this sequence is maintained. So I have B and C first. So for B, I have the value 20, C, I have the value 30. And D, we had not created any key with this particular index. So that is why we have NaN over here. And then we have A, for which we have the value 10. So this is how we can maybe add a new index position or change the existing index positions. So this is what we had over here. This was our series object. And now what I'd want to do is, so instead of A, B, C, D, I would want, let's say, C, B, A, and D. And if I click on run, you guys see that the sequence has changed over here. Now we'll also see how to extract individual elements from the series object. So here we have all of these elements starting from 1 going on till 9. And again, you'd have to keep in mind that the indexing starts from 0. So if I want to extract this particular element over here, so the index value for this would be 3. So 0, 1, 2, and 3. And when I given the index value as 3, I am able to extract this particular element. And if I want to extract a sequence of elements over here, so if I want the first 4 elements, then I'll have S1 colon 4. This would mean that I've been extracting all of the elements starting from index number 0 going on till index number 4. And since 4 is exclusive, so that is why we will only have till index number 3. So we'll have index number 1 going on till index number 3. And if you want to extract elements from the back side, here we'll have S1 and we'll type in -3 over here. So -3 basically means third element from the end. Third element from the end. When I give in colon, this would mean third element from the end going on till the end. So this is the third element from the end over here. So that is why I'll have 7, 8, and 9. And this is how I'll be able to extract a single element, a sequence of elements from the beginning, and a sequence of elements from the back. Let me just create a new series object over here. So I'll have S1 is equal to pd.series, and inside this I'll pass in a list of elements. I'll have 10, 20, 30, 40, 50, 60 and 70. Now that I have this, let me extract this element which is present at index number 3. So I'll have S1, I'll have parenthesis, then I'll just go ahead and give in the index value. So index value will be 3. And as you guys see, I have successfully extracted this particular element. Now if I want to extract the first 4 elements, then I'll just give in the colon over here and I'll have 4. And as you guys see, I have extracted the first 4 elements. Now if I want the last 3 elements over here, then I'll have S1. Then I'll have colon and I'll type in -3, which would mean the third element from the last going on till the last element over here. And I have 50, 60 and 70, which are the last 3 elements. Now we can also go ahead and perform some simple operations on top of the series object. So if I want to add a scalar value, so initially we had this series object where the number started from 1, went on till 9. And if I just wanted to add the scalar value phi to all of the individual elements which are present in the series object, all I have to do is use plus phi. And as you guys see, 1 becomes 5, 2 becomes 7, 3 becomes 8 and so on. And we can also go ahead and add 2 series objects. Over here I have S1 where the elements are from 1 to 9 and S2 where the elements are from 10 to 90. And when I perform S1 plus S2, this would add the elements which are present at the same index position. So here we'll have 10 plus 1, 11, 20 plus 2, 22, 30 plus 3, 33, and this goes on till the last index position over here. So let's go ahead and perform some basic operations on top of the series object. So I already have S1 over here. And these are the original values which are present in S1. Now I'd want to add 10 more to these existing values. So I'll just type in S1 plus 10. And as you guys see, the values, all of the values which are present in the series object have been incremented by 10. Now also I can add 2 series objects together. So in the series object, I have 7 elements. I'll go ahead and create S2. Where I'll have 7 more elements over here. So I would have to type pd.series and inside this, let me just have 7, 6, 5, 4, 3, 2 and 1. Let me print out S2 for your sake over here. So we have S1 and S2, and when I perform S1 plus S2, this is the result which we get. So 10 plus 7 becomes 17, 20 plus 6 becomes 26, 30 plus 5 becomes 35, and this proceeds to the last index value. So that was all about the series object, which was a single dimensional labeled array. Now we'll work with a data frame, which forms the major part of all of the machine learning data science projects. So what exactly is a data frame? It is a 2-dimensional labeled data structure. And if you'd have worked with SQL or maybe Excel, you would have dealt with tabular data. And a data frame helps you to deal with tabular data in Python seamlessly. So a data frame, because this is a tabular data, consists of rows and columns. Now, let's see how can we go ahead and create a data frame from a dictionary. So to create a data frame, we'd have to use this particular method over here. We'd have to type in pd.dataframe, where D is capital and F is also capital. So by any chance, if you give maybe D as small or F as small, you'll get an error. So both of them have to be in capital case. And over here, I have 2 key value pairs. So the first key is name, and then we have a list of values which are Bob, Sam, and Annie. Then we have the next key, which is marks. Then we have the list of values for marks, which are 76, 25, and 92. So here, as you see, the keys become the column names and the values become the records over here. So name and marks become the column names, and these values over here, the list of values Bob, Sam, and Annie, which are the values for this key, become the records of this particular column. Similarly, these values are there for this particular key, and these become the records for this particular column. So let me go ahead and create a first data frame over here. So I'll just go ahead and type in data frame. Now to create a data frame, I'd have to type pd.dataframe, and D and F both have to be capital. And inside this, I'll create a dictionary. So to create a dictionary, I would need curly braces. So the first key would be name, and I'll go ahead and give in a list of names over here. Let's say the first name is Sam. Then we have Annie. Going ahead, we have Jennifer. Now, once we have the first key value pair, I'll go ahead and also add their marks over here. So the second key would be marks, and I'll have a list of values over here. Let's say Sam has scored 50 marks, Annie has scored 60 marks, and Jennifer has scored 70 marks. And I'll go ahead and store this in df. Let me print out df over here. And we have created our first data frame, where the column names are name and marks, and the values are these over here. And let me go ahead and also show you guys the type of this object which I've just created. So inside this type method, I'll be passing in df. And as you guys see, this is pandas.co.frame.dataframe, which basically means this is a data frame object. Now that we have created our first data frame, we'll perform some basic functions on top of a data frame. We've got head, tail, shape, and describe. So we'll just implement all of these. Now to implement this, we will be performing them on a dataset called as the iris dataset. Now to read any CSV file, we have a method called as pd.read_CSV. So here I'll have pd.read_CSV. And inside this, I'll give in single quotes and given the name of the file. So the name of the file will be iris.csv, and I'll go ahead and store this in a new object called as iris. Now let me hit on run. Let me check the first 5 records which are present in this iris data frame. So if I want to check the first 5 records which are present in this iris data frame, I need to use the head method. So iris.head, as you guys see, I have the first 5 records. So this iris data frame comprises of 5 columns, which are sepal length, sepal width, petal length, petal width, and species. And we'll have 3 different species, which would be Setosa, versicolor, and virginica. So this is how we can work with the head method. Now, similar to the head method, we would also have the tail method, which would give us the last 5 rows which are present in a data frame. So here I'll type iris.tail, and when I click on run, you guys would see the index value over here. The index value starts from 145 and goes on till 149, because there are 150 records in this iris data frame. So we have extracted the last 5 records and we have printed it onto the console. Then if you want to check the number of rows and number of columns which are present in this iris data frame, we can just use the shape method. So here I'll have iris.shape, and as you guys see, this gives us a dimension value of 150, 5, which means there are 150 records and 5 columns. Then we'll have the describe method. So here I'll have iris.describe. And now when I click on run, we have all of these numerical quantities over here. So let's say if I want to find out what is the minimum value which is present in the sepal length column. The minimum value present in this sepal length column will be 4.3. Similarly, what is the maximum value in sepal length column? It will be 7.9. What is the mean value? It will be 5.84. So these are some interesting metrics which you can find out with the describe method. So now that we know this, let's actually see how can we extract individual records or individual columns from a data frame. So for that purpose, we can use the .iloc and loc methods. So let's start off with the .iloc method. So .iloc method, with the help of it, we can extract rows and columns on the basis of index. So here iloc basically stands for index location. And over here, as you see, I have a comma, and on the left side of the comma, that would indicate all of the rows, and the right side of the comma, that would indicate all of the columns. So from this entire iris data frame, I am extracting the first 3 records. So here the rows would be 0 to 3, and 3 is exclusive over here. That is why I'll have the records where the index values are 0, 1, and 2. And similarly, the columns would be 0 to 2, which would mean the column which is present at index 0, which will be sepal length, and the column which is present at index 1, which is sepal width. 2 again over here is exclusive. So let me go ahead and extract some rows and columns with this iloc method. So we already have this iris data frame with us. Let me again print out the head for you guys so that will be easier for you to have a glance at this. Now, let's say from this entire data frame, I would want the records from index number 30 going on till index number 40, and I would want the columns which are present at maybe index number 3 and index number 4. So index number 3 will be 0, 1, 2 and 3. This is index number 3, this is index number 4. So here I'll have index number 3 going on till the end because this is the last column. Let me print this out and show you guys the result. As you guys see, I have extracted all of the records starting from index number 30 going on till index number 39, and the columns which you see starts from index number 3, which is this particular columns index, and goes on till the end over here. So this is how we can extract individual rows and columns with the .iloc method. Now we have the .loc method. So instead of giving the column index, if I want to extract columns on the basis of their names, then I can go ahead and use the .loc method. And over here, when it comes to rows, you see that I've given 0 to 3. Here, when it comes to .loc, you'd have to keep in mind that 3 is inclusive. This is the only case where maybe you will find that the final value over here is inclusive. So when I given 0 to 3, you will get all of the records starting from index number 0 going on till index number 3, which is also inclusive. And over here, I'm giving in the column names, which are sepal length and petal length, and that is what I'm extracting over here. So I have this iris data frame. Then I'll just go ahead and use this .loc method. Now from all of these records, let's say I'd want all the records starting from index number 10 going on till index number 20. And the columns which I'd want to extract are sepal length and petal length. I'll just have sepal.length over here, and the next column which I want would be petal.length. Let me hit on run, and as you guys see, I have all the records starting from row number 10 going on till row number 20, and 20 is also inclusive over here. And the columns which I've extracted are sepal length and petal length. Now we'll see how to drop a particular column. So many a times it would happen that not all columns which are present in a data frame are important. So from this entire data frame, if we want to drop a particular column, then we can just go ahead and use the drop method. So here I'll have iris.drop, and I am dropping or removing the sepal length column from this entire data frame. So here, when I set the axis value to be equal to 1, this would basically mean that I am dropping a column. So if you want to drop a row, then you'd set the axis value to be equal to 0. And if you want to drop a column, then you'd set the axis value to be equal to 1. So if from this entire iris data set, again, I'll show you guys the head of this so that you guys can have a glance at all of the columns which are present over here. So from all of the columns, if I want to drop the species column, all I have to do is type in iris.drop, and inside this I'd have to give in the name of the column, which would be species, and I'd have to set the axis, which will be equal to 1 because I'm dropping a column. And as you guys see, I have successfully dropped the species column from this entire data frame. Now similarly, if I want to drop some particular rows which are present in this data frame, so here, as you guys see, the index value, it starts from 0, goes on till 4 over here. But if I want to drop the row indexes of 1, 2 and 3. Here, as you guys see, I have two parameters. First parameter, I'll give in a list of all of the indices that I'd want to drop. So I'd want to drop the index value 1, index value 2 and index value 3. And the resultant which you see over here, after 0, we directly jump on to the index number 4. So now from this entire data frame, this what you see over here, I'll just use iris.drop, and I would want to drop the index values of 1, 2 and 3, and I'll set the axis to be equal to 0. And when I hit run, you would see that after 0, we are directly jumping onto index number 4. So this is a very simple example of how to drop some records and how to drop some columns from your data frame. Now we'll go ahead and work with some simple pandas functions. So from the iris data frame, if I want to find out the mean values of all of the columns, I can just go ahead and use the mean method. Similarly, if I wanted the median values of the records of all of the columns, then I'll just go ahead and use the median method. Similarly, if I wanted to find out the minimum value, I'll use the min method. And if I wanted to find out the maximum value, I will use the max method over here. So very basic operations. So when I use iris.mean, this would give me the average values of all of the columns. So average sepal length of the entire data frame is 5.8. Average sepal width is 3.05. Average petal length is 3.75 and average petal width is 1.19. Similarly, if I want to find out the minimum value of all of the columns, so I'll have iris.mean and this will give me all of the minimum values. And if I want to find out the maximum values, I'll just go ahead and type iris.max and this would give me the maximum value of all of the columns over here. So I've got the mean value, the minimum value, the maximum value, and I can also find out the median value. So I'll just type in iris.median and when I click on run over here, this would give me the median values with respect to all of the columns which are present. Now we will get on with this library called as Matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be NumPy because we would want to create our data with this NumPy library. Then we would import this pyplot submodule from this Matplotlib library. So we'd have to type in from Matplotlib import pyplot as PLT and the alias which I'm giving for pyplot is PLT. Then I'll create two NumPy arrays over here. The first NumPy array will be X and I'm creating this NumPy array with the help of this np.arange method and the range will be from 1 to 10. And then I'll create the next NumPy array which is basically 2 times of X. So all I have to do is multiply X with 2 and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6 and this is how it proceeds. Now once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this pyplot module. So this takes in two parameters which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between X and Y, or in other words, as the value of X increases, the value of Y also correspondingly increases. So let's go to Jupyter Notebook and create our first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import pyplot as PLT. Let me write the spelling properly over here. And once I've imported these two libraries, I'd have to create the data. So first I'll have X and this I'll be creating with np.arange and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out X for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create Y, Y will just be 2 times of X. So here I'll have 2 into X and then let me print out Y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in X. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in two parameters, which are x and y. So this data would be plotted onto the x-axis. This data would be plotted onto the y-axis. And I'll just show this as a result. So as you guys see, we have this object x mapped on the x-axis, this object y mapped on the y-axis, and this is the corresponding line plot. Now that we have created this, we can also add the title, x label and y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add x label and y label by using these two methods. And as you guys see, we have added these two labels over here. So let me add the title, x label and y label, plt. So I'll copy this entire code over here and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title, and I'll just give the title as first line plot. Then I'll have x label. So here I'll have plt.x label, and here I'll give the x label as x-axis. Then I would have the y label, so plt.y label, and inside this I'll give the y label as y-axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the x and y-axis labels. Now with the help of these three methods, we have added the title, the x-axis label and the y-axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color. And as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default also the line width is 1. So we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2. And this is the final result which we get. So let's go ahead and add some color, line plot and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here and I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have 2 lines in the same plot. So for this purpose, I'll have 2 y variables. So x variable will be the same, which will be the numbers starting from 1 going on till 10. But I'll have 2 y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make 2 plots because I'd want 2 line plots in the same graph. So first I'll have plt.plot and this line will be between x and y1. So this first line which we are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2, and the color of this line will be red, and this will be a dashed line, and we are setting the line width to be equal to 3. Then again we have the title, x label and y label, and we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here, but when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dash line. Then we also have this next line over here, which is between x and y2, and this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have x. Now let me just print out x for you guys over here. These are all of the numbers which are present in x. Now y1, I'll set it as 2 times of x, and then I'll have y2, which will be equal to 3 times of x. So I have y1 and y2 ready. Now after this, I would have to make a plot between x and y1. So I'll have plt.plot, and onto the x-axis, I'll obviously have x. Then onto the y-axis, I'll have y1. And the color for the first line, I'll have green. And let's say the line width, I'll set this to be equal to 2. Then I'll have the next line, which will be between x and y2. So here I'll just write down x comma y2, and for this line I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it'll be plt.show, and I would also want a grid over here. So before this, I'll set plt.grid, and I will set this to be equal to true. Let's hit run. And as you guys see, I have 2 lines in the same plot. Now in the earlier example, we had 2 lines in the same plot, but if we actually want 2 subplots itself, that is, as you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have x, y1 and y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have 2 plots over here, and those 2 plots would be present in this way. So I'll have 1 row, 2 columns. As you guys see, I have 1 row and 2 columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between x and y1, color will be green, line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between x and y1. Then we'll have plt.subplot, which is our next subplot, and the first 2 parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between x and y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have x, y1 and y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between x and y1. And I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot. And the first two parameters will be 1 and 2 because I'd want these two plots along the columns, and I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between x and y2. And over here, I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have two subplots over here. The first subplot is between x and y1, and the color of this line is yellow. The next subplot is between x and y2, and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have 2 rows and only 1 column. When I hit run, as you guys see, I have 2 rows and only 1 column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between two numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys. And I'll go ahead and convert these keys into a list. So I'll pass this into this list method, and I'll store the result in this names object. Similarly, I'll extract all of the values, I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values, the second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names which are Bob, Matt, and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student, who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student, Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names, and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam, and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now the plot which we had created earlier was very bland, and we can go ahead and add the title, X label and Y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the X label and the Y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names and the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now, after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar. And we are adding a color as well. So by default, we had the blue color. And if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red, and we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis we'll have names. Let me change this to names, and as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we will head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities. And these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show off the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in X, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have Y, and in Y, I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter, and I'll just pass in x, y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same X and A. These are the same list which we have. It's just that we are adding new attributes over here. The first attribute is marker. Initially, we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now, instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot where we had two lines in the same graph, we can perform a similar sort of thing over here where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have X and A. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well. And then y2, I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between X and Y1. Then I'll go ahead and create the second scatter plot, which will be between X and Y2. And I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these 3 lists, then I'll have plt.subplot, then we'll have the same 3 parameters. And since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between X and A. So this is the scatter plot between X and A. Then I'll go ahead and create the next subplot, and the next subplot will be between X and B. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1, and the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. So that was all about the scatter plot. A categorical column, but when it comes to histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1, and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show, and this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4, and this is the result which I get. I'll copy this entire thing, I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5. And I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now, the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if we have to load any data frame, we'll have to use read_csv, since this is a CSV file. So inside read_csv, I am passing in the name of the file, and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, So here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column and I'll set the number of bins and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd. And we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame. And as we see, we have sepal length, sepal width, petal length, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll give in the name of the column. So the name of the column, let me keep this to be small. It'll be petal length. And I'll set the number of bins to be equal to, let's say 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset. And we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset. And I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in SNS.lineplot, and onto the x-axis, I am mapping the time point column, and onto the y-axis, I am mapping the signal column. And then I'll have a new attribute called as data. So basically, I am building this line plot on top of this fMRI dataset that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to. So here, if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. and we'd have to load the required libraries. The first library is obviously Seaborn, so I'll have import Seaborn as SNS. Then I'd also need PyPlot, so I'll have from Matplotlib import PyPlot as PLT. Let's just wait for these two libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have SNS.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI. And I will store it in this object called as fMRI, and let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present, and I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. SNS.line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event, and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20, and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2. And when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of queue event is much higher when compared to the increase of the stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column, and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column. And you see that the queue event is being represented with this dotted line and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the Seaborn library. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary, and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as pd. Now, once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this, I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in pokemon.head, and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this isLegendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this isLegendary column and then the speed column. So I'll be using sns.barplot, and onto the x-axis, I would have to map isLegendary, and then onto the y-axis, I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between isLegendary column and weight in kg column. So isLegendary column is again mapped onto the x-axis. It's just that here for the y-axis, we are mapping weight kg column. And this time it is very, very obvious that legendary Pokemons, their weight is much, much higher when compared to non-legendary Pokemons. I'll cut this out. I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now we can also go ahead and determine the color of these bars on the basis of a column, and we already know to do that we'll be using the hue aesthetic or the hue attribute, and I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary, this denotes all of those Pokemons which are legendary, and it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plot is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette, and we can directly use different predefined palettes. So first we have the blues D palette with a capital B. This is how it looks like. Then we have the rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute, and the first palette which I'll be using is blues D. And as you guys see, this is the blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these 2 bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between 2 numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up, then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis. So to x, I'll be using sepal dot length, and on the y-axis, I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got three different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got three different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add two more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis, and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital, and when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column, and you would see that we have three different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses, and for Virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram where it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the dimensions data frame. So we'll load up this dimensions data frame, we'll store it in this dimensions object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use Distplot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have dimensions of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head, and these are the different columns which are present. So I've got caret, which obviously tells us about the caret of the diamond. Then we've got the cut type of the diamond. We've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters. Y denotes the width of the diamond in millimeters, and Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot. And since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.distplot, and inside this I'll be passing in diamond. I'll have square braces over here. Inside this I'd have to pass in the column which is price, and I would just show this out. I'll have plt.show, and you would see that I have created this distribution plot over here. Now in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created, and to this, if I want to add color, I'll use this color attribute. I'll assign it red, and you would see that I have assigned it the red color. Now if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10. And I'm just setting the color to be equal to green. I'll select this over here. I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now, if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50, and as you guys see, I have only 50 bins. Now let's say instead of 50, maybe if I want only 10 bins, so you will see that I have only 10 bins. Now let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here. And here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now, if I hit on run, you would see that I have mapped this distribution plot onto the y-axis.
We have covered the essential Python libraries. To know more and deepen your understanding in Python, be sure to check out more videos on our channel and subscribe to stay updated. Now, let's focus on another critical aspect of data science: statistics. Understanding statistical methods is key to making sense of data and drawing meaningful insights. In this section, we'll introduce the basics of statistics, covering introductory concepts, descriptive statistics, and inferential statistics. We'll also learn important statistical techniques such as hypothesis testing and ANOVA. First off, statistics is the backbone of data science. It provides the theoretical foundation for understanding and analyzing data. Without a solid grasp of a statistical concept, data scientists can't effectively interpret the vast amount of data they work with every day. Statistics helps us make sense of raw data. It allows us to summarize data through measures like mean, median, and standard deviation, giving us a clearer picture of what the data is telling us. Imagine trying to understand a massive data set without being able to distill it into meaningful insights. Pretty tough, right? One of the primary roles of a data scientist is to make informed decisions based on data. Statistics provides the tool to test hypotheses, model data, and predict future trends. This is crucial for businesses that rely on data-driven decision-making to stay competitive. Data is inherently uncertain and incomplete. Statistics equips data scientists with techniques to handle this uncertainty, such as confidence interval and p-value. These tools help us understand the reliability of our result and make predictions with a known level of confidence. Machine learning, a key component of data science, heavily relies on statistical methods. Techniques like regression, classification, clustering, and Bayesian network are all grounded in statistical principles. Understanding statistics is essential for developing and tuning machine learning models. Let's look at some real-world applications. In healthcare, statistics is used to identify disease outbreaks and evaluate treatment effectiveness. In finance, it helps in risk assessment and fraud detection. In marketing, it enables customer segmentation and campaign effectiveness analysis. The list goes on and on.
So what are the various types of statistical analysis that you can go on to perform, or what are some of these various types of statistical analysis that you can use to solve a variety of problems? Well, there are two very popular ways of going to perform whenever you're going to perform statistical analysis, which is nothing but qualitative analysis and quantitative analysis. Now, for the people who are familiar with the term qualitative, for the people who are familiar with the term quantitative, you can find out what it means just by the words itself. Quantitative talks something about quantity. Qualitative talk something about quality, right? Let's talk about the example that you see on your screen right now. With respect to quantitative, let's close quantitative first so you will understand qualitative better. Now, if I say, hey, how many pens or pencils or whatever it is that you can see on your screen right now, what would be your answer, right? So there are 16 pens and pencils here. That's a quantity. Now, if I say, hey, why don't you pick up 3 pencils out of 16 pencils? Right? And analyze maybe if those pencils are right, correct or wrong or something, or if they have any manufacturing defects. All of these situations, you can have hundreds of situations, but you're performing analysis on a numerical metric directly. That is quantitative analysis, where quantity, where you're driven by a number as an input itself. But what about qualitative analysis? Now, qualitative analysis also you can do with respect to statistics. Let me give you an example. Let's just say there are 4 colors of different ink pens that you see on your screen right now. And maybe 2 of these are extremely expensive and they write beautifully. We know that pens that people used to write to put in a signature can sometimes get really expensive, right? It's made of silver, it's made of gold, and all of these different reasons. So maybe some of these pens write really well. So when you say it writes really well, what are we doing? What are we assessing and making a conclusion on? We are saying that, hey, this pen maybe is very smooth to write. Maybe the way it puts the ink down on the paper is very clean and you would like it. Correct? So you're assessing it based on quality. Now, quality, you might say, okay, so if we understand quality in terms of statistics, how can we put it in numbers? How did you put a TV show in terms of numbers? You had a rating to do it, where you had a range. In the range, you realize 0, it's very bad, 5 or 10 being amazing. Similarly, for qualitative analysis, even that example of TV shows is qualitative analysis. Here, what we are trying to do is we're trying to assess the same thing. If your pen is like very scratchy, it is tearing your pages, it is not depositing enough ink on your screen, you can say that, hey, the quality of this pen is bad. You've done this and you can say, if someone asks you, okay, so how bad is the quality? You'll say, on a scale of 1 to 5, I find it to be a 1. Right now, you have a metric to track quality, and with respect to quantitative, you have a metric directly to analyze. So either ways, either situations, logically speaking, you can convert and bring all these concepts right down to the fundamental level of mathematics and statistics. And don't you think with the details that you would have had at your hand at this moment of time, that if someone asks you which quality of pen should they buy, with your analysis here, don't you think you can give them a numerical answer? That is one very important thing you have to understand about the types of statistics that we have out there. Right? Now, we checked out with respect to qualitative and quantitative analysis, there are 2 more types. There are further divisions in the chart of types of statistical analysis, which is nothing but inferential statistics and nothing but descriptive statistics. Now, inferential statistics and descriptive statistics. As you know, the course is called Descriptive Statistics. So what are we trying to understand here? To understand descriptive statistics, you need to have a clear understanding of what inferential statistics is. Now, when you say inference, you're trying to infer something. What are you trying to do? You're trying to assess something, you're trying to assume something, or you're trying to infer something. Now, a simple example in inference is that, hey, right now in Bengaluru, that's where I'm from, it's actually very cloudy. It is super overcast right now. It's very dark in the afternoon, but I can infer something saying if this is the case for the next 30 minutes, maybe it will rain. Or I can say, sure that I see the darkest clouds in the sky right now, it will rain. So you're making an inference even before the situation occurs on the same lines of prediction, correct? That a concept around that is inferential statistics. Don't worry, we're going to take a look at it in detail. And then coming to descriptive statistics. Descriptive statistics is when you're trying to describe something on the fundamental level. What are you trying to describe? With respect to how one can go on to either describe and digress a problem, or how you can go on to explain a solution, or how you're working with your data. If you can describe that, either be it in a numerical way or in a logical way, that is descriptive statistics. So let's have some more clarity on these concepts. Let's try to understand, how we can go on to work with inferential statistics, what is descriptive statistics, and how we can work with that as well. So, to perform inferential statistics, you must understand one thing. Whenever you're trying to infer something, you will usually prefer, again, a sample space or a sample set from an entire population. In real world, even in small examples, while you guys are learning, you would have given 10 elements and you would have asked to analyze 2. What is that again? Population and sample set, right? So with respect to performing inferential statistics, I am not saying, hey, I can count 10 clouds in the sky. That is impossible. I can generalize and say there are a lot of clouds. And you might say, is this okay to say there is a lot of clouds when we are especially trying to infer something? It is okay, even though it's not a direct metric, having a generalization will still get you to your answer, right? Give it a thought. That exactly is inferential statistics. So let me give you a small example to help you understand. Now, if I say, hey, there is a sale going on, there are 18 sedans for sale, 4 SUVs for sale, super utility vehicles, and there are 3 convertible cars that are for sale. Now, if I ask you a question saying, in all of these sedans, SUVs, and convertible cars that are for sale right now, which is the major type of car that is being sold? Can you not answer that? Can't you just look at the data there and say, hey, so there are 4 SUVs, 3 convertibles, but 18 sedans being sold. So the number of sedans are the ones which are being sold the highest, right? They are the highest number of cars being sold, basically. So you can come to a numerical decision for a logical problem based on categorical data having numerical tracking. Right now, if you slowly rewind and listen to me one more time saying that, it will make complete sense to you all, but I'm sure it's a very simple example you can understand, right? Lot of cars, which type of car? You have a metric to answer, it's a direct pick and place. That when you're inferring something, when you're asking a question, which type of car sold the most, you're saying it's sedans. And when someone asks you, okay, how did you say that? Well, there's all the data in front of you to help you drive towards a decision. Every single step that we are just logically speaking out, or logically I'm explaining to you, there are numbers involved everywhere. And eventually these numbers, exactly as I've been telling, is what is driving the eventual solution. Don't you think? That is inferential statistics. Now coming to descriptive statistics. Descriptive statistics is exactly what all of us are after in this particular course. But one important thing for you to, if you just dive right into the concept of descriptive statistics, it becomes very difficult to assess and analyze later on. Because if you do not know what are the types of data, if you do not know that you have some real world connections to statistics that you have used, when you're working on real world data, it becomes super difficult for you to assess. Now, descriptive statistics is basically describing the data that we have at hand. Let us take this exact same example we discussed there. You have 18 sedans for sale, 4 SUVs for sale, and 3 convertible cars. Now, if I ask you a very specific question where your answer describes the entity in discussion, that is descriptive statistics, right? So if I say, hey, how many sedans that are being sold out of 18 are blue in color? So you'll maybe say, hey, there are 4 sedans that are blue in color that are being sold. You're describing not just a sedan, but the color of the sedan. And eventually you will say, okay, out of these 4 blue colored sedans, out of the 18 sedans, there are 4 blue and there are 5 sports models as well. Sportier versions, which maybe they go faster, or, they accelerate quicker, they have better performance, something like that. So can you or can you not describe the data that you have at hand, be it using numbers or be it using logic, in this situation as well? If it's a simple question of how many sedans, we answer it by making an inference. If I say, okay, so how many sedans of blue color, how many sedans which have 18-inch rims, something very specific, very detailed, which will have your answer to describe the entity in discussion. Ladies and gentlemen, that is descriptive statistics. Now we just took the entire complex world of descriptive statistics and understood it using a very simple example. Is descriptive statistics really this simple, or is it really this straightforward every single time? The answer is yes. The concept of how you apply statistics, the concept of how you describe something is going to remain the same. What becomes complex is the fact that you will have a lot of data that you have to use to get to this point. So it's never really as easy as looking at a crate, picking up 10 oranges from 100. What if you have 100 million oranges? What if you have the entire world's oranges in your farm right now, right? So when you think about situations like that, sometimes descriptive statistics will work in your favor, but sometimes to go on to perform the process itself, it can get cumbersome. So how do we solve this problem? How do we find ways through which we can measure so many things? Maybe you want to measure something in terms of accuracy. Maybe you want to have a metric that will just describe the data, which if you just look at your screen right now, 18 sedans, 4 SUVs, 3 convertible cars, you can probably find out the total number of cars that are sold. You can find the colors of the cars, types of cars, and all of that, right? Now, if I ask you a question, what is the average number of cars that was sold? Do you have data ready on your screen to tell you that? No, you have to perform some calculations based on the data at hand to give you that answer. What is the average number of cars that were sold? What is the minimum number of cars that were sold? What is the maximum number of cars that were sold? You're getting this right. You still have to describe the aspect of using the concept of statistics, but in this particular case wherein you will have to perform some operation to give you the description that you require, that is where we have a lot of measures that come into the picture. Measures of central tendency, measures of accuracy, measures of variability. All of these things are at the heart of statistics to a point where you will completely assess and analyze and come to your answer through certain operations powered by your data. And that is exactly what we are going to check out from this section till the end of this particular course. We're going to start this out by understanding something, a concept called as measures of central tendency. Now, if you have come from technical learning platform, or if you've come from maybe a mathematical education from your school or college or something, I can promise you that you've used central tendency, you have learned about it, and you never knew that it is called central tendency as such. Or you would have used this in real life as well, right? So if I say, hey, there are 10 apples in front of you, 3 of them are bad, 4 of them are very good, and maybe 2-3 of them can never be sold, something like that. If I say, what is the average number of apples that can be sold? You can just say 7 out of 10, 6 out of 10. So you have an average number to give me, right? So those are some numbers which are describing the data which you cannot find out looking at it through the naked eye directly, right? So certain numbers, mathematical operations describing the data. I am sure now that you looked at your screen, you can understand that there are 3 measures that we use to describe the data with respect to central tendency, which is the mean, which is the median, and which is the mode, right? Now that you know it, I'm sure you can guess what all of them mean. But for the people who have never worked on statistics, mean basically represents an average value in the entire data set. Now, what about median, if that's the case? Median talks about a middle value. Now, if I just give you 10 different cars, maybe in the order of 1 car being new, slightly used, very much used for 10 lakh kilometers, something like that, there is an order to it, right? You're ordering it based on the number of kilometers that the car has been driven for. In that particular case, if I say find the one in the middle spot, I don't want a car which is brand new. I don't want a car which has been used to a very good extent. I want something in the middle, right? I want something around the approximate, around the average. People usually use these terms in real world in conversation. Now, if you do not pay attention to this word which says ordered data set, because if I just give you these 10 cars in random order and say pick the middle one, do you still think the middle one is going to give you a clarity about it being the midpoint there? No. You might have the car which is brand new to be sitting in the middle spot just because your data is not ordered. So whenever you're trying to find and work on the median of it, you are going to require some ordering. Now you might say, if I require that for median, do I require it for mean? Absolutely not. Why? Because when you're performing an average operation, regardless of the order you put all the elements, add it up and divide it by the total, it will still remain the same. 2 plus 3 by 2 is still same as 3 plus 2 by 2. Think about it, right? So mean, you just require the data. You don't require any ordering. Median, you require the ordered data set. So what about mode then? Mode basically is giving you some sort of clarity about how many times a certain number is occurring, right? So if there are 10 elements, if I just give you numbers from 1 to 10, if it is in an order, fine, you can find the median. If it is not in an order also, you can find the mean. Now, if I say find the mode will be basically an entity, an element in discussion which is repeated the maximum number of times. Right? So I hope we are clear with this. So let's actually dive right into small examples to take a look at mean, take a look at median, and take a look at mode. Alright guys, So to talk to you about the measures of central tendency, the first one on our list is mean. Now I already told you that mean is a very simple calculation of an average, right? Now look at all the data elements that are present on your screen. We have 100, 150, 200, 380, 450. So you see that there's no order that you see on your screen, right? There's no ascending order, there's no descending order. Can we still find the mean? Of course we can, because regardless of you adding it in any order, it's still going to give you the same result. So how do we find the mean? Take all the data elements and add each and every one of the entities that are present there. Once you want to add all of them, divide them by the total number of elements. Now in this particular case, you'll see that there are 10 elements. So we're going to add each of those values divided by 10, and this is the average value, 238. Now it's a very simple thing. If you guys have watched cricket or if you watched football or something, they have told you the average runs scored by the team. You know, what is the batting average, bowling average, all of that, right? So how do they even find that? They just take a lot of data from the game in any order and eventually give you this thing, right? It's very simple, yet it is one of the most powerful concepts that governs the world of descriptive statistics. So if I just look at the data, don't look at the mean part, just look at the data. If you just look at it, if I ask you what is the average, without any calculation, can you give me the answer? No, you'll have to perform some calculations either in your head or on the paper, right? That is where these measures that you directly cannot see, but yet once you start finding them, they will give you so much more insight about the data. They'll help you describe the data better, right? That is descriptive statistic. Coming to the median now. Median, I told you, you really have to have ordered elements, right? Without an order, finding a median is meaningless, because if your values are jumbled, you're not trying to find any structure in that information. So the first one that you see here is our original list of elements. It is as we saw in the mean case. Now what we've done is I've rearranged the data in the ascending order for you guys. Now you'll see that the numbers are continuously increasing from left to right. So if that is the case, if I say, hey, find me the median of the data. Now here is one case where people might get confused. Okay, so if I'm just looking at 10 elements, which is the middle element? There is no middle element in 10, right? There never can be. If you have even numbers, the middle one is, you can never have one. It will be either 2 or it's none, right? Similarly, when someone asks you to find median for a data which has even number of elements, just find the middle 2 elements, take the average of that. Here it will work because the data is arranged. Here it will also work because you're just finding what exists between these 2 points. Now if I do 150 plus 100 by 2, it is nothing but 250 by 2, which is 125. So if there were a median in this particular case, it would have been 125. This is a complex case. However, there can be a simple case where you have odd number of elements. If you have odd number of elements, you can find the middle one easily, right? Look at this. If there are 9 elements, there are 4 on the left, 1 in the middle, 4 on the right. So the median is very straightforward. Just pick up the number 100 and eventually put it out there. You don't have to perform averages. You don't have to find the mean of the middle elements to find the median. Right? I hope this concept is clear. Now, we're done with mean, we're done with median. What about mode? For mode, it is very different from all the other types of data, because here you really do not require any sort of order. You do not require any sort of meaningful metric to actually find it. All you have to do is look at the frequency of occurrence. Here, look at this. If I say mode is 150, it means that 150 is the most occurring element out there, right? Look at this, 150, 100, 200, 150. This 150 is the one which has been repeated most of the times. As simple and straightforward as that. This eventually has to be the mode. Now, where would you use mode? Right? If I tell you, hey, there are 5 oranges, pick up 4 oranges which are ripe. The logical understanding is they are ripe, but you're trying to pick the most number of one. Even if I don't tell you pick up 5 oranges, if I tell you there's probably unripe mangoes or something which is green in color, there are ripe mangoes which are yellow in color. If I just say pick up all the ripe mangoes, you'll find the ones which are yellow color, find the maximum number of yellow colored mangoes and pick it up. Simple, right? You have used mode everywhere. You have used mean everywhere. You have used median everywhere. Just the fact that you might not know that it has this kind of a statistical value is what the bridge we are trying to gap here, right? The other thing that you have to understand is that it is not just mean, median, and mode which governs the world of descriptive statistics. It is a lot more from that. In fact, we have something called as measures of variability. What do you mean by variability? Something that varies. Can you track something that varies? The first thought that might have come to your head right now is, no, we cannot track something that varies. Well, when you say something is varying, you have a range of data to tell you that it is in between this range that it is varying, right? Now think about the concept of it raining tomorrow. If I say there's a 30% probability or there's a 30% chance that it might rain tomorrow, that 30% is basically a number between 0 and 100%, correct? So I have a range. So the data points there can vary enough to still give you a metric output, right? Now, when we have to showcase a range of data, when we have to have a measure which will govern part of the data in the range, well, that is when we go on to take a look at variability. In variability, there are three things you have to learn with respect to descriptive statistics, which is range, variance, and standard deviation. Let's take a look at range first. When someone says, find me the range of the data that is present there, or find me the range of the car that you're trying to take a look at, what is the range that you're trying to look at when you're purchasing something? You would have heard this term at the shopkeepers a lot, right? Maybe when you're in a market, whenever you're buying a new car or a bike, they say, what's your range? What range are you looking at? So that term gets thrown around like confetti, but at the end of the day, range, when you have to calculate it, is a very simple calculation between the highest value subtracted it with the lowest value. So the highest value minus the lowest value will give you the range. In this particular example that we have, regardless of what value will repeat how many times, all of that we don't care. All we try to look at is find the maximum value, find the minimum value. Max minus minimum, that is your range. So a range will tell you the difference of how your data will actually vary with respect to data points. Now, if your data can talk about its variability just with the fact of finding minimum and maximum, can we dive into the depth and try to understand how your data is spread across in a range? That is where a concept called as variance, that is where a concept called as standard deviation comes into the picture. I am sure if you have learnt mathematics in school or college, you would have come across these terms and you would have solved examples on these as well, right? So what is variance? Variance is basically a concept which will talk about how your data is spread compared to what. When you say spread, you can, if I just say, hey, spread these oranges around, you can throw it in your farm. You can keep one orange in India, one orange in America. There's no range. If there's no bound, you can never say that the spread is valid, right? So to keep the spread valid, we have a range of data, and eventually what are we comparing the spread to? In the case of variance, we're basically comparing that to the mean of the data point. Now we calculated the mean for this entire particular data to be 238.6 previously. So how do we find the variance with respect to each data point to the mean? Well, it's nothing but a very simple operation of squaring the differences between mean and each of the value. So you have mean value, you have one mean value, you have multiple values. All you have to do is find the difference between the mean and each of the value, square it up, find the average of the entire thing, and that will give you the value of variance. In this particular case, you can see that the variance value is somewhere around 67,321. How did we get to that? Let me quickly repeat. Find the mean of the entire data set first, find the difference between mean and each and every one of those data sets, and eventually have the average, square that entire number. That is what will give you your variance. If that is how you find variance, then how do you change? How do you understand with respect to your mean value? How do you figure out this is how my data is spread? Data spread can be figured out by something called as standard deviation. How does your data deviate with respect to its each point with respect to the mean? That is standard deviation at simplest form. Now it's very simple and straightforward, guys. If you have found variance, Just take a square root of that variance value, and eventually if you take the square root of 67,321.8, it is giving us somewhere around 259.4. So we're trying to say that, hey, this is how much the spread of the data is, and this is the range through which the data is spread whenever you've compared it to the particular mean. Right? So guys, with this we are clear with mean, we are clear with a median, we are clear with mode. That was central tendency. Now with respect to measure of variability, we understood how we can calculate range, we understood how we can work with variance, and once we understood variance, take a square root of it, it's standard deviation. But why the square root, or why taking the square root will give you what, is exactly what we actually figured out. Correct? Fantastic. Now after measures of variability, you will also have to take a look at understanding, hey, with respect to data, can we measure relationships, right? Now, think strictly in the term of numbers here, guys, because whenever you're trying to understand relationships that exist in between two data points, you can have two concepts here, right? Anytime you have an interdependency of values, it can be on the range of covariance and it can be on the range of correlation. So what is covariance? What is correlation? The concept of covariance is very simple. Here, what we're trying to do is, instead of comparing two direct values, we're just comparing and denoting the variance that exists between 2 points. And when I say two, in real world, it is never two. You can have any number of data points and you can find the covariance there. Right? Now, there is something called as positive covariance and there's something called as negative covariance. Positive covariance is when, there are all the elements that are in comparison is moving across the same vector, same plane, same direction. Okay, so can you give an example? If your engine rotates in the first gear, your engine rotation, and there's a very good chance the way your car moves is still going to be the same direction, right? So there's a positive covariance there. Now, if you use a lot of gearing, of course, there's a lot of gears used in your car, and it is not just that it will only go in the forward direction. You can put it to a reverse gear, even though your engine is running at the same speed, even though your engine is running in the same direction, those gears will make it run in an opposite fashion, right? So if your engine is still rotating forward, but your car is moving backwards, that is because there is a negative covariance that is put into there, right? It is negative if either of your data points move in a different direction. Numerically, if you have something that's going on the positive side and eventually the result of those positive numbers are decreasing negative numbers or something, that is nothing but covariance. You should be asking a question right now. We understood positive covariance, we understood negative covariance. What about zero? Well, if your data elements are zero, it means you cannot have anything to compare to that particular point in the example that we just spoke about, right? If all of your data elements, if you have 10 zeros, if I say find the covariance of all of these, nothing is varying for you to find a distance. If one point is zero, everything that has to do something with zero is going to remain zero. 0 multiplied with 0 is 0, 0 plus 0 is 0. So covariance will not exist in that particular case, right? So I hope we are clear with covariance. Now that we're done with covariance, the next thing that we're going to have to take a look at is correlation. How can we denote some relationship that exists, not just in terms of how it varies, but what it is in its most basic form is nothing but correlation. I'll give you a very simple example to explain correlation. Now, when I say, hey, I've been eating a lot of sugar, I've been eating a lot of unhealthy food, lot of cheese, and I'm not doing any sort of exercise, there is a good chance that there can be an onset of diabetes. As per age, if your age keeps going up, there is a certain chance you can still get diabetes, correct? So there is a correlation between age. Age is related to diabetes. Then if I say there is blood pressure also has an impact. If you are a person who has a normal blood pressure, maybe it has nothing to do with diabetes. But if you're a person who has high blood pressure, based on all the medical reports out there, your doctor might say, hey, your blood pressure is high and this is what is causing diabetes for you. You just heard the statement. You have high blood pressure. This is what is causing your diabetes. So you found out a cause through a point by having a relationship interlinking these two concepts, right? That is basically this. So with respect to bringing all of it in the terms of numbers, we will have a range of values through which we are worked with. So if I say that, hey, there is a correlation of 0.9 in between age and in between diabetes, it means that your age is very, very closely linked on how much impact it can have on diabetes. If I say your age has 0.1 correlation with respect to diabetes, it means that, hey, age has very tiny amount of factor or tiny amount of say in how you would get diabetes, right? Very simple to understand. Now you must be asking one more question. Okay, so we just spoke about 0 to positive numbers. What about negative correlation? Negative correlation also exists. You've been using it all your life. You just go to the nearest petrol bunk, you just get a full tank of petrol. Now, as in when your distance you travel on your bike or your car increases, the amount of fuel decreases. So what is the relationship? There's an inverse relationship. More the distance you go, more the fuel, of course, it takes. But if you're talking about quantity of fuel versus distance covered, the more distance you cover, the quantity of fuel will be coming down in your fuel tanks, right? Very simple case. This is how mileage is also calculated when you think about it. Every time you try to assess and analyze a real world situation, next time do this. Try to assess in a way of how you can statistically figure something out, because once you can go on to do that, you will figure out a lot about your data, which you can say initially this would have never been possible. Now that we're done with the measure of relationships, the next thing that we're going to take a look at is the measure of skewness. Now, when I say something is skewed, what do I mean? Skewness is basically talking about how unsymmetric a data point can get with respect to some position, right? Now, let me explain with the example that you see on your screen right now. There's something called as normal distribution. So once you plot a curve for a normal distribution, your data will be distributed equally to the left of the mean and to the right of the mean, as you can see. This is symmetrical data. In symmetrical data, your mean, your median, and your mode is going to remain the exact same thing, because your mean is the average of data, your median is the middle point, and your mode talks about the maximum occurrence. In this particular graph, you will see that all of those points will be right here in the middle. When that is the case, it is nothing but no data which is not skewed. Of course, in the real world, this never is the case. There is going to be either some change in the positive or the negative direction. So to understand that, what we are trying to assess here is what level of asymmetry is basically present in the data around us. So there is negative skewness and there is positive skewness. Remember, this is a very important point in discussion, because with respect to negative, with respect to negatively skewed data, your mean will always be less than the median, and your median will always be less than the mode, right? So quickly going back, it should show you that the points to the right of the data will have higher values than the points to the left of your data. If that is the case, it is nothing but negatively skewed data. If we have positively skewed data, it is different. Here, the least value is going to be your mode, your maximum value is going to be the mean. Because why? If it is positively skewed, there is more data to the right side of your mean, correct? Look at that. In this particular case, if your mode is less than median, which is less than the mean, look at the shape of the curve here. You will understand where the mode is, where the median of the data lies. This is the midpoint of the data, mind you. Again, in the midpoint of the data, if you take a look at the curve, everything left of the curve has more data to assess and analyze, while to the right of the median, there isn't, right? So guys, this is skewness. When your mean is less than your median, which is less than your mode, it is negatively skewed data. When you have your mode less than your median, less than your mean, that is positively skewed data. Now, I know it can be very difficult for you guys to assess and analyze this. That is the reason I have this diagram. Take a note of it, and importantly, take a look at understanding why it is the case. I just explained negatively skewed and positively skewed, and I told you why it happens, right? Take a note of that, and especially this part, right? Mean less than median less than mode, or mode less than median less than mean. This is super important, guys. So make sure you're taking a look at all of that.
What is analysis of variance? Now, ladies and gentlemen, I want to have one of these concepts really clear with all of you all. Now, throughout the course out here, I might be calling analysis of variance as ANOVA, A-N-O-V-A, ANOVA, right? ANOVA and analysis of variance, as you figured out right now, is exactly the same thing. So what is this concept that we are taking a look at? And the most important question is, why is it so relevant that you have to know all of these concepts, right? Well, let's take an example approach to help you understand the concept. First of all, let's just say that you are, you're a businessman and you're willing to get your cars painted. Let's just say you have 3 old cars. Think about it to be maybe repainting or maybe polishing, or any of these activities will make sense. So you're a businessman, you're always in a suit, you're in a tuxedo, you want to look great, and you want to walk out of a car which eventually looks great as well, right? You don't want to be the most fancy looking businessman coming out of a car which looks pretty dirty, right? It won't add to your maybe image or whatever it is. So what you say is, hey, I have 3 old cars, I want them repainted or I want them repolished or something like that. And the key highlight here is that you're a businessman. So once you're a businessman, you want your cars at the earliest, right? You cannot be left stranded without a car, nor when you're a very high standard, when you're in a very high position, people usually rarely take taxis out to their work. Common assumption. Or let's just say in a hypothetical example such as this. Now, what would you do in this situation if you want all 3 of your cars to be ready, and if you want it quicker, you will just prefer a painter or a polisher who will do the job really quickly and who will do it better, right? So among these 3 cars that are being painted, maybe the one you'll really like is the one that gets painted quicker, the one that has a job which is really well done. Again, common sense, right? Now, what if your car, out of these 3 cars, let's just say one car is actually really good. It probably doesn't require repainting or repolishing or anything. It just requires a good wash and then a detailing job or something like that, right? It doesn't take a lot of work. Let's just say that. And there's another car which you've probably used daily for the last 2 years. It has never seen water. It has never seen, it has never been cleaned basically. So that car will take a lot more amount of time and work to actually bring it back to its original glory. Now, here is where the question lies in. One of these painters would have taken less time to probably do the same job, but another painter would have to take a lot of, basically take more time, because at the end of the day, his or her car might require a lot more work. Now, when you try to generalize and say, hey, I gave 3 of my cars to be painted or to be polished or something, and when I got it back, one of the cars came really quick, but the other one took a really long time. So when you tend to analyze a situation such as this, when you ask, okay, why did this happen? Why did one of the cars come out really quickly while the other car was stuck in the paint shop for a really long time? Can you just say that all 3 painters had the same effort put in? That would be slightly difficult, right? Because one car did not take so much effort. Maybe the middle car took a good amount of effort, but the other car, you drove it daily. It was an absolute horrible shape that needed a lot of fixing. Now, that guy, the third guy, would have worked a lot more probably than the first guy, right? It's a common assumption. We can assume that. But what happens is that when you have to make a decision, when you have to say maybe which of those painters you would like to go back to for the next time, for the, let's just say polishing or something, that you want to go back to them, you want to make a reliable decision. You don't want any guesswork. And of course, if you don't want any guesswork to understand the concept, what are you going to do? You're going to require some evidence to support saying this painter was better than that one. Guess what technique is used in a situation exactly such as this, right? So whenever we talk about ANOVA, analysis of variance is a really, really popular technique that will help in making these critical decisions which are important. Now, I might have given you an example which does not highlight the importance of ANOVA, but at the end of the day, this is a concept that is used, I want to say, by almost every single company that exists out there who are trying to analyze something, right? Because ANOVA is a concept that will help you take a data-driven decisions. And when I say data-driven decisions, you have to understand that you're no longer guessing. You're no longer saying, I think this might happen. You will say, hey, I know this will happen because I have the data to prove that that will happen. Now, if you were on the other side of the conversation, what would you like to hear? Do you want to hear that I just guessed out what might happen to an analysis, or I come with proof and I come with some data to say, hey, I know what will happen and here is concrete evidence of what's happening, so you can use it to take your decisions? Which would you prefer? Especially if it's a very, very important decision at a really high managerial post or something. Of course, you'll go with the person who brings data, who brings proof, who brings validation, who brings evidence. Correct? Now, to get to that point, to eventually make that decision, to analyze what went wrong, what was correct, and to have a structured, unbiased, and almost unbiased approach of how to get this done, ANOVA is really, really popular for this. Now, it's one of these statistical techniques that usually trumps a lot of other techniques that we have out there, because whenever you're trying to compare something, you usually break it down into its simplest terms, right? If you're trying to compare fruits, you'll compare an apple to an orange. So you have to pick up individual entities to compare. But in ANOVA, the biggest advantage is that here you have a technique that will help you assess and analyze multiple groups of data at a time, right? Now, there are multiple groups of data, meaning it'll have its own averages, it'll have its own mean, median, mode values and everything. And when you say that something is varying there, all you're trying to do is you're trying to have a fixed point. In many of these cases, it's usually the average or the mean. And all you're going to do is you're going to take that mean and eventually find out what are the difference between a group which has one set of mean values and maybe another group which has another set of mean values, right? This technique, once you start applying and find out what is the average time or something that took for these maybe painters to work on your car, you will get to find out at the end of it with concrete evidence to say that one of the painters actually had an advantage to begin with, right? And if all three of them were maybe provided an equal car, then too you would find some difference in maybe human error or the way the painters would work or something like that. But at the end of the day, you think that there's an equal chance at completion of task. But once you perform analysis, you will understand to a good amount of depth that one guy took a lot more work, took a lot more time to do it because there was a lot more work, and the other person might have not taken it, right? Now, this works exactly similarly when you think about it in the IT industry as well. When you have a huge team working on common operations and you want to have a threshold, you want to understand if your team is slacking off or if they are working at their best performance, you can use the concept of ANOVA to actually analyze a lot of things that they're doing to see if everything is on track, to see if somewhere is lagging behind, or in a very rare case to see if you're ahead of your schedule as well, right? Now with these many points that I have mentioned, I am very sure you have a clarity about what ANOVA is, and it's not just about what ANOVA is, but how important it is, right? Right from maybe you having your car painted all the way to the executive decisions that happen in Fortune 500 companies, everywhere ANOVA is super popular. And while you're watching this course, I can bet to say that there is someone out there right now. In fact, there'll be multiple people out there right now who are using these concepts as we speak as well, right? So it's really important for you to understand that. Now, for some of you all who might have not gotten full clarity, let me give you some more examples so that you can relate to the concept better. Now, let's just say that there are students from multiple colleges taking the same examination. It happens if you're a part of a common university, right? Now, there's many universities here in India. A popular one in South India is VTU. It's called Vishweshwaraya Technological University. Now, based on those universities' norms and all of that, there are colleges which link themselves and associate with respect to that university. So all these people who are a part of those many colleges, at the end of the day, will be taking the same examination that is set by the university. Now, here you can actually use ANOVA in a very interesting way. Here you can actually use ANOVA. Since the tests are the exact same thing, you can directly take a look at comparing colleges and to see which college maybe performed better than the other one, right? How amazing is that? It sounds like a very simple concept, but when you actually see the data and when you have to get to do it, it can be seen as a complex task. But with the help of ANOVA, you can simplify it to a good amount of extent, right? How cool is that? And then let me give you one more example. Let's just say that you're starting a farming business or any other business, and now you want to understand what processes should you do to have a better yield compared to the other. Maybe should you set up rainwater harvesting, or maybe do you have to change the way you put fertilizers in your field? Maybe you have to start moving around soil. So there are so many processes, right? Now, I'm not a farmer. I have no idea about this business, but I am very, very sure there's a million different things which will have a huge play in the outcome, right? You know what happens, right? If there's a drought and if the rain is delayed by a couple of days, the crops vanish. It's all a waste of time. So it is very important for you to analyze all of this in depth to make sure that you're getting ahead of your business everywhere, right? So it's really, really critical to understand this. Now, let me give you one more interesting example. let's just say that there is a person who is diabetic, right? And there are 3-4 various treatments that has been suggested from various doctors. One doctor says, hey, why don't you try Ayurveda? The other doctor says, hey, why don't you try some of these hardcore medications that have worked previously, or something like that, right? There's a lot of doctors giving you a lot of opinions. One other doctor would say, hey, why don't you just get up and start walking or something, or be more active? That way you can have all of your parameters under control. Now, if you are on the other side, and if you're a very interesting data analyst, what you can basically do is find out which doctor has given you really good advice. Now, no offense to all the doctors that are out there. It's just the fact that you can have a chance to track these metrics and you can understand for yourself which process might work better. I'm not saying you're comparing doctors to find out which one is better, but what treatment works better for you is the discussion here. And that you can easily find out with the help of analysis of variance, right? Now you can see this, right? You might have thought about a situation where analysis might not be required, or you might thought of a situation where ANOVA might not have such levels of importance, but when you actually get down to it, you realize that it definitely has a lot more impact than you might have initially thought about, right? So let's talk a little bit about what is required to understanding ANOVA. Now, as I just told you, ANOVA is a really popular concept in statistics. So of course, you have to have a basic understanding of statistics. You need to understand how the world of statistics works. And more importantly, no one is going to ask you a question saying, hey, prove this theorem or prove how this works. What knowledge you require is for a fact that you need to know how to apply these concepts to get there, right? And then understanding measures of central tendency. Measures of central tendency sounds like a very complex concept, but at the end of the day, it's mean, median, and mode. You've studied all of these in primary school, I'm very, very sure, or if not in college as well. But knowing how mean, median, and mode works is very, very important, because once you understand mean, median, and mode, then comes variance, then comes standard deviation, and all of those concepts, right? It's built on top of each other, so it's very important for you to know. And then basics of hypothesis testing. Yes, hypothesis testing is also very, very important, because when you're trying to assess and analyze multiple variables, and usually when you do it at the same time, things can get a lot confusing. So you usually, when you're working towards a solution, you start out with certain assumptions in your head, a hypothesis, let's just say, right? So you're going to require some understanding of that. And don't worry, we'll have a section where we'll have a quick look at understanding hypothesis testing. And of course, once you know statistics, once you know how to apply these concepts, and once you know how to prove everything on paper, what is the next thing that you want to do? The next thing is you want to translate all of your results to make sure you can use the power of your computing to maybe have a widespread impact of the solution as well, right? So of course, taking your own data analysis knowledge and putting it into code, either in the form of Python, or we have another brilliant tool, Microsoft Excel. Now, Microsoft Excel is absolutely brilliant, yet at the same time, not a lot of people use all of its capabilities. So it is usually put on the back burner, and people say, hey, Excel is only for workbooks. Not really. Excel is a very, very, very in-depth data analysis tool. If you know how to work with 100% of Excel, trust me, you can call yourself a data analyst, because there are so many things that Excel offers us, just that the widespread population probably, in my opinion, uses 20 or 30% of what the entire tool offers. So if you master those extra 60-70%, trust me, it's actually a very powerful tool. Of course, there are better tools for analysis, there are better tools for business intelligence and whatnot, but you cannot state for a fact that Excel is not powerful, right? So having the knowledge of all of these is very, very important for ANOVA. Well, with that, we are done with our first section. Now, coming on to a section where we're discussing some of the really important terminologies in ANOVA. Now, look at these terminologies that you see on your screen, because I am sure that there might have been a point where you're probably learning ANOVA on your own, that you've seen these terms and it is very difficult to make sense out of them. What does a grand mean mean? I mean, you would have just learned what a mean is right now, and now someone's asking you what a grand mean is. There's something called group variability. There's something called F ratio. All of these, as a beginner, even if I were to look at it for the first time in my life, I would be pretty confused, right? Now, I've been doing this for like many years, and I still remember the day I would have been taken aback by looking at these terms. And to make sure it doesn't happen to you guys, here is what grand mean means. Grand mean, basically, right? Let's just come back to the basic definition of what a mean is. Mean stands for average, right? We know that if you have 10 numbers, if you want to find the average of 10 numbers, what do? You add all of those 10 numbers, you will get the sum of it, and you will divide all of it by the number of elements. In this case, it's 10. right? You know how to calculate an average, you know how to calculate a mean. But in the world of ANOVA, we have two popular means. It's not just one mean that we say average, you're done. No, here we have two means. One is called the separate mean. The other one is called the grand mean. Now, a separate mean is basically you taking the mean, you taking the average of certain sample units that you have in consideration. 90% of the time, you have a huge data set. What you're going to do is from that population, you pick up sample sets, right? You pick up small amounts of data on which you perform analysis. If you perform analysis in a correct way, you can sort of say that, hey, if it works on this sample population, if it works on this sample set, it might work for the population as well, right? So a separate mean is when you find mean for each of these individual units or each of these groups of data that you are interested in. But what about a grand mean? Well, think about it like a grand finale, right? What happens in a grand mean is that when you have multiple individual means which are already there because you calculated it manually and you have like 100 different means right now from your data point, you take all those 100 means and you can take the mean of those means, right? Mean of all means is basically the grand mean. You take each of those means, add all of them up, divided by the total number of means that you just handled, and what you have at hand. What you have at hand right now is the grand mean, right? It is basically the mean. It's basically the average of all other averages that you have observed, and you've basically taken like a lot of averages, combined it into one big number and one big average, and that average is called as the grand mean, right? So that literally is what grand mean is, and it's as simple as that. Next, let's take a look at between group variability. Now, let's just say that we have certain sample data and we have multiple overlapping points, right? Now, if you have certain sample data where the data elements are literally around one single point or around 2-3 different points, when you try to find an average, you'll realize that the average of each of those points will not differ by much because all of those are like clustered onto one single surface, or it's clustered into one simple set of group that eventually will not let you have multiple means. That's the first thing that you have to understand. So finding your sample means or finding even something such as a grand mean will not make sense, because if all your sample means are similar, your grand mean will be one big number, which is again pretty similar. So it will not give you the in-depth clarity that you require. So what you do then is you chuck away the simple mean, you chuck away the grand mean, and here you understand the variation that occurs in between these points where there is overlapping occurring, right? As I told you, there's a couple of data points here, there's a couple of data points. In this case, they are overlapping. What you do is you try to find the variation that exists between those points which are overlapping. The overlap is your problem, right? That's where all the confusion started. But what you can do is find how different is each element in that particular region where it's overlapping. And again, a concept of standard deviation, how far away is your point from a mean or from a variance, something like that, is what will give you complete clarity, right? You take a sum of squares and you eventually work on it to you go from variance eventually to standard deviation. Standard deviation and variance are just one square root away. I'm sure you might know the formula already, but knowing that wherever there is overlap and the variation in the mean that happens at that overlap, that point is called as between group variability, because two different groups overlap. You try to find out what's overlapping, find the variability in the overlap, you're good to go. That again, as I just told you in the last 5 minutes, is between group variability. So the next time you see this term, I am confident that you will know what it means, right? Fantastic. The next important terminology that you really have to know about is something called as the F ratio. Now, F ratio is basically a measure that we have, which is a very interesting measure, because here what we're trying to do is we're trying to check if all the means of multiple samples are significantly different to one another. Now, if you have multiple means from multiple samples and you want to understand if there is a huge difference that exists between these 2 points or multiple different means out there, F ratio is a number that's going to tell you how different is your mean from each other. Now, if this ratio, it's a ratio, right? If this ratio is actually lower, it means that your sample means, the samples that you have taken from multiple points, are pretty similar. But what happens when your ratio is high? You can pretty much take a guess, right? But again, when the ratio is low, it's very important for you to know that there is one concept called null hypothesis, which you cannot reject. It cannot be rejected at this moment of time. I know some of you all might not know what null hypothesis is. Just hold your thought for a second, because we're going to be discussing that as well. But know this at the moment. If your F ratio is low, it is vital for you to understand that your null hypothesis cannot be rejected. right? And the F ratio basically uses the measures of between group variance, and there's another concept called as within group variance. These two concepts are very, very important to understand how the F ratio works as well. Now, we checked out one of these measures between group variance. There's another measure that you can go about understanding now that you already know between group variance, which is basically within group variance, right? So it's pretty similar, yet it's radically different. And I want you guys to spend some time understanding what it is and how that has an impact for your F ratio, right? Fantastic. Now, we understood that the F ratio has a certain say to, to basically be dependent on the world of hypothesis testing. So what is so important here that you have to know in hypothesis testing, without which it would become difficult for you to understand ANOVA? Well, the first thing that I'm going to tell all of you all is that hypothesis testing is not just an important part of ANOVA, but it is actually a very critical part of applied statistics in itself, right? So what is hypothesis testing to begin with? Well, hypothesis testing is one of the part of statistics where you try to make an assumption. You make assumptions even before you start working on a solution, and you have a very structured set procedure in hand that will help you test your assumption to see if your initial assumption that you might have made is either correct or is incorrect. If your initial assumption is correct, you say, hey, I accept the hypothesis. But if your initial assumption was something very wrong, and you can later prove it with respect to data to say you were wrong, there's absolutely, you reject your own initial assumption, right? Because whatever you assumed were wrong. How do you know that? You now have the proof. You now have the data to actually tell you that you were initially wrong, right? That is very simply what a hypothesis is. But in hypothesis, when we try to apply hypothesis, again, there's two types of hypothesis you really should know about. One of the terms you just heard in the previous slide, null hypothesis, and there's another term called alternate hypothesis. Well, what are these terms? Let me give you an example to actually explain the situation. We all know our solar system, right? We all know our solar system, and we know that we have a very nice planet at the end of the solar system. It's called Pluto. Now, some of you all are saying, oh, Pluto is not a planet. Now, some of you all are saying Pluto is a planet. Well, what's the actual deal? Well, when probably people were trying to analyze, when astrophysicists were trying to understand if Pluto was a planet or not, initially they would have assumed something. They would have said, hey, if a celestial body has so and so size, so and so shape, and maybe it has this many diameters worth in so many thousands of kilometers or something like that, that's when they say that this is basically called a planet. Starting, if you remember, when we were kids, probably a couple of decades ago, they would have taught you that Pluto is a planet in the solar system. And then there were a couple of discussions to say, oh no, Pluto doesn't meet certain requirements to be able to call it a planet. So we won't call it a planet anymore, right? There's a lot of confusion. So you can see that the initial hypothesis, the null hypothesis, was that you would say that, hey, I begin by saying Pluto is a planet. It's called H0, or it's called null hypothesis. And then there's an alternative hypothesis. This is not you just basically telling something out. This is not you just taking a chance. This is you knowing that your alternate hypothesis will probably be affected by some other situation, by an external factor. So you cannot guess anything in the alternate hypothesis. Your null hypothesis, yes, you can guess and try to prove if your guess is right or wrong, but your alternative hypothesis is used, and you know for a fact that anything that you change might have a say in your result, right? So basically it's denoted by H1 or HA or something like that. So these two concepts, null hypothesis and alternate hypothesis, always take the center stage whenever you are trying to understand anything related to hypothesis testing. Now there's many other metric, F score, T score, so many scores and so many tests which will tell you if you should reject the null hypothesis or not. And we know for a fact that if the F ratio is less, let me quickly go back to that slide. As you can see, we know if the F ratio is low, it basically means that null hypothesis cannot be rejected. Now, one more thing you have to understand about hypothesis testing is you don't say we accept the hypothesis, you just reject the other one out for some reason. That's the colloquial term you would go about using. Now, you might be a person who's saying that, hey, the process to determine whether you have to reject a hypothesis or maybe to fail to even reject the null hypothesis what is this process called? The process where you reject the hypothesis and have a conclusion at hand is basically everything called hypothesis testing. It involves 4 important steps, as you can see from your screen right now. And the first step in any hypothesis testing for any solution out there in the entire world is for you to define what a null hypothesis is and for you to define what the alternate hypothesis is. Because once you understand and figure out these concepts and you define them, that is how later you can have a plan. That's step number 2. Step number 2 basically talks about you having an analysis plan for you to use sample data to find out if your null hypothesis is right or wrong. Once you do that, you come to the third step. The third step is pretty simple. You'll do some analysis to find out if you have to create, if you have to create a single number, and that single number is usually called as the test statistics. Later, fourth step is where all the magic happens. You understand the result by actually applying the decision that you took, the decision rule that was put into place to check if your null hypothesis is true or not. If it's true, you know what to do. If it's not true, again, you know what to do in either decision. There's no more guesswork from that point. Guesswork is usually in step number 1 when you're trying to define the hypothesis. And once you've defined those hypotheses, there is a very structured way, as you can see from step number 2, 3, and 4, that you can actually work through and say that, hey, it was an assumption until then, but now I have concrete data to no longer call it an assumption, but call it what? An observation, right? So that is really important for you to know. So there is a metric which is used to track. It's called as the T-statistic metric. And usually if this value of T-statistic is actually less than something what we call as the significance level, then we say, hey, null hypothesis doesn't work anymore. I want to reject the null hypothesis. Or you say that you fail to reject the null hypothesis based on whatever condition we have at hand otherwise, right? Now, technically what will happen is that you will never say that you will accept the null hypothesis. You will either say that you fail to reject it or you fail to reject the null hypothesis itself. That, as I just told you, right, it's a colloquial term of how you would say it. But of course, at the end of the day, it does have profound impact on what it means as well. So this is a bit of hypothesis testing that you really should know about. And then coming to certain 1 or 2 really important terms that you really have to know in hypothesis testing. The first term that I just spoke about a minute back is significance level. A significance level, when you say something is significant, you know that it has certain importance, right? So here what we're trying to do is basically significance level is nothing but the probability of when you should reject a null hypothesis, but in actual it might be true as well. So to give you an example to help you understand this concept better, let's just say that there is a 0.05 significance level, which basically at the end of the day means that there is a 5% risk in assuming that there is some difference. But in actual, there will not be any difference. But you say that there's a 5% risk. So this is that 5% risk you associate is basically called as a significance level, because you're not just saying, hey, there's a risk. Now you're saying there's a 5% risk. You have a way to measure that. And that significance level is a very important term in hypothesis testing. And that's usually denoted by alpha. So whenever you see hypothesis testing, whenever you see the term alpha, I'm very sure you're not left in deep waters right now, right? Fantastic. And next we come to something called as the p-value. The p-value is basically the probability that we're trying to see. We're trying to understand if a t-statistics as extreme as your calculated value can be occurred if your null hypothesis is true. This is very important for you to know. So what happens when your p-value changes? When your p-value becomes very low, it means that you are ready to reject your null hypothesis. And once you reject the null hypothesis, it automatically means that your p-value is less than what? Less than what? Less than the significance level that we just understood, right? So significance level, p-value, null hypothesis, alternate hypothesis, you can see that all of these are linked in a chain. So once you start understanding one thing, like a domino, you have to understand the others or it's going to become pretty difficult for you to figure out, right? I think this is one of the reasons why, the domain such as hypothesis testing is usually seen as very complex, but as you can see from the moment, it was pretty simple.
Now let's move on to our next topic, that is difference between ANOVA test and T-test. So in T-test, we know that the T-test is a type of inferential statistics, which is used to compare the means of two population. So there is a constraint in T-test, that is, it is applicable for two population only. Whereas ANOVA test is also an inferential test used to compare means of 3 or more population. Moving on to the next difference, the test statistics for t-test is sigma bar minus mu divided by s divided by under root of n. Whereas for ANOVA test, the test statistics is f statistics, or we can say the f value, that is the f statistics of ANOVA test is between the sample variance divided by within the sample variance. Okay, between the sample variance and within the sample variance. The third difference is t-test is used for hypothesis testing, whereas the ANOVA test is used to measure the deviation between the populations. So these are some of the important differences between t-test and ANOVA test. Now let's see some of the applications of ANOVA test. So basically ANOVA test can be applicable in case of when we want to determine the relation between a categorical and a numerical variable by testing the differences between their mean. It is also used to determine the statistical difference between the two or more groups.
After understanding the statistical methods is essential to grasp the fundamentals of machine learning. We'll break down the different types of machine learning, supervised learning, unsupervised learning, and reinforcement learning. This foundational knowledge will help you choose the right approach for your projects. Additionally, we'll explore different types of machine learning algorithms, including regression analysis, logistic regression, and clustering.
There are three different types of machine learning of how a machine itself learns in this domain. It is supervised learning, it is unsupervised learning, and it is reinforcement learning. Now these three learning methodologies, right, they work in very different ways. Each has its own application, each has further subdivisions and a lot of things, but these are extremely important. These are foundational for everything. Make sure you're putting an ample amount of concentration for these slides, guys. Right. The first one that we are going to check out is supervised learning. Now, think away from data science, think away from machine learning for a second here. When someone says supervised learning or that you're learning with some supervision, what's the first thing that comes into your mind? Because for me, it's probably a child who's studying for an examination and there's a parent who is supervising and making sure that the child is not playing games but is actually studying. Supervision, right? Keeping a control. Now, in the case of machine learning, things work similarly to the analogy that I just mentioned to you. Here, however, it is not the machine itself governing. It is the data which is governing. It is the governing entity in a way where the machine itself knows what data it is seeing. It is not literally being supervised, but it understands the data as if it were supervised. That's the difference here, guys. So you have three images on your screen right now. Let me use those examples to explain supervised learning for you. You have the image of a flower, you have some dumbbells, and you have a car here. Now, you as a human being is probably taught from a very young age to see not one, not 100, but 1,000 pictures of flowers to say it's a flower, right? You will not see a flower and call it an aeroplane. You know that is wrong. You have been trained over the years again and again and again. You see a picture of a dumbbell, right? There's a good chance it can be slightly confusing because you might have never used a dumbbell, or if you have, it is very easy to spot it, right? Now car is definitely a popular thing that you've seen, you've known. You would have seen thousands of cars in your lifetime, hundreds of colors, hundreds of models, all of these. So as soon as you look at the picture that I've put in here, there's a good chance that you can say, hey, it's an orange color, it's this brand, it's a coupe, it has this brand sport wheels, it comes with this engine. You can actually go on to tell the model just by looking at that image. But if you show the image to a computer, no, it will not understand any of these, right? You have to be very clear about that. So to bridge this gap of us telling the machine what it is seeing, right? The advantage of supervised learning is we give the labels for the data. If the data is the image of a flower, we give a label. We tell, hey computer, here is the image of a flower. We specifically mention that it's a flower and then give the image to the machine learning algorithm. So at the end of the day, the machine learning algorithm already knows what it is seeing. So it uses that to learn and later predict other images which might be of the case. Now this is just one example of supervised learning that I'm giving to you. But having these labels below that says this is a car, this is a dumbbell, this is a flower, right? That is very important for supervised learning. Now, with unsupervised learning, you don't do this. I'm going to explain that in a second. But before that, here's another important concept that you definitely should know about when it comes to supervised learning. See, supervised learning is a very simple form of how we can have an input. How can we apply a function on the input to eventually transform and arrive at a solution, right? So if your input variable, as we call it, is considered as x, applying a function on it becomes f of x. If you assign this to another variable y is equal to f of x is what we get. This is the foundation of supervised learning. We are trying to map the output as a function of the input, right? So we have the input, you're doing some transformation on the input, which eventually takes you to the output, right? So whenever there is a common discussion, y is equal to f of x, now you know what y is equal to f of x means. You have an input, you apply a transformation, you apply functions on it, you do a lot of things to the input to take it from its raw form to a processed form, and the process form itself is considered as y, which is the output variable in this particular case, guys. So this is a very, very important thing about supervised learning that you should know about. But then, did you know that supervised learning is further branched into two things called as regression and classification? Now, first of all, machine learning is divided into three things: supervised learning, unsupervised learning, and reinforcement learning, right? Now, supervised learning branches into two, where it's called as regression on one side, classification on the other. Now, if you've been wondering about what regression means, again, regression is a concept which I have already discussed previously, where you take in data from the past and you try to predict what might happen in the future. Or let's say you take data from the past and you understand why we are at this point in time today, right? We're going to be discussing a regression use case practically as well. So make sure you stick around till the end of this module. So regression is a very simple concept. Again, we're going to discuss it with an example. But if you're looking at classification, right? Classification is a simple concept which you've already used. Regression is something which you might have used in a casual conversation, but classification is something which you know you have done. Let me give you an example. If I give you, a ripe apple versus an unripe apple, or let's say I give you 3 apples or 2 oranges, I mix it and I give it to you. I say, hey, based on the shape of the apple, based on the shape of the fruit, why don't you split it out and classify it differently? Well, an orange is a round fruit, right? So you just take it and you move it to another place. On the left, you keep an apple. The apple has a very unique shape, right? So you put it on the left. Now, if I said, hey, why don't you classify it now based on the type of fruit? Now, there might be a case where there's a defect in the apple and it is now round, right? There are certain chances that it is almost round, you can get confused. But if I say classified based on the fruit only, you will know no matter what size or shape the apple is, push it to the left. No matter what size or shape the orange is, push it to the right. That is a simple way of classification here. Now, let us take a look at supervised learning. Unsupervised learning is one of these types of learning which is a direct contrast to supervised learning. Here, the entire goal of the machine learning algorithm is not us telling what the data is, but it figuring it out on its own. So the entire usage of unsupervised learning is based upon how the machine learning algorithm itself can find some sort of hidden structure or pattern that is present in the data without us specifically telling it, right? Now, take a look at the same 3 images I have on your screen. Flowers, dumbbell, and car. But this time I have not labeled it, right? That is done on purpose because here in unsupervised learning, you do not label the data. You just give it an input variable and let the machine learning algorithm figure out on its own. Now, there is a very, very good chance that now there's a question in your mind saying, okay, so if you're not helping the machine, is unsupervised learning a complex procedure compared to supervised learning? In many cases, the answer is yes, because here, it is not just cross-referencing what it has learned to what it already knows, but here it has to first of all learn in a very different way and then work on cross-referencing. So it definitely takes a good amount of computing time, computing power, and of course the way the machine learns, the way it uses algorithms to already know that it only has the input to get to the output and find a structure is very, very different compared to supervised learning. So I hope I was clear in that point, right? Now, if you're looking at grouping, another very important thing that you have to know in unsupervised learning is that there's two groupings, just like how we had for supervised learning. But here, instead of regression and classification like how we had in supervised learning, in unsupervised learning, we have clustering and association. Now, clustering is a fantastic example, which again, you would have used in your real life anyway. If I give you 3 erasers, 2 pencils and 5 pens and say, can you group all of these things separately and keep it into 2 or 3 piles? Can you or can you not do it? You can do it in a very simple way because you know what a pen looks like, you know what an eraser looks like, you know what a pencil looks like, and you know how to club it and group it and keep it separately, right? Does the machine know this? No. But if you train it, can it understand this? Absolutely yes. That is the entire point of using unsupervised learning, right? So that is a simple example of clustering. Now let us take a look at a simple example of association. Again, association is something which you have used, but you might not know you've used. Maybe you're on the Amazon's website. Maybe you're buying your favorite thing. Maybe you just bought a new mobile phone. Now, as soon as you buy a new mobile phone, as soon as you add it to the cart, there's an option below which says people who have bought this mobile phone also bought this. It may be a screen guard, it may be a case, it may be an earphone, whatever accessory, right? So it is recommending something to you. It is saying, hey, people who bought this also bought this. So it is trying to map something. People who buy this phone have a good chance of buying the protective case for it, tempered glass for it, all of these things, right? That is association. Here's another example. Every time you finish watching a TV show on maybe Netflix or Amazon Prime, at the end of it, there is a good chance it recommends a very similar TV show for you. Now, if you watched a horror movie, the next recommendation is going to be a horror movie or a thriller or something like that. If you watched a comedy, a situational comedy, sitcom or anything like that, after you finish an episode or after you finish the TV show itself, the next one it's going to recommend to you is something similar, because here, Amazon, Netflix and all, they're trying to understand what your preferences are, what you like watching, and eventually customizing their platform so your viewing experience is amazing, right? That is association. If you've been wondering, association is used not only in these 2-3 cases, but almost everywhere that you can think of. Everywhere where there's customization, where there is a goal to make sure that customer retention is high, will use association, and even in fact a concept of clustering very popularly as well. So it becomes very, very vital that you understand that unsupervised learning is among the most popular algorithms or the types of learning there are in today's world. Right. Now that we checked out supervised learning and unsupervised learning, let's get to the third type of machine learning. Here we're going to take a look at reinforcement learning. Now, reinforcement learning is a very, very fun algorithm because, again, here's an analogy in real life to simplify what it means. Okay, so how many of you guys have either pet cats or pet dogs at home? It works better with dogs and less with cats because I personally am a owner of both. So I know that it just works amazingly well with dogs. Right, here's the example. Have you ever had your dog trained professionally? Right now, a simple training, it usually starts out with sit, stand, give me a handshake, all of those instructions to your dog, right? Now, your dog does this. Your dog is trained in a way where if it gives a handshake, it gets a tiny reward. It gets a biscuit. It gets a treat, right? So your intention here is to get the dog to give you a handshake. The dog's intention is to train itself in a way where if it gives a handshake, it gets a treat. It gets a nice thing to eat, right? Your happiness lies in getting the handshake. The dog's happiness lies in getting the biscuit. It's two different things. But at the end of the day, your purpose of getting a handshake is being solved, right? So that's the thing. With cats, I've seen that if you ask a cat for a handshake, they just meow and run away and they don't care absolutely. Or I don't know, just is it my cats or something like that? But that's the most common thing that I have seen, right? So there's a reward which is waiting at the end of learning. Now, if the dog does not give a handshake, and if you say, hey, give me a handshake, and you extend, you try, but it runs away, it is not getting the treat. It is missing a treat. It is intelligent enough to understand that it has to work towards something, be it a handshake, be it sit, stand, roll over, whatever it is, to get that treat while it is being trained, right? Exactly the same thing here in machine learning as well. When a machine learning algorithm learns, here we are trying to make sure that it is learning based on its own feedback. It will use its feedback in a way where either it has to work towards the rewards. In case, if it is learning right, it will be given a reward every position of the way. If it is going away from the solution, if it is doing something which does not add value to the solution, it is punished or it is penalized. Of course, guys, this is just an example with machine learning. There is no penalization or there's no punishment with real pet dogs. It was just an analogy, so that's an important thing you have to note, right? In machine learning algorithm, the penalty or the reward is just mathematical numbers. It's +1, -1, all of these things which will eventually not hurt anything, right? So keep it at that. What happens here is exactly that. If it's going towards the goal, it is given a quick reward and it knows that it has to maximize the number of rewards it gets. If it is learning something which is not useful to the reward, it gets to the goal, it gets penalized and the rewards keep coming down. So the goal is to maximize the number of rewards, and it does this by looking at its previous steps, previous learnings, previous iterations. So that is how reinforcement learning works. It's a really, really fun way to work with machine learning. I absolutely love working with reinforcement learning. But again, in the most simplest way, it is okay to implement for a simple solution. But if you have very, very complex solutions where you have to use reinforcement learning, the implementation does become tough, guys. So that's one thing you should know about.
Now we will see how this clustering works and what is clustering. So process dividing a data set into groups and consist of similar data points is known as clustering. So you can understand these are the information is nothing but our data points. So basically for the machine or for the model, it's actually clustering the same data points with one cluster and the different data points with the other clusters. So this is how this clustering works. As a note, points within the same clusters are similar to each other but are different when compared to other clusters. So you can see in the image itself, we have same type of human being who are in blue. Some of them are in red. Some of them in yellow, but they are different from each other. But when we talk about the same cluster, we will have the same thing. Right? So do not confuse about the different clusters. So clusters basically make with the same kind of data points. So if we talk about the same kind of a choice of movies or same choice of clothes, someone like Western, someone like Indian, right? So in this case, they will try to cluster all customers together who are actually liking Indian most, and they will try to give some recommendation. So we all know the recommendation about Amazon, Flipkart, Myntra, right? So whenever you go for doing any shopping, they will show you that maybe you will also like this. How they do that? Basically, it's nothing but the clustering, the recommendation system. Right, so they do the clusters the same type of a customer and give the same recommendation for them. Right, so this is where also unsupervised learning works. So now if we talk about the example of clustering, so cluster different colors of fruit, maybe mango, banana, I can see some, blueberries are there, right? So they will cluster the same type of fruits together. Now, if we talk about the different type of garbage, so maybe there is a paper, glass, organic, plastic. So you have garbage all together and your machine will try to find it out the same type of a garbage and actually cluster them together. So this is the example of clusterings. So now if we ask why clustering is needed, in that case we can say determine intrinsic grouping in the set of unlabeled data. Right? Organize the data into clusters, thereby showing internal structure of the data. Yes, it will show what is the internal structure of your data, how your data is structured, what is the cluster, what are the number of clusters you have in your data, what is the data distribution. Everything you can understand if you go for using clustering. Then create partition in the data set. It's also create partition. Obviously, when you have 2-3 cluster in one particular data set, before that your data set is a whole is a whole data set. But when you actually cluster them, it will have the partitions, the different clusters. So this is why we need clustering to understand our data set in a more precise way and also do the machine learning algorithms. Now, if we talk about the types of clustering, what are the types of clustering we have? We have clustering three types of. One is exclusive clustering, one is overlapping clustering, one is hierarchical clustering. So let's have a look at one by one in a short way what this clustering stands for. So first, if we talk about exclusive clustering, that time you can say item exclusively belongs to one cluster, not several. So when you have clusters 0, 1, 2, 3, that time these clusters are not going to overlap to each other. You will have a proper cluster for each and every data points, right? For maybe your data points 1, 3, 4, and 7, it's coming to one cluster, and for your 3, 4, 7, 6, it's coming to another cluster, but there will be no overlapping. So the example of exclusive clustering is K-means clustering, what we are going to do in the later in the section, right? Now, if we talk about the overlapping clustering, what is overlapping clustering? Set of item belongings to multiple cluster. So one particular data point can comes to two different cluster. So you can see the rate dots, you can see it's belonging cluster 1 and cluster 2 both. So this is known as the belonging to multiple clusters is known as overlapping clustering. So the example of overlapping clustering is fuzzy or C-means is a type of clustering, right? Where actually this this data points are going to can be the part of two different cluster or three different cluster, right? So now if we talk about the hierarchical clustering, but before start with the hierarchical clustering, maybe you can ask me, hey, how can it be even possible that one data point will belongs to two different data or two different clusters? But yes, that's possible because we don't give any type of a label over there. Maybe the characteristics, they both have that something common, something similar. That time they can overlap with each other as well. Now comes the hierarchical clustering. Cluster having a parent-child relationship, which is actually like nothing like something like tree-like structure. It's known as hierarchical clustering. From the name itself, we can understand there is a hierarchy. So basically, hierarchical clustering itself is the example of that. So you can see C2 is the parent, where you have C1 and C0, which is the nothing but your child, right? So cluster 0 and cluster 1 will be your child, whereas cluster 2 will be your parent. So there is a structure of tree-like structure, which is parent and child's relationship, right? So yeah, we have talked about the pretty much about why do we need clustering, and then what is the reason we are actually going for clustering, and we have the partition in the data set. We try to understand our data in a more precise way. We can do the prediction using this clustering, and when your model is going to see the same type of a data points, is going to cluster the same thing with together, right? So this is pretty much about the clustering we have learned so far, and maybe after that we will start talking about the K-means clustering. In this part, we are going to talk about what is K-mean clustering. K-mean is a clustering algorithm that we know that it's exclusively, if we go back to the presentation, you can see the exclusive clustering is one of the example of K-means clustering. So from this, what we know that items exclusively belong to one cluster, not several, right? So always keep this basic part in your mind. So now if we'll talk about the K-means clustering, K-means is a clustering algorithm which focuses on grouping similar elements or data points into a cluster, right? So basically what we have actually do, so basically K-means clustering algorithm is focuses on grouping similar items, right, in a particular cluster. So K means represent the number of cluster. What are the numbers, total number of cluster you will have in your data set, which is known as the K-means clustering, and the K is basically defining the number of cluster, right? I hope you understand why this is known as K-means clustering. Now, if we just go deep into K-means clustering, before that, you need to have an idea about business applications we have in K-means. So behavioral segmentation, inventory categorization, sorting sensor measurements, and detecting bots or anomalies. For that, we use K-means. Now, if we talk about the understanding K-means algorithm, in that case, maybe we are going to take an example. You can see here there is number of cluster equals to 3. We have data points over here in the straight line. So in this case, what you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see in the visually we can say this, and this. This tree will be 3 clusters. But how to do this with k-means? So let's have a look at how we'll start with the k-means. So firstly, we need to maintain some, we need to maintain some steps. Before that, if you want to see our final output, you can see this will be our final output. The first 4 will be belongs to the orange group. The second blue one will be the 4 will be belongs to the blue group. And the third cluster, it's a green cluster, the last 4 data points will belong to the third cluster, right, which is the green cluster. Now, if we start doing this one by one, it's just something we can see. But there is something we also need to do. So first, identify the number of clusters, that k equals to 3 in this case. So already we know that identify the number of cluster. Now, randomly select 3 distinct data points. Okay. Now, you know nothing. There is the white cluster, white data points you have. Now, I have just chosen this particular orange, blue and green one. So basically, you have to choose randomly 3 distinct data points. After that, measure the distance between the first point and the selected 3 clusters. So now what you need to do, maybe I have taken this particular part, right? I have taken this orange, then blue, then green. So I am going to take the distance between the first one, the first data point with the first data point I have selected, from the second, from the third. You can see, measure the distance from the point 1 to the orange cluster. You can see this is the arrow is showing that. Then distance the point 1 to the blue clusters. This is one we are using for the blue clusters, and for the last one, the distance from the point 1 to the green cluster, right? So these are the 3 steps you need to follow when we go for using this particular k-means algorithm. Now, if we just look at the second step, what we need to do in this case, assign the first point to the nearest cluster. So you can see for the first one, orange in this case, right? So what we are going to do, you can see when we actually calculate the distance, this distance will be the less, this will be more, this will be pretty much more, right? So that time this will be the first cluster we can assume that comes under orange, right? So this is the repeating the process. Then we again going to repeat the particular process, right? After that, calculate the mean value including the new point for the orange cluster, right? Then we are going to calculate the mean value, right? That is which is going to including the new point for the cluster, orange cluster. All right, we will try to find it out the mean over there. Then what we need to do, see after this when we actually did this, so that time we are going to do what? So find the which cluster does point 2 belongs to how, right? Repeat the same procedure, measure the distance to the orange mean. Again we are going to measure the distance. Here you can see we have taken the mean over here, right? So distance from point to the orange cluster, right? You can see. Then distance from the 2 to blue clusters, we have done this, and then distance from the 2 to the green cluster, and we will keep on repeating this particular stage, right? After that, point 2 belongs to the orange cluster. Calculate the new cluster mean including the new point. Again we need to calculate the new cluster mean, and again we are going to include the new point. So we are going to repeat the process like this only, right? And this is just for we are trying to elaborate this just to your understanding, right? Find to which cluster does point 3 belongs to and how, right? Repeat the same procedure, but measure the distance to the red mean, right? So distance from the point 3 to the new orange mean, and distance from the point 3 to blue cluster, and distance from the point 3 to the green cluster. So this is how we will try to find it out the cluster for each and every data point we have in our data set. Now we will keep on repeating the process, and you can see point 3 also belongs to the orange cluster. Measure the distance and add the third point to the cluster having the minimum distance, and calculate the new cluster mean including the new point, right? So now as we have done this, so you can see find which cluster data point 5 belongs to and how. We are going to do the same process, repeat the same process, and we will find the result out of it like that. Now, what we are going to do, since the raised points lies closest to the green cluster, so all the point you can see from here, so as we have taken this point, right, from here to here, and these all comes into the green cluster, right? But this is not right, right? We can see this is not right. So in this case, what we are going to do, the result we got, that is the blue, we have the orange is fine, but the blue one, that the two blue should come under blue, which already comes under green. So in this case, we need to do, again, we need to repeat the same thing. But when we actually do the same thing for the second time, for the second iteration, before that, you have to understand the total variation within the cluster. You can see this is the variation over here. It's not symmetrical at all, because in the blue one, you can see the variation is very less, right? So this is how we can understand our clustering is not perfect. When we try to do the iteration 2, we will try to change, not we will try to change, we will actually change the random data points, right? And start from the first with different initial random points. Always remember, we cannot use the same initial point, so as compared to the first iteration. Then again, step 1, select the number of clusters that we know equals to 3. Randomly select 3 distinct data points. The same thing we have done. Then measures the distance between the points and the selected 3 cluster. And keep on doing this. And then again for the iteration 3. Right, for iteration 2, iteration 3. After that, what we will do, you can see the iteration and the variation. Right, finite iteration with the minimum variation is selected. So we always try to find it out a clustering where the variation is very limited. So you can see in the iteration 3 we got our result. So this is how our k-means clustering works, and this is how we can actually work with k-means. But after this, we will have a talk about how to decide the value of k. What is the funda behind it? How actually the k value, for this case we know the k equals to 3. But how to decide the k value? In this part where we left off, that how to decide the k value, we will do it over here. So for our case, for the example, we know this time k equals to 3 was known. But what if the exact value of k is unknown? Right? So the idea behind partitioning is to define clusters such that total intra-cluster variation or total within sum of square, which is known as WSS, for each cluster is minimized. So always try to have a inter-cluster variation should be very minimized, and also within sum of square, which is known as WSS, will be also very minimized. The note you can understand the total WSS measures the compactness of the clusters. Right, so if you want to check the compactness of the clusters, you need to measure the WSS, which is nothing but within sum of square. Now we will understand how to decide the value of k. So this time we use a method called elbow method. The elbow method looks at the total WSS as a function of the number of clusters. The number of clusters should be chosen so that on adding another clusters does not improve the total WSS. Right? So from there, when you actually, this elbow method is going to help you the compute. How to do that? Compute different values of k, varying with k from 1 to 10 cluster. For each k, calculate the total within cluster sum of square, which is known as WSS. Plot the curve of WSS according to the number of clusters k. The location of a bend that is known as knee in the plot gives the appropriate number of clusters. If we go back to the presentation, you can see there is a graph is given. In this graph, you can see there is a elbow. Elbow type structure is there. Right? So this elbow is basically nothing but going to help you to how many cluster you will have in your data set. So the location of bend knee in the plot, which gives the appropriate number of cluster. So this is how we actually need to decide the value of k. And to decide the value of k, we need to understand the elbow method. Now, after this, we are going to do the demo on k-means clustering. So we will do a basics demo on k-means clustering, and after that, we will do a project on k-means clustering. So let's get started on that. In this part, we are going to talk about k-means algorithm implementation in Python. How to do that? How we'll actually implement k-means in Python. So let's have a look at how we will start with k-means algorithm. So let's have a recap of how k-means works. So the first step, as we all know, need to specify the number of clusters, that is k, need to be generated by this algorithm. Then the step 2, next randomly select k data points and assign each data points to a cluster. In simple words, classify the data based on the number of data points. Right? What is number 3? So number 3 will compute the cluster centroids. We need to understand what is the centroid of our cluster. Then the fourth step is keep iterating the following until we find the optimal centroid that we have seen in our presentation, which is the assignment of data points to the cluster that are not changing anymore. Right? And there are few subpoints if we want to look into. Then the first sum of the square distance between data points and the centroids would be computed. Then now we have to assign each data point to the cluster that is closer than the other clusters. Right? That we have done. That is basically we are trying to calculate the centroids. At last, compute the centroids for the clusters by taking the average of all data points of that cluster. Right? So these are the steps we have followed when we have done this particular process in presentation. Right? So K-means follows expectation maximization approach to solve the problem. The expectation step is used for assigning the data points to the closest cluster, and the maximization step is used for computing the centroids of each cluster. Right? So we know all these things before as well. It's just to recap to understand K-means in a more concise way. So now we will have a look at what are the libraries we are going to use over there. So we are going to use Matplotlib, Seaborn, Numpy and sklearn. Now you will ask me, what are these libraries used for? Let me give you a quick heads up on that. So basically Matplotlib and Seaborn are used for data visualization. There is one more question. If Matplotlib can do the data visualization, then why do we need to go for Seaborn? Because Matplotlib is a very basic library. So in this case, if you want to do some kind of a advanced data visualization, you have to go for Seaborn. And Seaborn is basically based on Matplotlib. Right? So you can understand for this time being that Matplotlib and Seaborn both are required for a proper data visualization, presentation. Okay. Now we will have a look at Numpy. So what is Numpy? Numpy is nothing but numerical Python. We used for numerical purpose. Then comes sklearn. What is sklearn? This library is known as scikit-learn, basically for machine learning techniques. In this library, all the algorithms are implemented, and also we can use them by calling them their name. Right? So basically you don't need to do anything and you don't need to write an algorithm from the scratch. The scikit-learn library makes our life easy. Now we will going to do few things. First, we are going to generate a 2D data set which will contain 5 different clusters. How to do that? For that, we are going to import make blobs from scikit-learn. So we have written that from sklearn.dataset.samples generator import make blobs. Right? So this is how we have imported our library. Now we are going to making our data set. But wait, we need to talk about what is make blobs. So if we go up, the make blobs is basically generate isotropic Gaussian blobs for clustering. Right? So in sample, we have few parameters on this particular function. The in samples, this basically it is the total number of points equally divided among clusters. Right? Then we have in features, the number of features for each sample. Right? Then we have centers. So basically centers are nothing but the number of centers to generate or the fixed center location. If in sample is an int and center is none, 3 centers are generated. If in samples is an array, like centers must be either none or any other length of equal to length of in samples. Right? So this is how we actually decide our centers. Then we have cluster std. Why do we use cluster std? Because this is a standard deviation of the clusters. Right? Then we have shuffle, we have center box, random state, reproducible output, return centers, all these parameters. So we can look into it and you can start using according to your uses. Now what we are going to do, we are going to do a very basic make blobs. So in this case we have written that x and y equals to make blobs in samples equals to 400, centers equals to 5, cluster standard deviation which is known as cluster std equals to 0.60 and random state equals to 0. But what is random state? Random state is basically determines random generation for dataset creation. Right? If we do that, and then we are going to see what actually dataset we have made. For that, we are going to use a data visualization tool, which is Matplotlib. We are going to use for this particular purpose. And we are going to use a graph, data visualization for dot scatter. So we have written plt dot scatter, and then we have provided our data. If you just look into it, you can see this make blob is total 5 clusters we have, the different data points you have. Now using k-means, you need to understand how you can actually make them in 5 particular clusters. Now, what we need to do, as we have seen, we have 5 different clusters. By looking at the dataset, we can say, next, make an object of k-means along with the providing number of clusters. Train the model and do the prediction. How to do that? We are going to call k-means function, which is basically where our k-means algorithm is implemented. So in this case, you can see we have used a variable called k-means, and we have written k-means and the cluster equals to 5. So we have 5 cluster. Now we have written k-means.fit x. So whenever we are going to use .fit function, it's nothing but it's actually you are going to train your model. Then what we are going to write, we have written y k-means equals to k-means.predict s. So in this part, we will try to predict our k-means, the x. If we do that, the plot and visualize the cluster center picked by k-means Python estimator. Now if we just try to understand the what actually our model has done, in this case, what we need to do, we are going to use that plt dot scatter plot again. Here, if you can look over here, you can see that we have written centers equals to k-means dot cluster centers, right? So in this case, you can see what we have got. We get all the centers of the cluster, and total cluster we have total 5 cluster. So this is a very basic example of k-means clustering, how you can start up with starting with make blobs, and then try to give centers and feed your model with k-means, and then try to find it out all the different cluster in your data set. We are going to do one more example of k-means using a data set. But that data set we will actually load from the scikit-learn library itself, right? So here also we are going to use Matplotlib, Seaborn, Numpy and scikit-learn. So here what we have done, we have load the digit data set from sklearn and make an object of it. Dataset is having basically 1797 samples with 64 features, right? So let's have a look at how can you load the dataset from the library itself. So for that, we are going to import from sklearn .datasets import load digits, right? And digit equals to load digits, right? So if you do that, then you can see your dataset will be already imported. Not even imported, it's already loaded, right? So now if we just try to understand digit.data.shape, what is your shape of the data, that time you can understand your data.shape is 1797 rows you have and 64 columns you have, right? So we use .shape function to understand our data. In this case, there are few columns will be there, the images will be there to understand our data. What actually we want to do with this? We just try to understand what are the digit it is. So basically, we will try to segregate the digit 1 to 10, right? Using this data set. Now, if you want to check this, if you want to check this out, you can see this is nothing but numpy.ndarray. Right, the data is type of numpy.ndarray. Now what we need to do, we are going to do the same thing. We are going to call k-means clustering. Here, how many clusters we will have? We will have 10 clusters, 0 to 10. So total number will be 10 clusters, right? So the number of cluster will be 10 and random state equals to again 0 we have used. Now what we need to do, we need to train our model. How to do that? Clusters equals to k-means.fit predict then digit.data. So why we are using .data? Basically, it's going to give you all the data itself, right? And after that, if we just try to understand the shape cluster centers.shape, that time it will show you that 10 clusters with 64 features. If we do that, you can see this is 10 clusters with 64 features. As we have said that our total cluster will be 10 and the feature will be 64. Right, as we have 64 columns. Now, if you just look over here, what we have done, we have used few data visualization technique to understand our data. In this case, we use fig and ax plt.subplot. It's basically we will have different plots in one plot, right? And after that, we have written k-means dot cluster centers dot reshape, and we have reshaped the cluster centers to 10, 8, 8, right? Then what we have done, we have just used dot imshow. This imshow basically we used from Matplotlib to actually see the images, right? You can see these are the images we got. We have 4, 3, 1, 1, 9, 0, 7, 6, 5, 1. This is your data set, right? With the match the learned clusters labels with the true levels found in them. Okay. Now what we need to do, we are trying to do a stats. We will try to do some statistical visualization. So in this case, we have imported scipy.stats import mode, right? Now what we have done, we have just written np.zeros like clusters. Then we have just used a for loop to check like what is the mass, what is the label, what is the data set, right? After that, what we have done, we try to understand the accuracy of our model, how our model is going to work, right? So in this case, we have used accuracy score from scikit-learn. So we have written accuracy score and then digit.target and your label. So basically what we are doing, we will try to give our data, not the label, right? So as we don't give the label, so when we try to predict, that time we understand what label our model is going to predict for this information. If it's correct, then obviously it will be counted as a correct one. Then the accuracy score will be high. So in this case, we did the same thing. You can understand our accuracy score is 0.795. So basically it's nothing but 79.5%. So near about we can say it's 80%, right? So our model is working pretty fine, but you can use this particular concepts with different data sets as well. It's a very basic data set to start with for k-means clustering. In this part, we are going to use a mall customer data set to do the k-means clustering, right? So we will try to cluster the same type of a customers according to their maybe income and spending score, right? So before starting with the project, let's have a look at the data set, what we have in the data set. If we just go to the data set, you can see this is our data set, right? I have taken this data set from Kaggle itself. So it's a free open source data set. Basically, anyone can use it. Okay. So here you can see we have customer ID, the genre, that is the male or female, age group, right? We have annual income, total in dollar, right? You can see the total annual income and the spending score that we have. Right? So if we look at the data, basically we talked about the data set without label and with label. So in this case, you can see in this data, there is no label. So basically our k-means clustering is trying to cluster the customers according to these informations, right? So this is pretty much about the data set we are going to use for this project. And let's have a look at how we are going to do this in k-means clustering. So we are going to again use Numpy, Pandas and Matplotlib and Seaborn, right? So we are going to use pd.readCSV function. As we know, we use this function for reading the comma separated value, that is your .readCSV. And if you are new to the Google Colab, you can see here is an option to upload, right? From uploading session storage. But be sure the session storage will stay for 12 hours. After that, everything will be deleted, right? So whenever you are going to use Google Colab, try to save your data in your or mount your data, right, with Google storage itself. Now comes this uploading data. If you click over there, it will directly automatically take you to the uploading part from your local system, and from there you can directly upload your .csv file. Now you need to have the copy path. So where will I get the path for this particular data set I have uploaded? If you can look at this sign, if you click over here, you will get the option of copy path. Right? So for after that, pd.readCSV, and you need to give your path, right? Your path is content / mall customers.csv, right? So now you can see if I just do this, the data set will be already stored in the data set. The variable called name is data set. Now, if you want to check, is your data set is stored or from the .csv file or not, you can go for using .head function and .tail function. So what is .head function? So .head function is basically going to return you first 5 rows of your data set. right? So data.head. So if you look at here, you will get the customer ID, genre, age, annual income, and spending score, and your data is already uploaded, right? Your data is stored in dataset variable, which is a type of data frame. Now we are talking about the tail as well. So basically, if you just write dataset.tail, right? So if you just do that, in this case, what you will get the last 5 rows of your data set, right? You can see 199, 198 like this. Now, if you want to check the shape of your data, how many columns you have, how many rows you have, you just need to write dataset.shape function. Right? If you just write dataset.shape function, it will return you the total number of rows and columns in your dataset. So for my case, 200 rows I have and 5 columns I have. Right? So now we are going to do the dataset.info. So what is dataset.info? It's going to give you the information about your dataset. What type of information it's going to give me? So basically, what is the data type of your each column? Do you have any null value or not? Right? So these are the things you can understand by using .info function. Yeah. After that, we have one more function called .describe function. But why do we need .describe function? We need .describe function to understand the few statistical terms in our dataset, like the count, what is the mean of your data, like for each and every column, what is the standard deviation, what is the IQR interquartile range, right? We basically divide our dataset into 4 parts, right? 25 percentile, 50 percentile, and 75 percentile. Right? So IQR is basically taking the third part of the leg, that is known as third quintile, and the first quartile, right? So basically we use these two to calculate IQR, right? So basically these are the basic statistical term you need to know when we talked about like our data set. So that's why we use .describe function. After that, if we need to check, is there any missing value we have in our data set? But why do we need to check it? We need to check it because if we have missing value and if we do the prediction with this missing value, our data is not at all perfect to go for a analysis, and if we do that, we will get a very bad result. We will end up with a very bad prediction that we don't want, right? So that's why for the precaution, we always try to check what is the outlier. Do you have any outlier in the data set? Do you have any missing value in the data set or not? So in this case, we are going to use a function called .isNull function. And then we have written .sum. So basically, we are going to check if is there any null value we have in our data set. If we have that, what is the number of that? Then you can see the sum of the null values is 0. So we can see we don't have any null value in our data set. Now, if you want to check what are the columns you have in your data set, how to do that? In this case, you need to use .columns function. If you just write dataset.columns, you will get all the column you have in your data set. Right? So now we are going to do the clustering based on the annual income and spending score. So we will try to use annual income and spending score, right? Not the age and the customer ID is not needed anyway. The genre and the age, maybe we can do. Let's see, maybe in the first let's try with the annual income and spending score. What is the annual income and what is the spending score? Right? So in this case, how to take it? We just use this, like if you want to take 2 particular column from your data set, you need to do this like this, like not the 2. If you want to take many, so that time also you just need to use this particular technique, right? So in the data, what we have now, if we just look at the data, we will have 2 columns. One is annual income, one is spending score. So if you just try to understand your data shape, in this case again you will get the same thing, right? So 200 columns with, just let me do that, data.shape. Okay, so if we do that, you can see we have 200 rows and 2 columns. Now I just want to only the values, not the column name. That time you just need to call .values. You will get all the values, not the column, right? You can say this is your value. Now, we always assume the max number of cluster. Now we will do the clustering. So we always assume that the max number of cluster will be 10. You can judge the number of cluster by doing averaging. But in this case, we will try to find it out what is our K for this particular data set, because we don't want to take any random assumption for that. Maybe you can do that, but in this case, if we just use this particular elbow method to understand the K value, let's have a look at now. So in this case, we are going to import k-means. we will going to calculate the WCSS, and for I in range 1 to 11, we are going to say, like from 1 to 11, why we basically try to take 0 to 10, the 10 clusters, right? So we have written k-means underscore clue equals to k-means in cluster equals to I, right? So your I will go 1 to 11, okay? And this part maybe you can skip as well. So random state equals to 42 for 56, and then we will feed our data. So if we do that, and if we just try to plot our elbow method, you can see it's actually showing it's the elbow is the 5, right? So 2, 3, 4, it's not there, the 5 one. So in this case, this curve is telling you that the elbow comes at k equals to 5. So that matter the range we select, that's why 1 to 21 also will say the same behavior, right? So basically we try to understand this particular elbow in the curve to understand our k value. So in this case, like the curve, it comes from 5. Now what we need to do, we are trying to do the k-means clustering that we have done so far. So we know our k value. So we actually prefer to like finding out the k value. Otherwise, maybe you need to start from 1 to 10 to understand which one is working for you. We don't want it, right? So in this case, we are going to use elbow method. So this elbow method is basically helping us to start with k value. Now, as we see, the k-means, we are going to call the function called k-means and cluster equals to 4. Here we are going to write 5. Right? So as we can see, its cluster equals to 5. Now the random state equals to 4, 42. Maybe you can change it accordingly. It's just randomly changing your data. All right. And then we are going to use k-means.feed predict x. Right? Now, as we have done this part, right? So now we try to visualize our data. How to visualize our data? We are going to use a scatter plot, and there we are going to use this. We have actually give some different colors to show our data, right? We have pink, yellow, red, orange, magenta, right? Maybe something else, maybe you can give green as well. Maybe we are going to give green. So you have total 5 cluster, right? And the centroids we have given, that is yellow. No, which will not work. So in this case, maybe we can give the centroids will be orange or violet. Maybe it will highlight it. Yeah, you can see, right? So in this case, what we have done, we have used 5 clusters. We have 5 cluster that we have talked, and their k-means dot clusters, and we have used the centroids. We try to find it out as centroids as well, and we give the centroid color is violet. So if you look at this, you can see there is a 1, 2, 3, 4, 5 clusters, and they try to separate the data points as well. This is the cluster 1, 2, 3, 4, 5. So cluster 1 is pink, cluster 2 is this one, this yellow one, 3 is red, 4 is again yellow, and 5 is green, right? And these violets are the centroids, right? So this is how our clustering, k-means clustering works when we don't have the label in our data sets, right? I hope you like this particular demo, and we have covered all the things like we have talked about what is supervised, unsupervised learning, what is machine learning, and then what is like clustering, the types of clusterings we have, and also we talked about the in-depth in k-means clustering, and we have done almost 3 demo, like the basics of k-means, then using a very basic data sets of k-means data, like like the digit data set to do the k-means demo, and lastly we did, right, let me just change the name of it, so small customer clustering. Okay, so basically what we have done, so lastly we have used a small customer data set to do the clustering, right? So yeah, this is pretty much about the k-means clustering we have learned so far. So first we are going to talk about what is regression. So regression is basically nothing but a technique that predicts the value of variable y based on the values of variable x. I can understand it's basically nothing but it's confusing, right? What type of variable x and y we are talking about? I will explain you everything, the maths behind regression as well. And this is very simple, trust me. And if you really like the video, do not forget to like it, and do not forget to like and subscribe Great Learning. And if you feel this is going to help you to your peers, your classmates, please do share this video with them as well. All right, so let me tell you what is regression. So in the case of this, you can understand we do have two types of variable. One is dependent variable, one is independent variable. We will talk about variable later. But before that, let me give you a use case example for that you understand what actually I want to mean by regression. So regression is nothing but who can help you to find the relationship between two different things. Suppose we have an example of as the winter comes, we try to put on jackets, right? So in that case, what we can say, as the winter comes, we used to buy more jackets. So yes, there is a direct relationship between sale of the jacket with the weather. Yes, finding out this type of relation is nothing but your regression. So we can see here as the temperature drops, sale of the jacket increases, and we are getting a relationship between them. Right, now we will have a look at one more thing. So you can totally see that regression is nothing but if you think there is a relationship between two things, then the regression will help you to confirm it. Right, now let's go and move forward to the another example. Suppose as the temperature increases, right, as the summer comes, what we do, we used to buy lots of ice creams, right, because we love to have ice cream and it's cold, right? So yes, you can totally again understand there is a relationship between summer and the ice cream van. So as the temperature increases, number of cones sold at the ice cream stores also increases. So there is a direct relation between both of them, and regression will help you to confirm that, will help you to find that yes, there is a relationship between these two variables, right? Yes, this is pretty much about regression and how regression help us to find out the information from the data. You can totally understand how regression is helping us to get the idea, okay, there is a relationship between these two particular variables using regression technique. Now we will talk about what are the type of regression we have, and then we will see how we are going to do this particular regression technique on the data set, using the data set, and how it actually help you to do the regression analysis as well. Right? So what are the type of regression we have? There are various types of regression we have, like linear regression, logistic regression. We talk about multiple linear regression, right? So there are types of linear regressions we have. So in this particular case, we are going to talk about linear regression. Right. So linear regression is a type of supervised learning. So we talked about type of machine learning. What are the type of machine learning we have? Basically, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So we know what is supervised learning, right? The supervised learning is nothing but where you have the labeled data set. So I will show you again what labeled data set I want to mean by, right? So linear regression is a type of supervised learning. Now we are going to talk about used for finding linear relationship between the dependent and independent variable. Now let me give you one example. We have y equals to mx plus c, right? That is nothing but, again, this is a straight line formula. While we have y equals to your dependent variable. So when we are going to write in x plus c equals to y, so you can understand x is nothing but your independent variable. We will see the elaboration of this particular formula later, but yes, I can just give you a heads up on this. So linear regression works on y equals to mx plus 3. Right? Now, this help you to find the relationship between two or more continuous variable. Yes, if you have a continuous type variable, right? Suppose your salary is a continuous type variable. Suppose is your Uber care, like Uber cap prediction is again cap fair prediction. Fair is a continuous variable. But when you have a discrete variable, that time you cannot use linear regression, right? Yes, so this help you to find the relationship between two or more variables. That variables will be or should be continuous type variable, right? So yes, this is pretty much about what is linear regression. Now we will have a look at what is multilinear regression. So guys, if you have any doubt, do not forget to let me know in the live, let me know in the comment box. For that, I can give you the proper, or I can just solve your doubts. We will happy to do that, right? Now we will see what is multiple linear regression. So multiple linear regression is nothing but an extension of linear regression. Yes, so if you have simple linear regression, from there we have multilinear regression. It helps to find the relationship between more than two variables. When you have more than two variables, suppose you have y equals to mx1 plus mx2 plus mx3 plus c, right? So in that case, this comes under multiple linear regression when you have more than two variables. As we know, in simple linear regression, and was actually has one predictor and one response variable. But have a good look over here what I am saying, and it's actually a very good point, or the main essential point, or the difference between simple and multiple linear regression. So in the case of multiple regression, you have more than one predictor, but response variable will be one, right? So this is what stands for multiple linear regression. Now we are going to talk about the two type of linear regression we have talked, right? So you can see here the single predictor we have for simple linear regression, and for multiple linear regression we have multiple predictor, right? Can you see over here? And what I have said over here, this will be more than one predictor variable, but one response. You can see the y will be one, but the predictor will be multiple in the case of multiple linear regression. Now, if we talk about the formula, then for simple linear regression, we write y equals to mx plus c. That is nothing but our simple straight line formula. I hope you have already idea about what is this y equals to mx plus c. Y is the dependent variable, x is the independent variable. So these things you have to keep in mind very carefully, and you have to have a very good idea about it, right? As we already said, as a data scientist or a data mining engineer or a data architect, the basic pillars you need to have, that is statistics. You need to know the basics of linear algebra, and you have to have an understanding of one programming language, and then you have to know, how to read the data, how to understand the data. So yes, this particular mathematical part, little bit of mathematical part comes into the picture when we do this type of concepts, right? So now we are going to talk about y equals to m1 x1 plus m2 x2 plus m3 x3. So while we have multiple linear regression, right? So in this case, what we need to do, we have different type of different independent variable, like your predictors, that x1, x2, x3, but your end reach will be y. That is your dependent variable, right? So I hope you do not have any doubt regarding this particular two equation we have for two different linear regression. But this multiple linear regression obviously comes from simple linear regression. All right. Now we are going to talk about how can you understand simple linear regression. So we have dependent variable, we have independent variable, right? Can you see over here? And from there, we try to conclude a relationship between them. All right. Now, if I just move forward, we have two observation, right? So your x1, x2, x3 will be your observation. From there, you will try to find it out a relationship between these observations, right? Now you have multiple observation, right? Can you see? Yes. From there, you will try to find the regression line using that particular formula y equals to mx plus c. So from this particular, using y equals to mx plus c or y equals to mx1 plus mx2 plus mx3 dot 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 plus c. So basically it's for simple linear regression or multiple linear regression. Using the formula, you will try to find a line, right, which is nothing but a relationship between the two different variable or more than that, right? And using that, you will find a regression line which will predict the future values, right? So here you can see we will try to find the regression line, and we will try to find the minimize the error between the predictor, predicted value and the actual value, right? So in the red you can see this is your estimated value, and you have in the blue you have the actual value, right? So this is the line we have. We will try to find it out that okay, this line will be as less as you can, because the error will be that less, right? So you can see the actual value and the predicted value is really different from each other, and the goal is basically minimize the error. The distance between the actual and the estimate value should be less, right? So yes, by using the formula, we try to find out the relationship, and we try to find it out that this particular regression line which will predict the future value points, right? So yeah, this is what about simple linear regression, and with the observation we have done. As we have understood this particular concepts in a mathematical way, then we will try to do these things in Python using different data set, trying to understand different way of doing that, and also we will do a simple linear regression in Python without any data set in order to understand how linear regression works, right? So okay, let's see what we have next. Yes, we have the demo. How can you implement linear regression using Python? In this particular part, we are going to talk about simple linear regression, right? What is simple linear regression? We have talked about that. Now we are going to implement simple linear regression using Python and using Python library in our Google Colab, right? So if you do not know about Google Colab, please do check out the video on Google Colab. So this is nothing but an IDE we have in Python. I mean, for just to do code in Python. So this is provided by Google, right? So now we are going to talk about how can you import packages and classes. So here hardly we can import classes, so we can focus on the packages. So we have talked about Numpy. Yes, so we have talked about Numpy, and we have worked with Numpy a lot in our previous modules, right? So in this particular case, again, we are going to import Numpy as NP. So again, guys, there's a quick question for all of you. If you have actually watched the previous part, you know why we use as NP. So a quick confirmation from all of you why we use as NP, right? Please do let me know in the comment section. For that, we can understand you guys are properly following us, right? And we will like to see all the comments from all of you that you are actually getting to know new things from us. It's always inspiring for us to make new content for you. Okay, so we have two types of variable here. You can see we have independent variable and dependent variable. So dependent variable is dependent on the independent variable, right? That the name suggests, and we all know. Now we are going to use a particular formula that we have said, y equals to mx plus c. But we don't need to use, or we don't need to do it from the scratch, because we have scikit-learn in Python. So what is scikit-learn? Scikit-learn is nothing but a machine learning library we have in Python, where we have all the algorithm implemented previously, right? You don't need to write a program to implement a particular algo in machine learning. What you need to do, you just need to call the particular function, and you can just make your work done, right? So the first first variable x, we are going to initialize that using np array. So we have written np.array, and then we have given 25, 35, 45, 55, 65 and 65. and we given for y viewpoints, that is 5, 20, 14, 32, 22 and 38, right? Now I have just printed. So printing x is 25, 35, 45 and y is as follows. Now the input is x and output is y, right? What I have done over here, but we have used dot reshape function. Why we have used dot reshape? Why do I need to reshape my x? So on x, because of this array is required to be two-dimensional, or to be more precise, to have one column and as many rows as necessary. So what we have done, we have reshaped our array -1, 1. Right? So if you just print x, you can see this is what we have changed the dimension for x. Now, if I just write x dot shape, it's 0 and 1. You can see, yes, this is how we have changed it. Now we are going to create a model to have an understanding of linear regression. So we know linear regression follows what formula? I have said so many times. Again, a quick question from all of you: what formula or what basic algebra, or you need to know, to do the linear regression? A quick understanding from all of you again in the comment section. What is the okay, let me tell you what is the straight line formula we have talked about so far, right? How can we do that? What is that formula? Let me know in the comment section, and then again pause the video and then again start it, because I want you to be more attentive in this particular while you are doing these things, and you have to understand what you are doing. Right? So yes, for your answer, we use y equals to mx plus c. For all the data points you have, we try to understand y, right? So you have x, we try to find it out y. So we have done x and y. Okay. So now in the case of model equals to linear regression, we have done. So you don't need to write it from the scratch. So already linear regression is implemented in scikit-learn. I have written linear regression. So basically I am calling that particular function. So I have created an object of model, and model.feed is while we are going to train your model. We talked about in machine learning, we first need to train our model, then we try to find that how our model is working with the new set of data set. But here, as we are doing the very basic things, first we will try to find it out. First we will do the training, and then we will try to find it out how our model is working, right? So we have written model.feed x comma y, right? So you have just said, please get trained my model with the data points I have in x and y, right? So let me execute that. Yes, you can see the training is really done, because the data set you have, it's really less, right? So once you have the model fitted, you get the result to check whether the model works satisfactorily and interpret it, right? Now I have done the R square. So if I just go back to the presentation, and I will just show you how to find it out, how your model is working. So we have came to the presentation. Now you can see we have done this particular regression line. Now we want to check, okay, our model is working perfectly fine, or our model are giving some error. In order to check that, we use R square method. So R square is basically like used to understand how your model working and how much error you are getting, right? So yes, so in that case, we will try to understand our R square in order to see how our model is going to work. So let's go back to Google Colab and let's see how it's going to work. So to do that, we called a function called score. So we have used model.score, and we have given our data points, that's x and y. So while we are going to give that model.score x and y, we get the output that 0.7158. So in precisely, we can say our model is working 71% accurately, right? So yes, there is a lots of scope we have where we can increase this particular number, But again, as we have a small data set here, it's a very basic demo. This we can say the model is working with the 71% accuracy. Now we have intercept. How can you understand the intercept? So in order to get the intercept, you have to call the again dot intercept underscore, right? You will get your intercept for the model. Then you have slope or coefficient. Again, to understand that, you can write model dot coefficient, that's COEF underscore, you will get this coefficient. These are the, the basic, and you can say these are the core part to understand. That's why we have talked about. Now, if we try to predict the values from, predict the values of y, you have to call model dot predict, and you just need to give x, right? So you can see what you have get over here. So if you write, let me show you. This is really interesting to work with. Okay. Now, if I just write print here actual values, right? And if I just write y, okay, so you will have the actual value, you will have the predicted value. Okay, so as we have written that y predict equals to model dot predict x, so for the y prediction you get 8.3, but the actual is 5. Then you get 13.733 while the actual is 20. Then you get 19.13 while the actual is 14, right? So yes, there is a few changes here and there you have. That's why the accuracy is 71%. The more data points you will have, the more your data will try to, or your data will understand, or your model will understand more precisely, right? So yes, this is the basics of, linear regression we have done. Now we will see one demo of multiple linear regression, and then we will jump into the project, and there I will show you how you can understand your data, the thing we have done, the visualization of data. How can you do that? Everything we will talk about that. I think you are also excited like me to work on these particular projects. Please do let me know in the comment section, and I will happy to answer your all of your doubts, right? And if you like the video, do not forget to like it. And if you feel like, to get updated with the new content we are going to release, do not forget to subscribe. Great learning, right? So yes, if you feel again, this video is going to help you to understand the basics of data mining, basics of machine learning, please do share this video with your friends as well, right? So let's see how can we do the multiple linear regression using Python, and also obviously using the libraries. Right? So let's see how we are going to do that. Now we are going to do demo on multiple linear regression, right? So we have already talked about what is multiple linear regression. When we have like data points, like the independent data points, more predictors, right? That time we go for the understanding of multiple linear regression. If you have any doubt, do let me know in the comment section for understanding of multiple linear regression. Now we will actually implement this multiple linear regression concepts in Python. So the first and foremost things we need to do that importing packages, because we are really pretty much dependent about the packages. So we have talked about NumPy, and I have already given the introduction to scikit-learn. Scikit-learn is basically nothing but we have this particular library for implementing, like already implemented algorithms for machine learning, and we just need to call them, and we just need to call the function basically, and we can ready to use, right? Yes, so this is pretty much about why do we need scikit-learn. Now we are going to just declare our variables, and from there we will try to use this particular concepts of multiple linear regression. So we have x and y, right? I have just zoomed it for your understanding. If you feel like you are not able to see, that's why. I know this letters are really small. I don't have any option to increase the fonts. So here we actually write x equals to 10, 21, 5, 18, 15, 24, 25, 26, right? We have do one. We have just declared the list of list. So total one list we have, and then we have multiple small list. So here y is our what? It's like nothing but our independent, not independent, it's a dependent variable, and x is our independent variable. Now if I just want to print x and y, you can see x is nothing but the list of list and y is like, okay, let me just do that. Okay, so x is nothing but our list of list, right? And y is our, again, the list. So suppose if you just want to print the type of x, so how to check the type of any variable? We need to use type function for that. Yes, so yes, this is nothing but class list. Now if I do the same thing for y as well, type of y, this will be again your list. Now, in multiple linear regression, X is a two-dimensional array with the list two columns, while Y is usually a one-dimensional array. This is a simple example of multiple linear regression, and X has exactly two columns, right? Yes, so that's why what we have done, we have just use x and y to np.array. Now, if I just print x and y after we converted them to array, this will look like, right, x and y. Now, we are going to do the last, not the last. First, then we have done like we will call our model, then we will train our model. After training our model, what we will do, we will try to find it out the result, how our model is going to work, right? I don't want to do this at a time. I just want to show you how we are going to do that. So again, we are like we have written the variable name model equals to linear regression. So we have called our, you know, algorithm, that is linear regression from scikit-learn, right? Then what we are going to do, we are going to write model, right, dot fit. So why we use fit function? You can see over here, fit linear model. And we have few parameters like array like sparse matrix of shape, like for x and y, right? So if you want to know more about these particular functions, this, just click over, like write it and just click over here. It will show everything about that function from the documentation. Right now, if I just write x comma y, so I have given my data to get trained and to get, train my model, right? So let me do that. Yes, can you see it's already trained? So why it's taking less time? While we are going to use a data set, it's obviously going to take more time. The more data you have, the more it will take the time, because the compiler also needs to understand the data points, and they also need to understand how these data points are, uh, connected with each other, and trying to find it out the relationship between them, right? So we actually just calling the function and that's all, but that's not all at all. In the background, we are doing lots of things, like the library itself, it's doing a lots of things to understand these data points, to get a relationship between them, and also predict the future as well, right? So yes, using machine learning, we know we can predict the future. But that's not that easy, right? You have the data, understanding the data, from those data, finding out the relationship, and then find out the future. It's really time taking. When and like while we will have a lots of data, right? For this basic purpose, maybe we are just using an array for your betterment of understanding. But yes, after that, we will do few projects like salary expectations based on the experience, and also we will do the Uber caf fare prediction, right? I hope you all are actually excited to do that. And please do let us know what else you want to learn from us. And if you like the video, do not forget to like it. And if you feel like you want to get updated with the new content we have from Great Learning, do not forget to subscribe Great Learning, right? So now how we are going to create the model that we have done. Now we have already trained our model using the data set. Now the most awaited part, the getting results and trying to understand how our model is working, right? So I have written R square, right? R square we use to understand what is the error percentage we have, and also what is how your model is working. Okay, so in order to do that, you have to call the function called dot score, and you have to provide your data set x comma y. So your model is working with the 79% accuracy. That's pretty good, right? Yes. So this is how your model is working. Now, if you want to see the intercept, you have to call dot intercept and then underscore. You will give the intercept for your this particular y equals to m1 x1 plus y plus m2 x2 plus m3 x plus m3 x3 plus c, right? So here we will get the intercept. Now if you want to get the slope, again you have to call dot coefficient function, right? Now last but not the least, we will see the predict response, how your model is going to predict the y while you are giving x, right? So we will call the function called model.predict and we will give x. Okay, so here you can see this is what we have given, and we will do a really interesting thing after that. So you can see y prediction will have all the predicted value according to x. Now what I'm going to do, I'm going to print actual value, right? And also I am going to write y. Then I'm going to write print predicted value and we will write what y print. Okay, let's see how actually it works. Okay. So your actual value is 4. For the case of first one, it's showing 10.87. So yeah, you can see this is pretty much near to them, but there are few different numbers we can see over here. That's why your accuracy is 79%, right? So yes, this is pretty much about this multiple linear regression. I hope you understood this, how to implement simple linear regression, how to implement multiple linear regression, and the most awaited part. For this next part, we are going to do a salary expectation based on the experience. I will show you the particular, data set as well, and how you can understand what is a continuous value data set, how you can understand what is the, how to like use linear regression based on the data set. We will talk about that. And for that, you have to keep tuned to the last till the last of the video. And please do let us know your comment on this particular part. Right. So let's see how can we do the most awaited project of salary expectation based on the experience. So now in this particular part, we are going to do the most, wanted part, that salary expectation based on experience. That's nothing but a project we are going to do. First, before doing that, I will show you how to understand the data set, and from there, how can you start your project building. So guys, what are things I have said while we are going to say it? Okay, we are going to make a project. So first thing that comes into our mind, we have to understand our data set. After you understand your data set, you have to go for cleaning your data. But no, there is one more step that we have just forget. That's not acceptable. That your problem statement. You have to understand what is your problem statement. To understand, after you understand your objective, you can proceed with understanding the data. First, you need to collect the data, and from there, you have to go for clean your data. After you clean your data, you will go for exploratory data analysis. That is nothing but few statistical terms. From there, you will understand your data more, and we will use few mathematical understanding and also machine learning algorithms understanding, which will actually go with your data in order to make a model out of it. After you do that, you will train your model, and after you train your model, you will give a new data set to understand how your model is working. If your model is working, you will go and deploy it. But in this part, maybe we are not going to talk about the deploying part, but yes, till before that, understanding the data to predicting your data set, like predicting your model, how it's working, we will do everything, right? So I hope it's quite interesting for all of you, and you guys are really excited to do that. Okay, so in this case, first we need to understand our data. So I have taken this data from Kaggle to do this particular project. So yes, this is the data set. We have taken salary.csv. So let me show you what is this data set and how you can understand that what type of data set you are going to use while working with regression. So as I have said, regression works with only the continuous values. Now I will show you this particular data set, salary.csv. Here we have only two columns, right? Let me make it big. Okay. So we have a year of experience and salary, right? Maybe you can work with more complicated data, but here we have get the basic data from Kaggle. So here we have seen that if your experience is 1.1, then your salary near about 239343, right? Or if your experience is 1.3, then 46,205. Okay, these are based on your experience. So you can see the salary column we see the label data set, right? What is label data set? So in order to say the label data set, your data can be, continuous data, or your data can be distinct data. So now we are not going to talk about the discrete data in order to talk with logistic regression. Maybe we will talk about that. But in the case of linear regression, we use continuous value data. So you can see we have 39343, or you can say 37731 or 43525. All of them are nothing but your continuous value. From there itself, you can understand you need to go for regression analysis, right? So regression always work with continuous value data set. So guys, if you have any doubt in order to understand what is continuous value data set, please do let me know in the comment section. But I tried my level best to make you understand what is continuous value data set. Well, we are going to do the Uber cafe prediction. Again, I will show you what is continuous value, right? So yes, continuous value, the name itself saying there will be a continuous type value, right? Yes. So while you are having this, you can say, okay, I can go for using this particular data set for regression. Now let's go back to the code file and let's see what we have done. Right. So here what we have done, we have actually imported the packages. So we have imported pandas and numpy. So we know why do we need numpy, why do we need pandas. Then we have matplotlib and seaborn for the data visualization, as we already knew. So here I just want to show you one thing. If you want to upload the data set in Google Colab, you have to click over this particular button, and from there you will get option of upload to session storage. You can directly, if you click over there, it will redirect to your local system, and you can actually upload the data set you want to. So in this case, I just upload this particular data set, right? So that is salary. Okay, so you can do that. I hope you don't have any doubt on Google Colab. If you do have, please do check out our video on Google Colab, right? So I have imported pandas numpy, I have imported matplotlib seaborn, and now we are going to read CSV file. How can you read a CSV file? We have called .read underscore CSV from pandas. Yes, we can read lots of type of data set or data description, whatever it is. If you want to read using pandas, you can do that. There are a lot more function they have for that. Now I have written pd.read CSV, then I have given the path. How can I get the path for the data set? Let me show you. Don't be panicked for that. Everything is super easy with Google Colab and also while you are working with Python. So you can see that salary.csv you have. If you click on this three dots, if you click over there, you will get an option of copy path. You just need to copy the path, and here you just need to paste it. It's that easy, guys, right? There is no such thing you have to do like so many ways to understand the path. No, right? So we have written pd.read CSV and we have given the path, and our data will be stored in a data variable. Now, if you just want to see your data is loaded or not, what we use one function called .head. What .head does, as the name suggests, it's going to give you the head portion of your data. So what is the head portion of your data? In default, it is going to return you the first 5 rows from your data. So data.head. Okay, right, you can see this is particularly data.head, and your data is uploaded to, or you can say loaded to data variable. Now, if you want to see the last 5 variable, like last 5 rows from your data, you can write data.tail, right? It will show you the last 5 rows from your data. So total maybe data you have 34 records you have, and yes, this is the last 5 rows. Now we will see few things. Now if you want to see what are the columns I have in my data set, a sudden question pop up in your mind. So yes, it's not a sudden question. Again, to understand your data more precisely, we need to understand what are the columns we have, what are the continuous value we have, and what is the data type of the all the columns. We will see how we can do that. Also, we will have a look at the cleaning data. In order to clean the data, the null value, oh my god, there are a lot of things. So yes, to understand all of the things one by one, you have to keep tuned to the last of the video, right? And if you like it, again, do not forget to like the video, do not forget to subscribe. Great learning. So we have used dot columns. So data dot columns is going to return you all the columns you have in your data set. If I just do that, what are the columns we have? Just 2 columns we have for this particular data set. We have years of experience and salary. Now, let's check the dimension of that data set. What is the dimension we have for the data set? So, in order to get that, what will be my answer? We have to use data.shape, that 35, 2. So you have total 35 rows, right? And 2 columns. Okay. Yes, this is how your shape is going to return you. So dot head already we have done, and now we are going to use data.describe. What describe does? So describe is going to give you the total count of your data. Then what is the mean value, right? Maybe in the case of year of experience or in the case of salary, what is the mean value you have? Then we go for standard deviation. That is in statistics one of the most used term. Then we have interquartile range. Maybe it's a 25%, maybe it's 50%. We have talked about IQR, right? Yes. Then it comes to 75% and max value you have in your data set, right? So we use data set in order to understand our data more precisely. Now we will go for missing value detection and treatment. If you have missing value, then you have to go for understanding the where you have, and you have to remove them, or you just need to replace them with mean or median, right? So the following values in the data set are considered to be missing value. What are those values? Blank values, or if you have nan value, or if you have null value, right? Or one more type of value, that is some continuous columns, right, have zeros to indicate missing data. Let's see, do we have something like that? If we have something like that, then we have to have a good treatment for that for our data set, right? So in this case, we have written data.info. It's going to give you the info about your data set. So my year of experience, and there is no null value, and the data type for this row 64. And for the salary, we have 35, no null value, and the data type is integer 64. Now, if we want to check again to make sure that do we have any null value, we have to use one function called data.isNull. If you write data.isNull, you can see that for each and every rows, it's giving you false, false, and true, right? But I don't want to see like that. I want to see, do I have any null value? Please show that, right? So in this case, what we have written data dot is null dot any. If you have any null value, it will return you true. Otherwise, it will return you false. So now we do not have any null value. That's why it's returning you false. Now, if you just want to see the summation of the null value, how you can do that? In order to do that, you have to write data.isNull.sum. Right? So summation will give you, do you have any null value? It will only give you the summation. So you can see the year of experience, the null value is 0. The salary is 0. So basically what we can easily say we don't have any null value in our data set. Now, if I want to visualize my data based on salary and year of experience, as we have only 2 columns, but most of the cases you will have lots of columns to again understand your data more. So what we have done, we have written plt.plot and we have given x and y, that data of salary and data of year of experience. So you can see this is what we get as a year of experience and the salary. All right. So you can say for 2, this is near about to 40,000. While you are having a more experience, you are going to get a good salary again. Right? Now what we are going to do, we are trying to find it out the expectations. But before that, we will try to understand the correlation. So this plot will help us to understand if there is any multicollinearity in the data set. Right? How we can do that? We have written PLT is basically Matplotlib, plt.subplot, and we have given the figure size 20, 10. Now we have given the data dot correlation to understand the correlation between different columns you have. Right? Can you see, is it correlated or not? So we have used again heat map from Seaborn. And if we just execute that, you will get us beautiful looking, metrics like this, right? This is nothing but your correlation tricks in order to understand is your data correlated or not. So obviously total experience and total experience will be 1, 1, and this will be 0.98, 0.98, obviously, right? So this is something you can totally understand how it's going to work. Experience. So year of experience to year of experience 1, salary to salary will be 1. So obviously this will be the high correlation. But in the case of this 0.98, 0.98. All right. So this is what and how we are going to do the correlation. Now, after we have done the correlation, we have to go for making a model in linear regression. But before that, we want to just, divided our data set into 4 parts. One is training, one is testing. So basically, you have two particular, okay, I will show you how can we actually make it 4 parts. For now, we just understand we have to break our dataset or divide our dataset into 2 parts. One is for training, one is for testing. Now, while it comes to training, we will give our data in the training part to see how our model is working. In the case of testing, our model will not see the data. While we are going to do this particular testing with the new dataset, that time only our model will see that. Okay. Now what I have written from sklearn.model selection, I have imported train test feed. Okay. Just don't look at here right now. Okay. Let me do that. Now what I want to do, I want to split my data set. Okay. How we can do that? So before splitting our data set, I want to do one thing. So I have written data.drop. So as we were saying, while we have data and we will have a, yes. So as we are going to have the salary and the year of expectation, year of experience. So in that case, what's happening? Our data of salary, right, is your like label column. Okay. So we try to predict that only. So we will drop that particular column from our data. So we are going to write data.drop. Then we have dropped salary and we have stored it to X. And now Y will have your salary column, right? So you have understood X and Y. Now, if you just write X, after doing this, if you just write X and Y, let me just print X and Y. Print X dot height. So you can see what is X and Y. So your X is year of experience and your Y is nothing but the salary. Just do that. So this is year of experience, right? And your Y will be your salary. Yes, so your Y is salary and X is experience. Now we are going to make it 4 parts. But we have 2 parts already. Now we are making X of train. Matlab X train is basically your experience. X test your experience for testing part, Y train is again for salary for the training part, Y test is salary for testing part. So we have called train test state function and we have given XY. Now we have written test size equals to 0.2. What does that mean? Because you can say that training part you are going to use the 80% of your data set, and the training purpose you are going to use 20% of your data set. And while we are writing random state equals to 42, it will take randomly data. There is no such rule. The first 80% will go for the training and 20% will go for testing. No, it will take any data from anywhere and it will basically just mix the data, right? So that's why we have written a random state equals to 42. Now, if I just write from scalar.linear model, and if I just import linear regression, then we have called our regression model. That is linear regression, right? After we called our model, we have written L.fit. So basically, we are going to fit the model with the data set, that is X train and Y train. Okay, and then we have the prediction. Then we have written ypred equals to L.predict and then xtest, right? So you have given your testing data. Now I will show you what is your, predicted value and what is your actual value, right? So your ypred will have all the predicted value. Now, if you want to get the score, what is the score for your predicted value? You just need to write L.score. It will give you how your model is working. And you can say 89% with the 89% of accuracy, your model is working. Now, if I just do one thing, print actual salary, then comma, we have written Y. Y, right? Okay. Or we can write Y test. Okay. Now here we can write print predicted value with salary. Then we can write Y print, right? Let's see. Okay. So your actual and predicted is okay. Y test. Okay. Let me check why it's showing that. Okay. Okay. So let me write Y over here. I'm not sure this is okay, right. So here why it's taking this. Okay, fine. Right. So we have done this over here. Can you see this is your predicted value? And if I just write the actual salary here, so these are your predicted value while it's talking about that. Yes, can you see? Yes, so this is your actual value and that was your predicted value, right? So this is how we can do the salary expectations based on the experience, right? And this is how we can make a model out of it. And we can do say, okay, if you have experience like this, then my model is saying your predicted value or your expected salary will be this, right? I hope you like the project. Please do let me know on that, what you feel about it. And also do not forget to like this particular video and do not forget to subscribe. Great learning. Then we will again do a mind-blowing project on Uber data analysis and also the CAF fare prediction. Right? So please let me know your thoughts about this particular project and then we will move forward to the next project. In this part, as we have already talked about regression, what is linear regression? How can we actually use linear regression technique? And where are the data set you can go for? We have talked about everything. We have done one project on linear regression as well. Now, in this part, we are going to do the Uber data analysis and we will try to predict the fare price, right? So what are the library we are going to import for that? Numpy, Pandas, Matplotlib, Seaborn, and also we will import linear regression from scikit-learn, right? And what are the data set we have? We have data set of cabrides.csv and we have data set for weather.csv, right? So these are the data set we have. Now, if you just want to talk about cap data height, right, what it will give? It will give you your cap data, right? And we have weather data. So here you can see we have distance, cap type, timestamp, destination, all these things. Now, if you want to see the columns for that, okay, we will do this later. So now if you want to see the columns for that, what do you need to do? You just need to write cap_data dot columns. So it will give you all the columns you have in the cap data set. Now, if you want to check the shape of the data set, what do you need to do? You just need to write cap_data dot shape, right? So you will get total how many columns you have, total how many rows you have. So you have column of rows of 693071 and you have 11 columns, right? This is pretty much big data set you can see from here. Now if you want to check the weather data set that we have read as well, so in this case you can see let me just show you the weather data set. So in this case we need to write weather_data dot height, right? Okay, so you can see this is the weather data set. Now if you want to see more things about the data set, not the text one, I want to have the code one, right? If you want to see the shape of the data set, let me do that, weather dot shape, right? So the weather data_data dot shape, right? So yeah, what you will get? You will get 6276 data. I mean total rows you have and 9 columns you have, right? Now what I'm going to do here, you can see we have done this column shape, all the basic things is done. Now I just want to change my date time, right? So before doing that, let me describe my data as well. Cap data dot describe, right? What you will get? Okay, let me the parenthesis. Okay, can you see? For distance, timestamp, price, search multiplier, everything you get about the describe one. And I know you guys have idea about why do we need to use describe. Please do let me know in the in the comment section. For that I can understand you guys are how much you guys are reminding that why do we use describe, right? And if you like the video, do not forget to like it and do not forget to subscribe. Great learning. And one more thing I just want to update you guys that if you feel like you have any doubt, please do let us know in the comment section. We are happy to help you, right? So yeah, this is about the describe, this is about the info you get. Now I just want to change my cap data date type to actual date time. For that, what I need to do, I have to import date time, and then I have written cap data. From there, the column name date time equals to pd dot to underscore date time. So anything you want to change, you need to use to underscore date time, and then in the parenthesis your name, like which name and the data you have given. Now for the weather also we did the same thing, right? We have changed our date time column into actual date time, right? Now we have done the shape, we have done this. Now what we want to do, we want to go for again description. Here description, you can see this is the timestamp you get, right? The distance, price, search multiplier you get over here, right? And this is the describe for this. Now if I want to just concat the two data set, right? We just want to concatenate two data sets like cap data and weather data. How to do that? We have just used pd dot concat and we have given the two data set, cap data and weather data. And now A will consist of all the concatenation of two data set. Now I have written, now I just want to see my data set. After I concat them, I'm going to write a dot hit. Let's see. Yes, this is my data set. Here I have distance, cap type, timestamp, destination, source, price, search multiplier. Here I have ID, product ID, name, date time, pressure, rain, humidity, right? So this is what we have done. Now, if I just write, want to get the day and the hour, how to do that? In this case, time.dt.day, right? And a of hour equals to, basically we have changed, like, do this data pre-processing to make our data more perfect. Now if I just want to okay, no, I don't want to fill nan values. Okay, here first I want to show you what are the nan values I had. Okay, it's taking time. Right. Cool, let me just do this again because I want to do this one more time, because I want to show you what are the, like, how many nan values we have, right? Let me show that. Okay, after that, I just don't want to fill my nan values with 0. I just want to show you a dot is null dot any, right? If I have, then I'm going to use the dot sum function. Yes, I do have lots of null values, then I just want to use dot sum, total summation of the null values. Okay, we have a pretty good number of null values. We can just need to fill that it with 0. Let me fill that with 0. Okay, so we just cannot we go for so many null values. What we can do, we can fill them with the median, or we can fill them with the 0, anything you want to go for. Now I just want to group by the cap type, and I want to get the count of that. So total type of cap type. So cap type is lift, uber, you get. Can you see? This is your cap type. Now if you want to, group by cap type and count, and then if you want to plot the bar plot, yes, this is how you can do that. Dot count plot dot bar. So this is the color code you have for distance, timestamps and all, and this is the cap type you have, right? This is lift, this is uber, right? So you can see this, all the parameters you get for different cap type, right? Now if you want to see the price, how can you do that? What I have written price dot value counts dot plot, then bar, and this is like what color I want. Can you see? This is the price plot, right? The value counts right here. Okay, now if you want to see the hour, like this is nothing but the data visualization we have done. For hour you can do the bar plot, and then here we want to do the plot, like what hour basis price. So this is what we get, like this is the hour, this is the price, and then we have plot them, right? And this is for rain and price. Suppose it's raining, and if you want to change, like see the what is the price difference and what is the plot, it's for the data set you have, the data points, this is what you get, right? And these are the columns again, now for making the linear regression model, what are the things I want to take? I want to take distance, temperature, cloud, pressure, humidity, wind, rain, day, hour, surge multiplier, and clouds. And for the prediction, we are going to take the price. Now, from scikit-learn model.selection import 10 state split, we are going to, split our dataset into two parts, training part and testing part. We have four things like X train, Y train, X test, and Y test. So 25% of the dataset will be test size, and 75% of the dataset will be train size for that. Now I have just written linear dot fit, and I have given my X train and X train and X test. Right? So this is how we have done the linear regression, train the model. Now if I just want to predict, so linear.predict, then you have to provide Y train. Now if you want to check the actual price versus the predicted price, so your actual price is 42, it's showing 32.54. Here it's 32, it's 16. Okay, so there are here and there, like it's here 7.5, it's showing 10. So these are pretty much near, right? You can see 9, 11, 8, 11, 27. This is again some here and there is there, right? So this is what we get for, like, after putting the linear regression. Okay, and yeah, so here you can see we have written the df.head, and you can see here, like, can you see? This is what we have done, the data visualization, and this is what the actual versus predicted value you get, right? And if you just want to print the prediction for this, let me do that, right? So we have done, yeah, these are your prediction values. So we have done our linear regression concepts. We have talked about diabetes prediction using linear regression, not diabetes prediction. We have done the outlier detection using PIMA diabetes 1, right? And for salary prediction, we have done the linear regression one, right? So we have done two projects on linear regression. One is salary prediction using based on your experience, and one is UBIT data, right? So I hope you like it, and if you like the video, do not forget to like it and do not forget to subscribe. Great learning. In this part, we are going to talk about the logistic regression. That is also comes under one of the supervised learning technique in machine learning, which used for classification algorithm. Now let's have a look at what is logistic regression. Logistic regression is also a part of supervised learning classification algorithm that we already know. It is used to predict the probability of a target variable. Yes, it's basically used to predict the probability of a target variable, and the nature of a target or a dependent variable is discrete. So for the output, there will be only two classes will be present. As we have talked about the dataset of diabetes dataset, so we need to try to find it out the particular person is diabetic or not, depending upon the other dependent variable. The dependent variable is binary in nature, so that can be either 1 or 0, yes or no, true or negative, right? So this is how you can understand that this will be only two classes we will have. The logistic regression is also known as sigmoid function. We have a function called sigmoid function, and we use this particular concepts in logistic regression. The formula for the sigmoid function we know, that is 1 by 1 plus to the power minus value. Now, if we talk about how actually logistic regressions comes into the picture, and if we just go back a little bit and we just try to understand the linear regression. So in the case of linear regression, as it's a regression and it's a continuous value we use for that, we use a one particular formula that for that y equals to mx plus c, the straight line formula. So in this case, if we just put that particular formula for this, the case of the finding out the size of the cat. So we know the size of the cat is 2.1 into weight plus 4. So maybe if we just write weight equals to 0, then also the predicted size for that cat equals to 4. Is it really possible the particular cat has a 0 weight but the size is 4 inches? No, right? How even it's possible? That there where actually linear regression fails and the logistic regressions comes into the picture. So we can see the logistic regression is similar to linear regression, except it predicts whether something is true or false instead of predicting something continuous like size of cat, right? So here you can see the probability of cat is obese here, and the probability of that the cat is not obese is there, right? So there you can see this is the probability of cat is obese and this is the probability of cat is not obese, right? So here we are just going to predict yes or no, true or false, and this is where logistic regressions comes into the picture. So if you can see, if you get your point and probability near to 1, we can see there is a high probability of the new cat of being obese, and if you get the probability near to 0, you can say there is a high probability that the particular cat is not being obese, right? The curve tells the probability of the cat being an obese based on its weight. So this is the S curve. This is known as the S curve. Basically, we use in logistic regression, right? So this is like little bit about logistic regression. So if you get your point near to not 0.5 and 0.5.5, there is a 50% chance that the cat is obese and that cat is not obese. The curve tells the probability of the cat of being obese and based on its weight, right? So this is how this logistic regression works. So if you get the point is near about to 0, the very low probability of the light cat being an obese. So it's generally used for classification. For example, if the probability of a cat being obese is greater than 50%, we use a threshold value. So if we see the probability of the you get the probability which is greater than 50%, then it is classified as obese. And if it is less than 50%, then it will be classified as not obese, right? So this is how our the logistic regression works. Now if we just look at the mathematical explanation of logistic regression, from where this logistic regression comes, so logistic regression is a special case of linear regression, we can say. So we know for linear regression we use a formula that is y equals to mx plus c, and in the more data points we use y equals to m1 x1 plus m2 x2 plus dot 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 and so on, where we are going to use a function in logistic regression that is p equals to 1 by 1 plus to the power minus y. This is nothing but your sigmoid function. Now, if you just replace your m1, just p, what we have basically here, if you can look over here. So if you just have e to the power minus y, so if you just replace your minus y equals to m1 x1 plus m2 x2 dot 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 and so on, you can see you will get the formula of logistic regression. So this is nothing but related to linear regression, but here we use classification. So we do yes or no, true or false, obvious or not obvious, and so on. So this is something about logistic regression we learned, right? So if you just want to check the real-time use cases that come under logistic regression problem, maybe you just need to, will that property have a good neighborhood? Maybe that property have a good neighborhood, maybe not. Is this mail is a spam mail or not, right? So these are the things you can understand by using logistic regression algorithm. Now we will talk about the few key points we have in logistic regression. That is, it's a categorical variable, solve classification issues, not the continuous value problems. It has a S-curve, and it is like the example of it is the mail is particularly spam or not. So yes, this is all about logistic regression we have learned so far, the mathematical explanation of logistic regression, why logistic regression comes into the picture, and what are the key points we have in logistic regression. Now we are going to do a project on logistic regression, that is credit card fraud analysis using this particular algorithm, and we will see that particular transaction is a fraud transaction or is a genuine transaction. In this part, we are going to talk about credit card fraud analysis using logistic regression. In this part, we are going to do an end-to-end project using logistic regression to find a transaction is a fraud transaction or not, right? So in this case, we are going to use a data set from Kaggle itself, and we have actually uploaded this data set to Dropbox. Now, if I just want to show you the data set, so in this case, let me just show you what we have in the data set. But before start with the data set, we just need to understand that what are the things we have in the data set. So always look into the raw data to have a good understanding of your data, right? It's too big. Let me just download it. Okay. Right. So here it's not getting downloaded, but it's already there in my local system itself. So if I go here and let me just write credit card. Right here. Let me just open the data set to make you understand what we have in the data set itself, because we have talked about we have few types of data sets. One is continuous type data set. Your dependent variable will be continuous type. One will be your data set will be categorical data set. So you have classes. So here we will have two classes. One is the transaction is a fraud transaction, or the transaction is a normal transaction. So it's a big file. It's a big CSV file, that is comma separated file. So it is taking little time. So when it's going to be open, and I will show you what are the columns we have in our data set. Basically in the data set, we need to check few parts, that is dependent variable, independent variables, and what is the type of your data set. So this, your dependent variable is a continuous type, or your dependent variable is a categorical type, right? So in this case, our data will be categorical, as we will have two class, right? So it's almost 92% yes. So if you just look at the data set, you can see we have time column, then we have V1, V2, and so on. And lastly, we will have amount column, and then we will have class column. So the amount is nothing but the what is the amount of the transaction you have done, and class is 0. Basically, this is a genuine transaction. If the class is 1, do we have anything 1? If we have 1, then the transaction is a fraud transaction, right? Let me just check. Do we have? Did we just missed one? Okay. So if we have 1, so that means that transaction is nothing but the fraud transaction. Let me just check more. So it's a big data set itself. So if I just scroll it down a little bit more, did I get any transaction with 1? No, I don't get it right away, but it's fine. So let's go to Anaconda and not Anaconda, let's go to Google Colab and let's have a look at how to go with the data set, right? So I have just uploaded the data set to Dropbox, and there you will get this shareable link. And in the shareable link, you can use in the Google Colab itself. Now, if you just look at what are the libraries we have imported NumPy, Pandas, Matplotlib, then matplotlib.pyplot. This is .pyplot is nothing but it's a MATLAB, right? You can directly use the MATLAB function. So this is why we use .pyplot. Then we have model selection, that train trace split from scikit-learn to split your data set. Then we have classification report just to check what is the report accuracy. Then you have confusion matrix. We will talk about what is confusion matrix. Then we have import the logistic regression, as we are going to use logistic regression. And from there we have matrix and Seaborn, right? Seaborn is also a data visualization library, right? So this is the dataset link, right, from the Kaggle itself. If you just click on here, you will just redirect it to Kaggle website itself. It's an open source data. Anyone can use it, right? So this is all about the data, right? You can see this is the data set, right? So you can directly download it from Kaggle itself. Just click on download, your dataset will be downloaded. Now, if you don't want to upload your dataset into Dropbox, then how to upload directly? Here is a box sign you can see. Click over here. Here you will get an upload option. Just click over here. It will redirect to your local system wherever you will have the the dataset. Just suppose technical support data I have. Just click over here and then open. It will automatically upload the dataset, right? Let me just do that. Right, so you can see your data is already here. But be sure this data, whatever the data you have uploading in Google Colab, it will stay for only 12 hours. After that, it will be recycled, right? So whatever the work you are going to do in Google Colab, make sure that you have downloaded. Right, now we need to use the .read CSV function from Pandas. So .read CSV function, how it works, it's nothing but it's going to read the comma separated values, right? So in this case, you have to give the path for your data set. But wait, from where we will get the path? We have just uploaded the data set. So here you can do one thing. If you just hover over this data set you have, and you will get 3 points over here. Just click over here, you will get the option for download. If you want to delete the file, delete. Then rename if you want to rename the file, and copy path. So if you just copy the path and if you just put the path over here, it will automatically read the .csv file. Right? It's automatically reads. Right now, if we talk about the dataset, it contains 285000 rows and of the data and 31 columns we have. The most important columns are time, amount, and the class, that is fraud or not fraud. Right, and if your class is equals to 0, it's not a fraud transaction, it's a genuine transaction. If your class equals to 1, it's a fraud transaction. Now, if we just want to see the first 5 rows of our data set, how to do that? You just need to use data df, where we have actually, if you can look at the variable, we have stored our CSV file, that is data df, and if you just write data df dot head, you will get the first 5 rows of your data. Right, can you see time, v1, v2, v3, v4, and so on, and amount and class, right? You have. Now, if you want to check the shape of your data, how to do that? You just need to write data df dot shape function. It's going to return you how many rows you have, how many columns you have. So we have total 284807 rows and 31 columns. Right, now if you want to check the describe, so where to use describe? And one more thing I want to show you, if you want to check the columns, so data dot column. So basically it will return you what are the columns name you have in your data set. Sorry, it will be data df, right? So what are the columns you have in your data set? So these are the 31 columns I have in my data set, right? Now, if you want to check the describe, so describe is nothing but it's going to return you some statistical information about your data set. So particularly for this 3 columns, I want to check the statistical information of my data set. So in this case, I have written amount, time and class, right? Can you see the list I'm providing here? And then we have using dot describe function. So if I just click over here and just execute it, you can see we have total count of the data, you have the rows, then you have the mean value, right? What is the mean of your total column? Then you have standard deviation, then you have minimum amount you have in your data. Then we have IQR, that is interquartile range. So interquartile range, if you want, if you just divide your data set in 4 different parts, first quantile, second quantile and third quantile and so on. So this is 25%, 50%, 70% and max. So this is all you will get about if you just use dot describe function, right? Now it's just columns is already done. Now we are going to check, is there any missing value do we have in our data set? As we have talked in that as well, this missing value, if you have missing value in your data set, it's not going to provide a good prediction for your data. It's always give you some, arbitrary predictions, and it's also not perform well, right? So in this case, make sure that your data does not have the type of the missing value will be really less, right? So in that case, to check with missing value, what we need to do, we need to use one function that is called dot isany function. Let me just cut this part, right? If I just use datadf dot isany, that time you can see it's going to provide me for each and every rows and columns, right? Maybe for each and every index itself, it's going to give you, is there any null value is there or not. But looking at this like this, it's not possible to, you can see the most of the cases is false. But maybe there is a true, maybe you will not able to find it out. That time, we are going to use a function called dot any. So dot any function, what does this dot any function? It's going to check for each and every column, is there any null value is there or not. Is there any null value, it's going to return you true. Otherwise, it's going to return you false. Normally, it returns the Boolean values. For time, there is false. For all the cases, you can see there is false. So we can say there is no missing value. Now, if you want to again reconfirm it, we have done a manual job, right? So what we have done, we have used the columns, and we have actually making a data frame here. Here we have columns that datadf.isany dot sum. Is there any isany? That what is the sum of the dot, null functions we have, or not the null function, not the null value basically we have. Then we have if you have then dot index, then number of null values, right? So what is the number of null values you have? Then values, then percentage. So basically we want to check what is the percentage of the null value we have. Now if we just print it, so what we will get columns, the column name, we have the number of null values, that is 0, and lastly we have percentage. What is the percentage of null value we have? So here you can see this is all as 0, right? So we can say the null value percentage is 0 for this particular data set. But normally for the real-time cases, you will not get a data which has 0 null values. So always you have to try to understand how to find it out the null values and the missing values as well. So now if you want to check the last 10 rows of your data from the class itself, you just need to use dot tail function. Can you see? We got it. Now we are going to check the percentage of total number of fraud transaction. So I want to see what is the total number of fraud transaction we have. So in this case, we are going to use one particular variable called nf count, right? That is equals to 0. Now what I have done, not fraud, right? Or maybe you can make it genuine transaction. I have written not fraud equals to data df, and we have taken only the column that is class column, right? Now we have used one for loop for I in range, and then it will go till length of the not fraud, right? So it's basically doing what? It's taking the length of the, let me just show you what we are doing here. So this is something not fraud transaction. We were taking the class itself, right? So here, if I just write not fraud, right? So it will give you what the total length of your data. So your for loop will run or execute till this 284807, right? Now what we are going to do, if I have written not fraud, this particular variable equals to 0, then we are going to count the nf count equals to nf count plus 1, right? So basically we are trying to find it out the total number of genuine transaction we have in our data set. So in this case, you can see, yeah, let me just print it here, right? So firstly, we will try to find out the total number of not fraud transaction, and then we will do the percentage of that, right? So here, if I just print it over here, can you see the total not fraud transaction, that is 284315. The total number of length of data we have 284807. Here we are getting not fraud, that is genuine transaction, that is 284315. So we can conclude one thing from here, that the fraud transaction is really less in our data set. Now if you want to check the percentage of it, the normal percentage formula, we have just taken nf count divided by length of not fraud transaction into 100, right? So not fraud transaction is nothing but the total length of the column, and nf count is basically the total genuine transaction into 100. If I just print it, the percentage of not fraud transaction, or the percentage of total genuine transaction in the data set, is nothing but, you can see, 99.82%, right? So there is very few transaction we have as a fraud transaction. Now we will do the same thing to find it out the fraud transaction. So we are going to take if count equals to 0, one more variable, and from there we have fraud equals to data df and class. Again, we are taking a column of class. Now we have written for I in range, the same thing, the length of fraud. Then if we have written here, let's look at this if statement, the conditional statement. We have written if fraud of I equals to 1, then only if count equals to if count plus 1. It's nothing but the small logic, right? From here, if I just write, let me just, okay, different sale for like the different one. So here, if I just write the if count, you can say the total fraud transaction in our data set, that is 492. Now, if I just print out the percentage of the fraud transaction, that is 0.172. But yes, we do have fraud transaction. We cannot ignore it, right? From here, we are trying to find it out the visualization, the data visualization for genuine transaction and the fraud transaction. So here for data, plotting the data, right? So here we are taking one data frame. First, we have created our empty data frame here, plot data, that pd.data frame. So this is how you can create a empty data frame. From there, the plot data equals to fraud transaction. So fraud transaction, the column name will be fraud transaction, and we have written the fraud. So what we were doing, we were actually trying to figure it out, what is the percentage of fraud transaction you have in your data set, and what is the percentage of genuine transaction you have in your data set. So for that, what we have done, we take a variable called nf count, and this is equals to 0 because it will work as a counter, right? Now what we have done, we have written not fraud equals to data df, and then you want class, okay? So whenever, let me just add one cell over here. So whenever we try to get like particular cell, like a particular column from your data set, that time what we have done, so we try to take the particular column name, right? So for my case, I'm going to take class, right? So you can see what it actually have. This class is nothing but your outcome, and it is a dependent variable or on other columns you have. And in here, you can see it's not fraud equals to, we take the whole class, right? So now what we are actually trying to do, we will try to count all the one, right? It's not fraud. So basically, we will try to count all the zero, like how much zero you have in the particular column, and divided by the total number of records you have into 100. So that's how we can actually understand the percentage of genuine transaction in your data set. So in this case, what we have done, you can see not fraud equals to data df class. Now we have used a for loop and we have written that for I in range length of not fraud. So it will go the length of not fraud. Like for this, you can, if you want to see what is that, let me just write it over here. So not fraud, right? If we can do this two particular place over here, and if we just write one more code cell, let me just execute that. Now what we are going to do, we are going to say not fraud, okay, and here we have used length function, right? So you will get nothing but the length of the not fraud. So total number of rows you have in your data set, so you can see this is 284807, right? So now what we have done over here, we actually, your for loop will walk till this part, right? And if said if not fraud of I, not fraud of I is basically the value you have, not the index number, 0 or 1. So not fraud of I equals to 0. If it's equals to 0, then please increase the counter. My counter is nf count over here 0. It will count 1 plus 1 plus 1, right? Then what we have done, we have done that the percentage. So you got that nf count, right? Here you got the nf count. So now you know how much, like if I just write here after this, if I just, okay, let me just break it in few parts for that you can understand what actually we are trying to do. So here, right. So in this nf count will have all the count of 0 you have in your data set. So you can see 284315 records you have, they are 0. Basically, they are the genuine transaction. Now, what I have done, I just want to understand the percentage. So nf count divided by total number of records you have into 100. So for that, you will get the percentage of total not fraud transaction or the genuine transaction. So 99.82 percentage of data set you have, that is a genuine transaction. Now we will count the fraud transaction in the same way. Again, we will take a counter over here. From there, you can see the fraud equals to, we take the class again, and what we are doing, we are writing fraud of I equals to 1. So we will try to understand how much like data or rows we have with class 1, right? So that basically nothing but your fraud transaction. Okay, so let me just do this as well. Right. So in this case, you will get the if count 492, right? It's a very negligible, but yeah, there are fraud transaction you have in your data set. So now if we just try to find it out the percentage, so it's nothing but 0.1%, right? So this is how we have understood that what is the percentage of genuine transaction you have in your data set and what is the percentage of fraud transaction you have in your data set. Now, if you just need to plot it, right? How to do that? In this case, you have written plot data equals to pd.dataframe. You have created a empty data frame over here. Now you have written plot data fraud transaction equals to fraud. So the fraud you had, right? Now you just give plot data genuine transaction, right? Genuine transaction equals to not fraud. Then plot the data. So here what we have done, if you can look over here, right? So not fraud, it will become your if count. And this will be less, I think, right? And it will be nf count if I'm not wrong, but it's, yeah, right. So here you can see one thing, your fraud transaction will be, so you basically try to understand your fraud transaction and your genuine transaction, right? So in this case, what you have done, if we just remove this two part, right? Let me just do that. And let me just write plot.head. So basically you can do it, otherwise you can skip it as well. That's not the problem. Plot data. No, it's not coming. Why? Acha, okay. Fine. Why it's not coming? Because this f count is nothing but your total number, right? And this is how basically you can skip this part. There is no point of using. But yeah, if you want to make a data frame out of it, or if you just write the transactions, maybe you can write the transactions. and you can use the data df. Now if you just try to print it, you can see only the transaction, only like the class column you will have in this particular data frame. Now what we need to do, we try to understand and visualize our data. How to visualize our data? We try to understand that what are the data are actually going to help us to understand what is the bar plot. We actually do bar plot to understand visually that what we have done, the calculation that is right or wrong. So in this case, what we are going to do, we are going to write plt dot, you can say plt dot title bar plot for fraud versus genuine transaction, right? So you can use bar plot or you can use count plot as well, right? So you can see what we have done. We have written x equals to fraud transaction, y equals to genuine transactions, right? And what we need to do, we basically try to give the data set over here. So here you can see what we have done. We were working with that bar plot, but now I want to have a count plot, right? So count plot over here will work as like, it will automatically count. Otherwise, you need to do all the count by yourself. So in this case, what we have done, we have written plt.title count plot for fraud versus genuine transaction, right? So now you know for 0 is genuine and 1 is fraud transaction. So if you just write SNS from Seaborn, basically if you write SNS.count plot, you can see this is the all about count plot. Show the count of observation in each categorical bin using bars. So you have two bin over here, 0 and 1, and a count plot can be thought of as a histogram across the categorical instead of quantitative variable. The basic API and options are identical to those for bar plot, so you can compare counts across nested variables. Input data can be passed in variety of formats and including the vectors data represented. At least there is no point of understanding this, but now you can understand. It will automatically count how many 0 you have in your data set, how many 1 you have in your data set. So what I have I have written that x equals to class, then data equals to data df, your data set, then palette equals to blues, I want the blue, and then age color equals to w, right? So you can see for in this case, whenever I try to execute it, for that you can see the 0 is the high, 1 is almost like negligible, right? So you can see and you can say, okay, whatever the percentage we have, find it out, it's quite right, because in the bar graph in the count plot itself is showing the same, right? So as for the graph, we can see the ratio of genuine transactions and higher than the fraud transaction, right? So now if you want to check the plot, normal plot, how to do, you just need to write maybe for the x and the y, I just want to check between amount and time. So in this case, I have written data df amount and y equals to data df time. And then I have written plt.plot xy, and the title will be plt.title time versus amount. Right. So in this case, you can see this is the relation between amount and time. And this graph, we try to plot the relationship between time and amount. You can see this is the time and this is the amount. Right, x equals to, we did, okay, x equals to amount. So these are the 5,000, 10,000 to 15,000 is your amount, and this is your time, right? How much time it takes to do the transaction. Now if we just try to understand the amount distribution, where the amount is high, where the amount is like, what is the distribution of your amount you have in your data set, that time again we are going to use Distplot, right? So Distplot is a kind of a histogram type of a thing, you can say. So here we are going to try to do the amount distribution. So in the amount distribution, what we need to do, we try to understand the distribution of the amount in our data set. So here we are going to use Seaborn Distplot. So you can see we have taken only the amount column. Now what we have done, color equals to red. I just want the distribution should be looks in red. So in this case, if you look over this, you can check, you can see from the amount distribution curve, it's shown that the number of higher transactions are very low. Obviously, so you can see this is the high transaction are really low. Most of them are in between 5,000, right? And so there is a high probability for huge transaction to be fraud, right? So this is the high. If you see there is a 25,000 and more like amount is high, so at that time there is a chance that your transaction is a fraud transaction, right? So now we will talk about the outlier. So for outlier, we can use box plot and we can use scatter plot as well. So we try to understand, because of this problem we need outliers, because those transactions in a high amount, that time there is a chance that these are the outliers, and these are the cases where we need to find it out that, okay, these are the cases for my transaction can be fraud, right? So in this case we try to use scatter plot. So that dot scatter, if you just call dot scatter, and if you just give it your your scatter plot will be plotted using your data set. You can see this 25,000 only one dot here. So these are your data points. Most of the data points are from 0 to 5,000, and after 10,000 also you have, but after 10,000 all of our is your actually outlier, right? So in this case we need outlier to understand the fraud transactions behavior. And now if we talk about the correlation matrix, yes, there is a concept of correlation to understand the correlation between two different variable you have in your data set. So in this case correlation matrix equals to data df dot core if you write, and if you just plot it with the figure size I have given 14,9, and if you just write a Seaborn dot heat map, it's nothing but it's going to give you the correlation between two different variable for time and time. You can see you can see this is quite white. So this is the color range is also here. When it's quite white type of a thing, it's the high correlated. When it's near to black or blue and something like that, it's the correlation is low, right? So this is how you can understand the correlation between two different variable you have in your data set. So correlation matrix helps us to understand the correlation between two attributes, right? So now, yeah, it's pretty much about the data set. We have done the outlier analysis. We try to understand our data. We try to understand the fraud transactions. Now what we need to do, we just need to split our data for machine learning. So splitting our data is nothing but you can split your data at 80 and 20%, or maybe 70-30%. It's up to you. So 80% for training, 20% for testing. So when you do the model training, that time your model will not see your testing data. So it will be a new data for your model, right? So for that, you can see for x equals to df, data df dot drop. So we try to have all the features in x, and the outcome column, the class column, the dependent column for others will be stored in y, right? After that, what we have done, we use scikit-learn to split our data. We have used, we actually split our data in 4 different parts: xtrain, xtest, where you will have all the features; ytrain, ytest both will have the class, right? And train test split function you have to call, and then you need to pass your x and y. Then you have written test size equals to 0.2, that is nothing but 80 and 20%. If you write 0.3, it's nothing but 70% and 30%, right? And random state equals to 42, because we try to say that there is no hard and fast rule that first 80% will be for testing, will be for training, and 20% for training testing, right? So it's like randomly it will take the data and it will just make your testing and training data set, right? So yeah, it's pretty much about the x train, y train. Now if you just want to check the shape of x train, you can write x train dot shape, right? What you get this 2, 2, 7, 8, 4, 5, 30, right? And if you just do the x test, you can check your shape like this. I will get an error. Okay, right? For testing, you can see 5, 6, 9, 6, 2, and this is 30, right? So this is how your x train, x test, y train, y test works. Now if we are going to use logistic regression, we talked about logistic regression. For scikit-learn, what you need to do, you just need to call the function, right? Because there are a lot of all the you can say all the machine learning algorithm are already implemented in scikit-learn. So what we need to do, we just need to call logistic regression function, and you can see this is the logistic regression function we have called. Now if you want to train your model, you just need to call dot fit function, and you will provide x train and y train, right? Let me do that. Now if you want to check what is the prediction for your model, that time what you need to do, you have to use dot predict function, and this time you are going to give your only the features, and we will try to find it out what the class, right? So whenever you try to use ypred, and we are going to give the logistic regression dot predict x test, And if we just go here, vibrate, right? So here we will get all the cars 1 0 0 0 0 0. So now if we try to understand the accuracy, we need to call one more function, that is logistic regression dot score, and you have to pass x-test and y-test, right? So now if we just try to understand what is the accuracy, so accuracy is 99.85%. So yeah, your model is working pretty cool and pretty fine. And if you want to add few other things, you can, right? And one more thing, I just want to explain that what is confusion matrix. So whatever the accuracy we have done over here, there is one more concept from those matrix as well. You can find it out. So in this case, we called confusion matrix. In confusion matrix, we have few parameters. That's positive, negative, true positive, true negative, false negative, right? So what is positive? Observation is positive. For example, the transaction is true. Then observation is not positive. For example, the transaction is not genuine. Then we have term called true positive. What is true positive? The observation is positive and is predicted to be positive. That is true positive. So both the cases is positive. Now comes false positive. So here you can see observation is basically negative. The predicted value is positive. Then your model is not perfect, like working well. Now comes false negative. So observation is positive, but your predicted is negative. Again, your model is not working fine. Then comes true negative, when the observation is also negative and the predicted is also negative. So when you're have more true positive and true negative, your model is actually working quite fine, because what your model is quite understanding with the new data that whatever it needs to be done, right? So yeah, right. So the formula for accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative, right? So this is known as confusion matrix. And if you want to do this confusion matrix, if you want to check the confusion matrix, you need to write, and you also again need to import matrix, and after importing matrix, you need to call dot confusion matrix function, and you have to give y-test, that actual class, and then vibrate, that is actually predicted by your model. Now if you can look over here, this is your confusion matrix. And if you want to do the calculation of accuracy the same way, and you will get that 99.85% accuracy. With this percent of accuracy, your model is saying whatever you have done, it's right? So this is how we can actually start working with logistic regression. And I hope you understand that how can you start working with your new project on logistic regression.
Having explored the different machine learning approaches, let us know if you have applied these concepts in any of your projects. What did you find most challenging or exciting? Share your experiences in the comments below. Next, we'll look into SQL, focusing on essential DDL and DML commands, views, stored procedures, and joins. We'll also see how Python interacts with MySQL, turning theory into practice with real-world applications. Let's start now.
Now, in this part, we are going to show you how can you install MySQL Workbench in your local system, right? For that, we need to go to our favorite browser. For me, I will go to Google Chrome, and I will show you how can you install your MySQL. So yes, we came to this part. Before that, I will show you from the scratch itself. You are going to write download MySQL, right? If you write download MySQL, first time you will get this link. Okay, just go and click over there. Okay, now you will get this download part. Okay, so if you go down, you can see you will get an option called MySQL Community GPL Downloads. Click over here. After that, they will redirect to a page where you can see lots of community downloads are there. So here you will get router, shell, cluster, workbench, connector, right? Python connector, ODBC connector. This is for Java, Python you have over here. Click on MySQL Workbench, right? Now you will get Microsoft Select Operating System. So if you have Ubuntu, that is Linux, you can go for using that. If you have Oracle Linux, you can use that. Mac OS source code and Microsoft Windows. So for my case, it's Microsoft Windows, right? Now you will get few options. You will get an option called go to download page. Other than that, you will get some other options as well, that's known as other downloads. So don't go to this other downloads page, because maybe it will be have a MSI installer, zip file you will get. So always go for this go to download page. After you go to click on go to download page, you will get this two option. Okay, again mine one is Microsoft Windows, and you will get Windows X 86 32-bit MSI installer and Windows 86 32-bit MSI installer. So as I've shown you that you get two different option. One is X86 32 MSI installer, right, and one is X86 32 MSI installer. Both are same, but if you look at the size, right, the size are not same. One is 24.5, one is 427.6, right? So we want this MySQL installer, right? This is the community, right? This is a web community. So I don't want this web community. I want the community one, right? If you go to download over here, yes, you will say there is download, it's not started yet, because they are asking for login or sign up. But I said, hey, I don't want to log in or sign up. No thanks, just start my download. You need to click over there. So if you click over there, the download will automatically starts. It's a 428 MB file. It will take few minutes of time and it will install, right? Let it be installed that time. Right, it's just showing 30 to 30 seconds left. 281 MB is already downloaded. Let's see. We are just waiting for this part installer to be downloaded, and then we will do the installation process. Right, it's already installed. It's already downloaded. Let me just do that. Show in folder. Yes, it's already there. If you double click over here, right, so the community, the installer community will give you a pop-up that preparing to install. Yes, please wait while Windows configures MySQL installer community. So it will take few minutes of time. Yes, it's gonna ask you, do you want to allow this app to make changes in your device? Yes, right. After that, okay. It's showing it's gonna take 11 seconds of time. Again, they're asking, do you want to allow? Yes, right. It's getting installed. Finding all the packages and everything. Okay, if you look at this, can you see? It's showing me welcome back, because I have already downloaded this before as well. So next, all these things are already there for my case. For your case, maybe you need to install them. Then again, next. Yes, it's all are there. Now I just need to execute, ready to update for that. Yes, I am executing. Let's see, maybe here it will take few time. This is how this is a process. You need to install MySQL in your local system. Yes, it's gonna take a few minutes. Obviously, it's upgrading for my case. Okay, I think it's gonna take a good amount of time. If I can select on show details, you can see the details that's happening right now. Okay, so let's see. Okay, let's wait for a few more minutes and then come back to again to see this. I know it's gonna take a little bit of more time. There are lots of servers is there, Sail is there, router is there, connector for ODBC, C++, J, .NET, everything is there. I mean, they are actually getting updated for my case. When you are going to install it for the first time, it is going to get installed for the first time, right? So give some more time to it. Now here, as you can see, all the required prerequisite is already completed installation. Then you need to click on next, right? Okay. Right. There you will get this starting the server upgrading and updating the start menu link, right? It's working on that. After it's done, then we need to click on execute. So you can see this is configuration steps for starting the server or upgrading system tables. It's working. So after that, the updating the start menu link will be there. This is also will be done, and then we need to click on execute. And for this, we need to wait few seconds. Let's see how much time it's gonna take. So it's already giving like message that it may take long time as it's upgrading the tables and server. So we need to give some time to be executed this part. Right, you can see this is already done, the updating the start menu and starting the server and updating system tables. Now I need to put on finish. So now we will click on next. From there, can you see this is again you need to execute this too. This is already there. It's gonna check and finish. And here again you need to click on next. And then I am going to click on finish part. As you can see, all the part is done. If you look at it, now you need to click on next. Then you have to see, you can see the port number you have, that is 3306. That's the default port. And the pipe name is MySQL and memory name is also MySQL. Then click on next. Then next. So they are asking me for the current root password because I have installed this previously as well. For you, they will ask you a password, right? So my password was 12345678, right? Let it get checked. Yes. So now I need to click on next again. And can you see the port is 80. The service name is MySQL 80. Now, we are using standard system account, not the custom user. Then you have to configure these steps. Let me just execute all of them. So it will not take a long time to get executed. It's gonna updating the file rules, adjusting Windows service, starting the server, and updating the start menu, right? Yes. So they just want to execute that. All are executed. Now just click on finish. Yeah, this is how you need to do all the part, right? The reconfiguration. I mean, for my case, I need to reconfigure because the thing is like 1, 2, 3, 4, 5, 6, 7, 8. My password because I have installed it earlier as well. Now execute for all of them. For all, like if you are doing this for the first time, it will not going to ask you for reconfigure. It will ask for the configuration, right? It's now running the scripts. Let's just wait for a few more seconds. I think it will be done. It will not gonna take a long time. And this is the log file. If you can look at this, the creating sample database schema, data in MySQL server 08.0.21 connecting to port 3306. So now running the scripts. Basically what it will do basically after you install all the thing, you can directly go to MySQL. You can directly write MySQL workbench and then it will directly come. This is the MySQL workbench you have. After doing all the execution process, lastly, you have to give your password that you have given in the installation time. Then you need to check. You can see the status is showing that connection succeeded. So your MySQL server connection is succeeded. Then you have to press next. Then again execute. The last is this configuration steps will be there. And then we will move forward to the installation, the finish process, right? That's all we need to do. We will wait few seconds for that. To get these things executed. Now you can see this part is done. Now I need to click on finish, then next, and then finish, right? Yes, can you see that mysql.lsh.exe already came up? So it's actually basically your MySQL cell is ready to work with. And yes, so if you write quit, it will be okay, so basically you can do this part, otherwise you can just, okay, you got this, right? This part is already came in the back that welcome to MySQL workbench. And if you click over here, right, so if you click over here, as I already have some files, it's showing over here. But this is how we can install MySQL and we can start working with MySQL workbench. It's very easy to install, but it will take some time. So SQL is basically based on all types of command. So basically we have 5 types of commands. We have DDL, DQL, DML, DCL and TCL commands. I know you are thinking, what are these DDL, DQN and DML commands, right? Wait, I will give you a brief and I will show you how can you implement them in MySQL as well. So first, let's start with DDL commands. So basically, DDL stands for Data Definition Language. It helps to define the database schema. Also, it deals with description of the database. Also have power to deal with creating and modifying the structure of database objects. So let's have a look at how DDL works and what are the commands we have under DDL. So we have create command. So why do we use that create command? This command is used to create a database, or it also have some objects. Maybe you want to create a table, index, function, views, store, procedures, and triggers, right? And there comes the drop command. But why do I need to use drop command, right? So drop is mainly if you don't want some of the part of your database, like mainly used to delete objects from the database, right? Maybe you want to delete a table, maybe you want to delete a function, view, store, something like that. Now comes the alter command. So why and where we use alter? Alter, from the name itself, you can understand you can alter something. So maybe it's used to alter the structure of the database. So let me give you an example, like maybe you create a table and after that you want to add one more attributes, which stands for columns. So in that case, using alter statement, you can actually change your structure of the table. So this is how alter works. Then comes the truncate. So what is truncate? So truncate command is used to remove all the records from a table. So which includes all memory allocated for the records are removed, right? So basically truncate is used to remove all the records from a table. Now comes the comment. So this command is used to add comments to the data dictionary. And lastly, we have rename. So what is that rename stand for, right? So this is used to rename an objects existing in the database. Now we will have a look at how can you use them using MySQL. Now we will go to MySQL software and I will show you how can you do these commands. So we have already written the commands. Now I will show you what are the commands and how can you do that. So before start with that, MySQL has three parts, right? One is a console. Over here you can write your data or your language, structured query language. Here you will get your, like if you write one structured query language, that is SQL commands, and if you want to see your query is actually working or not, you can see over here. So it will, if you get a green tick over here, so basically, okay, your commands are running. Your commands are executed properly and you will get a message for that. And if your command has some problem, you will get an error code as well, right? But before that, let me show you how can you create your first SQL script. So basically, this is known as script. Here you can see an option called file, right? You can go from here as well, or you can see over here there is a plus sign in SQL. You just need to click on there, right? And from there, your script is ready, and or you can say your script where like the document is ready where you can write your script. If you want to save your script, how can you do that? So here you will get an option called save the script, right? You need to click over here and the location you gave to save your script, you will get that over here, and you need to give the name of your demo accordingly. But the extension of the demo will be .sql. So maybe you can give demo2 and then you just need to save it. And one more thing, if you don't save your data and the command you have written, so that will be lost, right? So whenever you are going to start working with MySQL, you have to be sure that your data is already saved, right? And MySQL is not case sensitive. So whenever you are going to use MySQL, you don't need to take care of the alphabets. I mean, the alphabets means the hierarchical alphabets, or maybe that's a capital letter or a small letter. You don't need to take care of that. So all you need to take care of the name. So that is why the MySQL is not case sensitive, right? Now we will have a look at how can you create your database. So first, if you want to create your database, you need to write a You need to write a query for that. So here you need to write create the first command, the DDL command, right? So you need to write create, and then I'm going to write database. And then you need to give the name of your database. So for my case, maybe I'm going to give MySQL then demo, right? So this will be my database name. Here, if you want to execute that, you need to select the hold command. Otherwise, it will not be executed. So in this case, you need to select the hold command and then you need to press this sign, right? So you can see there is a pop-up came that execute the selected. Okay, it's gone. Okay, execute the selected portion of the script or everything if there is no selection. So if you don't put any selection, it will execute the whole query. Okay, here one more catch over here, you need to use a semicolon. So whenever you complete your query, you need to put a semicolon. So these are the syntax you need to remind whenever you are going for using SQL or if you are going to write SQL query. Let me just select the part and then I'm going to write a execute, right? You can see I got a message that one row is affected and I got a green sign as well. That means my query got executed. Now, if I want to do the same thing, right? If I want to go for making the same database with the same database name, let's see my SQL software is going to take that or not. Let me execute that. Yes, I got an error message. You can see can't create database, right? It's as it is already exists. So you have to take care of that as well. Whenever you have made one database, you cannot use the same database again and again. So your all database name in MySQL Workbench is always be unique, right? Let me just delete it. Now, what I need to do, I need to say, okay, I have created my database. Now, what I need to do, I need to give a information or a instruction to my MySQL that, okay, I have created a database. Now I want to use them. To do that, we need to use a command called use, right? And under use, you need to give what database you need to add, right? Use, and then I need to copy this part. Right? So this command basically give an instruction to your MySQL Workbench. Okay, I have created my database or already I have this database. Now I'm going to use this database, right? So I said use this. Now let me execute that. Yes, you can see 0 rows affected, but this is actually worked. So now whatever the table or whatever the data you are going to add in your database, it will come under MySQL demo, right? Now let's have a look at what are the other commands we have. Let me go to the previous slide. Okay, so already we have covered create. Now maybe I am going to use a drop command. Let's see if we can drop our databases, whatever database we have made. So we have made our database MySQL demo. Let's see if we can drop them. So dropping them means you are going to delete that database. So let me just write, So I need to write drop database and then MySQL demo. So basically you are giving an instruction to your MySQL Workbench. Okay, I have created this database. Now I want to drop them. What I want to drop? I want to drop a database. So drop database and then you need to provide the database name. That is MySQL demo. Let me execute that. Yes. Okay. Yes, you can see drop database demo is already there and 0 rows affected. But wait, how can I see that this database doesn't exist? So in that case, you can use one more command, like it's called show, right? Show databases. Then you need to just put the semicolon, right? What it will return? It will return all the databases you have in your MySQL Workbench. So let me execute that. Okay, you can see I have lots of databases and here there is no database called MySQL demo, right? I have MySQL database, but I don't have any database called MySQL demo. So this is how we can use our DDL command using whenever we are going to make a database. Now, let me just, re-execute those queries. For that, we can again create our database. Yes, use MySQL demo. And then I am not going to use this, right? And then if I going to execute the show databases, let's see if it's going to show my SQL demo or not. Yes, you can see I already can get this, that my SQL demo. So this database is already there in my MySQL workbench, right? So you can be sure, okay, my SQL demo is already there. Now what I need to do, I am going to make a table. But why do we need to make a table, right? So we all know in SQL or in MySQL, what we need to do, we need to make our table, that is basically our database in a tabular form. So right, we need to go for making our first table. So how can I make them, right? So already I have written over there. Let me just copy that. And then I will just show you how I am going to use that part. You can see I have written create. So basically I am going to use the create command. Here you can see I have written database. So basically I was making a database. Now what I am making? I am making a table. So I have written this is a table. Then I need to provide the name of the table. So what is the name of the table? That is student table, right? Now what I need to give? Okay, my table name is already there. Now I need to get our attributes or the columns, right? So in that case, you need to provide the column name. But be sure about the structure, right? You can see that there is a symbol over here. That means you are writing one query, right? You are not writing multiple query. So in that case, your first bracket or the curl bracket or the round bracket, you can say it starts from here. Then you need to write the attributes name. The first attributes for me is student ID. Then what type ID I want? I want an integer type ID. So my ID is integer. Now I have already explained what is varchar, and I have also given the range of varchar. So you can see student name, my second attribute name is student name. And then I have provided my student name can be a varchar. What is the length of that student name will be? Maximum is 100. Then I have used a comma. Again, I am going to use course name, right? So this is one more attribute for my table. But be sure one thing over here, I am not using any key. I will add them as well. This is the basic part where I was showing you how can you create your first table using MySQL DDL commands. With time, we will go for using keys and how this relation works, right? So course name is basically here. So course name is also your one attribute. That is also varchar, but the length of that varchar is 40, right? Lastly, be sure about the syntax. We need to close our round bracket and then we need to give a semicolon. So this is how you have to careful whenever you are going to make a table. But one more thing, did you just notice that I have using a comma for each and every attribute, but in the last attribute I didn't use any comma, right? If you put a comma over here, you will get a cross, right? You can see there is a cross. That means your query is not right. You need to rectify your query. Maybe we will get some pop-up, but no, over here we are not getting. But this is something, it's showing your query is not right. Please look into your query. There are some mistakes, syntactical mistakes, or there are some like conceptual mistakes, right? So whenever your query is not right, you will get a cross sign like this. Now what you need to do, you just need to copy this and you just need to use an execute button. Yes, so you can say my table is already ready. But wait, how can I check that what are the tables I have in my database? So we can use again the show commands. So show, what I need to show? The database need to show tables, right? Let me just execute that. How many tables I have in my database? Okay, I have only one table, that is student table, right? So this is how you can see the table structure. Already I have shown you how can you see what are the tables you have in your database. But if I want to see the table schema or the table structure, how can I do that? To doing that, we need to use one more command that is called a describe. This is pretty clear, right? So this is how I really love MySQL because of its simplicity. Obviously, it's simple, like it's a normal English, right? I say show tables. Your command is ready. Now I say, please describe my table that is called student table. So first you need to write the command describe and the table name you want to see the schema, right? Let me execute that. So here again, I'm going to execute. Yeah, you can see I got the field, type, null, key, default and extra. But wait, what are these actually stands for? Field is basically what are the attributes you have. Type is basically what are the data types for each of the attribute. Now there comes null. Is your attributes can be null? Did you give that authority to your field that your field can be, your attributes can be null? Yes, for my case, I didn't mention anything. So that means your field can be null. And key, did I mention any key? No, I did not mention any primary key or foreign key. So yeah, this is how it's showing your table schema. So we have student ID, the first attribute, that is data type is integer. Then we have a student name attributes called varchar, which lengths have 100. Then lastly, we have a course name, which is also the type of varchar and the length of that varchar is 40, right? So this is how you can see your describing student table. Now what I need to do, I need to use a alter command, right? So if we go back to the presentation, let's have a look at what are the commands we left so far, okay? So here we came to the presentation again. So we left with truncate, comment and rename. So let's have one more, that is alter. So let's have a look at how can you actually use alter and truncate. So we came to the MySQL again and let's try to add one more attribute for your student table. Let's try to do that, right? So we are going to use alter command, right? Then what you need to do, you need to provide the table name, right? So for my case, student table. Then add what you need to add, columns, right? And then I am going to write email. And what will be the type of that email? Varchar and then 100, right? Okay, but I am getting some error. Okay, I was getting some error, but why I was getting the error? Okay, let me go back to the previous phase. So I didn't mention what you need to alter. So here you can see I need to alter table, right? So you need to specify that. Alter what? Table, and then you need to provide the table name, that is student table. Now please add what I need to add. Add the column. What's the column name? That is email. And what's the length of that? What's the type of that column, right? Or the attributes, that's varchar 100, right? So my data type is varchar and the length of that data type is 100, right? So let me just execute that. Yes, you can see my alter table command is already worked. So let me just check my description of that student table, right? Yes, you can see here my alter email field is already added and the type of the email field is varchar 100, right? So this is how our alter works. Now we will have a look at the truncate command. I have already written over here. Let me just copy this. Okay, so truncate command is also same as the before we have used whatever the command. So basically we are going to use truncate command. Then we need to use what you need to truncate. I want to truncate my table. So basically I want to delete my table, right? And then I need to provide my table name. Okay, so this is student table, right? Let me just execute that. Yes, you can see my truncate table is already done. So if I am going to use the show table commands, let's see what's going to give me. But still it's giving me the tables I have in the database. Let me see the describe Yes. Okay. So we have seen that if we use truncate table, still we will get the table structure in the database. But wait, why do we use truncate table? I will tell you why we use truncate table and how it's gonna work. Before that, we need to learn and we need to understand some of the other DML, DQL language as well. After learning those commands, you can understand how truncate is working and how it's actually deleting the data from the database. So now we will have a look at the second part. What is DML commands? That is data manipulation language. So let's go back to the presentation and let's have a look at what is DML command. So here we can see DML basically stands for data manipulation language. This DML commands handles all the data manipulation part. Let me give you what is actually data manipulation stands for. Suppose you have a table and now you want to insert some data to your table. How can you do that? Using DML command. Or if you want to get some of the particular data from your database, how can you do that? Using DML command. So this is how DML commands help us, or DML language help us to manipulate our data, right? And it also includes most important parts of SQL. So let's have a look at what are the DML commands we have in MySQL. So we have insert command, we have update and delete command. So when we use the insert command, right? So insert, from the name you can understand that when we need to insert data in the table, that time we need to use insert command. And when do we need to use update command, right? So we use update command if we want to change the table structure or if we want to change some of the data in the existing table. That time we need to use update command. And lastly comes delete. So when we use delete command, so we use delete command when we want to delete a particular data from the database. So we will see first how can you use insert command, and then we will see how can you use DQL command. So basically after using DQL command, we can use update and delete command as well. And we will do all the commands practically in MySQL workbench. So let's go and see how can you use insert command to insert data in your database. So you can see I have already written my command or the language that how can I use insert table. So we know we have a table called student table and we know what are the attributes we have for that particular table, right? So we have student ID attribute, we have student name, course name and email. Now if you want to insert them, you need to write insert and then you need to put into, right? So this is the basic syntax of how can you insert data into your table. Then you need to provide what? You need to provide the table name. My table name is student table. Now in the bracket, I am going to say, okay, what are the attributes I have and what are the attributes values I'm going to give. So I have attributes called student ID, student name, course name and email. So these 4 attributes I'm going to give data for them. Now, whenever you're going to give the data for all of them, you need to write values, right? So in the values after the bracket, you need to provide for the student ID I have provided it is 1. Then for the student name I have provided the name of the student is Prakash. Then course name is C1002. And lastly, we will have the attribute called email that is prakash@gmail.com. So this is how we can use our insert command, right? And like the same way you can write the you can insert thousands of data into your table. Okay. Now, maybe I'm going to write more data for your convenience, that how can we actually add more data, like millions of data in MySQL, right? Okay. Now I'm going to change all the values for them, right? 4, then maybe Shilpi, and then C1106, and then shilpi@gmail.com or shil123@gmail.com, right? And here again, we are going to change the data. So we don't want redundant data. So in that case, try to give all the unique data. But wait, we already have learned about primary key. In the next step, I will show you how actually we can use primary key For that, it reduces the redundancy of the data. And every time it makes sure that your rows value or your rows data is unique, right? Firstly, have a look at what are the commands we have and how can we use that commands. Then we will go for making a table with the key concept we have learned, right? Now, I am going to write Rima and the course ID should be unique, right? Yes. So this is how we are going to add some of the new entries. These are actually known as entries as well, right? So data we have inserted, that is known as entries when you go for industry level. So that time they call these data as entries, right? So they, and maybe this is 8 and this, right? So in this case, we are going to use only the insert command. After learning some of the different SQL commands, we will go for using update and delete command as well, right? Okay. Now, let me just run this. Yes, you can see you got a message that one row is affected. When you got this message that one row is affected, that means your query get executed. And this is already stored in your data. But wait, I have inserted the data. How can you see that, like in what manner my data gets executed or my data gets stored, right? So that time the DQL commands come into the picture. So let's have a look at what is DQL and what does it stands for, right? So let's go back to the presentation and have a look at what is DQL command. Now we will have a look at the types of command in MySQL, the DQL one. So basically DQL stands for Data Query Language. And this DQL used to make a queries on data within schema objects. The main focus on DQL command is to get some schema relation based on the query passed into it. And we have one command under DQL that is called select. This select command is the best or is the key for all the query you can say, right? So whenever you want to fetch data from your database, you need to use select commands. So let's go to the MySQL workbench and let's have a look at how can we use select command. Now we are going to use select command. So I need to write select, right? Then what I am going to write? Maybe if you want to get one particular column or attribute from your data set, you need to specify that. Maybe for my case, I want student ID. All the student ID I want to see, right? Okay. From, then you need to write a from command. So this is basically where you want to fetch the data. From which table I want to fetch the data from student table, right? Okay, let me execute that. Yes, you can see I have got all the data for student ID. Now I want to see the course ID as well. So in that case, or maybe the email. So in that case, I need to write email and then I need to execute the same command. So you can see we have got the result for student ID and email both. Let me just minimize that. Yes. So you can see we have got this. Now, if you are going to say, okay, I want to see the course name as well, right? So samely, you need to write course name, the attribute name. Be sure whenever you are going to write the attribute name, they are perfectly correct. Otherwise, it will not fetch the data. Okay. So let me execute that. Yes, you can see I have got the result, right? Student ID, email and course name. Now wait, I want to see all the data, not the particular attributes data. How can I do that? Do I need to write all the data, all the attributes, each of them, like every time I need to write all the attributes name? This is hectic, right? But no, you don't need to do that. What you need to do, you need to write just a star, right? This star is basically fetch all the columns from the data set or the data from the table, right? So I need to write select start from student table. Let me execute that. Yes, you can see I got all the attribute I have. Sorry. Okay. So all the attributes I have in my table, right? So you can see I got student name, course name, student ID and email, right? Okay. So basically if you drag this, you can change the column name according to you, your users, right? So basically I got student name, student ID, course name and email. So this is how we use our select command, right? Now we will have a look at the next command we have in MySQL. So let's go back to the presentation and let's have a look at what we have in the next. Now we will have a look at the next command called DCL. This DCL command is basically try to control your data, and this stands for Data Control Language. Basically, it deals with the rights and permission of the database. This works for controlling part of the data, and if you want to control your data, you need to use DCL commands. So let's have a look at what are the commands we have under DCL. So basically, we have grant and revoke. Two types of commands we have. So basically, what grant stands for, right? So this grant command provides users access privilege to database. So if you want to give some access to that some particular user, you can give them using grant command. When comes the revoke, revoke is basically if you don't want to give your database access privilege to some particular person, that time you can withdraw that privilege using revoke command, right? So this is what stands for DCL. Now let's go back to MySQL and let's have a look at how can we use delete command that comes under DML, right? So we will have a look at how can you use DML commands. So here we are going to use delete, but how can you use delete? And what's the difference between delete and truncate as well, right? Okay. So here I'm going to show you the truncate command that I have said. I will show you in the later part. Okay. So, and the delete we are going to see what and how delete is also working. So first let's have a look at delete. So how can you write delete? So first you need to write delete command, then you need to write from, but where? From where you need to delete, right? You need to write the table name. So for my case, table name is student table. Let me just execute that. Okay, fine. So basically when I was trying to delete my table, that time I was getting a save update mode error. So what you need to do in that time, right? So if your SQL workbench or MySQL workbench is a save update mode, that time you cannot delete anything like without any clause, right? Without any condition. So in that case, what I was doing, so that time you need to write a command. What command you need to write? You need to write set SQL save updates equals to 0. So basically when you are going to use this command and execute this, you can see 0 rows affected, but your command get executed, right? Now let's have a look at what we have in our table, right? So using select star from student table, we are going to check that. So you can see we have this, that student ID, student name, course name, and email, right? Now, what I need to do, I need to just execute my delete command. Again, how can you write the delete command? We need to write delete, that command, and from where you need to delete. I need to delete from student table, right? So I am going to execute that. Yes, you can see that 6 rows affected. Why it's showing 6 rows affected? Because you have 6 rows in your table. So it's got deleted. So let's have a look at actually it's deleted or not, right? Okay, let me use the same query that select star from student table. I already told you guys that when this select command is basically your like pathway or your everything when you want to retrieve your data, right? So anyway, if you want to retrieve your data, you want to see your data, if you want to manipulate your data, you need to use the select command, right? Now let me just execute that. Yes, you can see I have my table structure, right? But I don't have the data under my table. So this is how delete commands work. Now let me again insert all my data and try to execute truncate command, right? Okay, I am again going to execute all the insert command that I have inserted before. Okay, so let me just execute that. Yes, you can see 1 row affected. Now what we need to do, we need to again use select star from student table to understand actually data got inserted or not. So as we got the green tick, that means our data got inserted. That's for the second checking. So you can see we got total 7 records in our data. Now we are going to use the truncate table. How can you use truncate table, right? So using truncate table, you need to write truncate, the command, then table, from where table you need to, like which table you need to truncate, right? So the table name, for my case, student table. Now let me execute that. Now I already have shown you guys that in the truncate table schema is there. But what is got deleted, right? So basically, again, we are going to use select star command. That's select star from student table. Okay. Okay. I need to go down. Okay. I just changed my. Okay. Fine. Now, what I need to do, I need to write select star from student table, right? Let me just execute that. Yes, you can see I have this table schema, not the data under table. So this is how delete and truncates work. But wait, what's the difference between delete and truncate? If we can do the same thing using delete, why do even need to go for truncate? So let me give you an example. What's the difference between delete and truncate? Now I will give you few examples that what are the difference between delete and truncate. So the basic difference between delete and truncate is when you use delete, it is used to delete specific data, right? Here I didn't give any conditions. Whenever we are going to give some conditions, maybe a particular row you want to delete, right? So that time you need to go for using delete command. But when comes the truncate, it's to delete the entire database of the table. So if you want to maybe delete one particular row from your table, that time you cannot use truncate. You need to use delete command. Now let's have a look at when we have where clause. So I will give you an example where we are going to use where clause and what actually that where clause stands for. So when we use where clause, with the where clause we can use delete. But for the truncate time, whenever you are going to use truncate command, that time you cannot use a where clause. So basically where clause help us to give condition to do some particular work. But as we know in the truncate is not going to listen any condition. It's going to delete all the records from your data, right? Now comes the locking part. So when it comes to a delete, it locks the table row before deleting the row, right? But in the case of truncate, it locks the entire table. Okay. Now comes the rollback. So what is rollback? So rollback is basically if you want to roll back your data. But using delete, you can roll back the changes, whatever you have made. But using truncate, you cannot roll back your changes, right? Now the performance for delete is really slow, but for the case of truncate, it is faster than delete. So these are the basic difference between truncate and the delete command. Now let's go back to the presentation again and let's have a look at what other type of commands we have in our MySQL. Now we will have a look at the other command type we have in MySQL. That is TCL command. But what does TCL stands for, right? TCL is basically transaction control language. It helps you to control the transaction. We have commit. So why do we use commit command? Commit is basically used to commit a transaction. Then comes the rollback. Rollback a transaction for any error occurs. If you have any error, that time you can use rollback transaction command. Now comes a save point. So basically save point uses save point within a transaction. If you want to create a save point within a transaction, you need to use the save point command. Then lastly, the command we have for TCL, that is save transaction, is basically used to specify the characteristics for the transaction as well. Joins in SQL. But wait, why do we need to go for joining a table? Because if you are going to use a relational database management system, that time you already have a relation between different tables, right? And to use those relation, that key concepts comes into the picture, right? So we use those key concepts to actually prove the relation between the tables we have. But what actually it help us? So basically it helping us to fetch the data, to fetch a proper data, right? And to filter your data as well. right? So now we will have a look at how this actually fetching part and helping us to fetch the data from databases using this relational database management concepts we will have a look at, right? So first we will start with what is join in SQL. So a join concepts, which is basically a clause used to combine rows from different table based on condition. Suppose, let me give you an example for that. Suppose you have a table called customer and you have a table called account, right? Now you want to see, maybe you have customers in your database, but those customer does not have any account in your bank, right? Now you want to filter what are the data, what are the customer you have, actually those customer having account in your bank, okay, or in your apps maybe, right? So in this case you want to filter your data, but your customer table is a different table and account table is a different table. How can you join them if they both does not have any relation? Yes, this is where this join SQL joins comes into the picture. It basically help you to merge two table and get the similar like match data from them. Now we will have a look at what are the types of join we have in SQL. So first we have inner join. Then we have left join. So all total we have 5 joins, right? We have right join, we have full join and self join, right? Now you can see there's a set diagram. We are quite familiar with that set theory, right? Yes, this SQL joins also quite maintains this set theory concepts. And one by one, we will have a look at how this is going to work, right? For each of the joins, we are going to do the demo and also we will look into the theory as well. Now, we will start with inner join. From the name itself, you can understand it's if there is any inner connection between the table, it's going to return those. So let me give you a proper example for that. The inner joins helps to select the matching records from the both table. Yes, the example I was giving before. So if you have the customer in your customer table and if you have the customer in your account table, right, which are the customer is already present in your customer table, then only it's going to give you the records, right? So basically, it will help you to return whatever the customer you have in your account. So if your customer have account in your apps or in your bank, then only it's going to return the customers. If that particular customer does not have the account in your like apps or in your bank, then this customers will not be returned by the query. So now we will go to MySQL workbench and we will have a look at how this inner join concept works. But if you look at the image, you can see that it will only take the common from A and B. So if A is your table and B is your another table, it will take the common from both of them, right? So let's go to MySQL workbench and let's have a look at how it's gonna work. Before that, we are going to make our tables with the key concepts to understand this as well. So let's go. Now I am going to make a new table over here and I am going to start my SQL joins concept. So I will start with a table. So I have already written that table code because it's gonna take a lot time. So yeah, let me just copy this part and I will explain each and every line I have over here in the table, right? Control C and yes, I'm going to write. So it's quite similar with the previous table we have worked on. This table name is customer over here right now, and we have customer ID, we have if name, the first name, middle name, last name, we have CT, and then we have mobile number, occupation, and DOB, that is date of birth, but we don't have age. Here, I know you guys have a question, why this constraint and what this is going on, right? So basically, this constraint is, you are going to say, okay, my table has a constraint and that constraint is basically a primary key. So in that case, if you want to write that, if you don't want to write primary key that directly we did before, so in that time you need to write constraint, then you need to give a name of that constraint. My case, customer cust ID PK, right? That is primary key. And then I am going to write that primary key, okay? And in the bracket, I am going to write which attribute, right? Which column I need to make as a primary key. So my case, this is customer ID. Okay, so this is how we actually, in a professional way, we declare our constraints or the key for that particular table. Now I am going to use one more table called account. The same example I have given, right? Now I am going to just copy this because it's gonna take a lot time to write this. Yes. Okay. So here I am going to write them. Just okay. So what I have in my account table and how can I create that account table, right? The same syntax we have, that create. Then what you want to create? I want to create a table. Create table, and what is your table name? My table name is account, right? And then I said, okay, in my account table, there will be some attributes I want to be added. What are those attributes? I want account number, that is SE number, and the type of that attribute is varchar, and the length of that attribute is 6. Then I have a customer ID. If you can remember, we also have an attribute in customer table, that is customer ID, right? So we have customer ID over here, and that customer ID varchar, the data type of that customer ID is varchar, and the length of that is 6. Now we have BID. So this is basically your branch ID, right? And this is also a varchar. The length of that varchar is 6. Now I am going to check what is my opening balance. From that you can understand this is a bank table, like bank account, right? Yes. So bank account, in that opening, what is your opening balance? When we are going to open our account, we need to give some value, right? We need to give some rupees. So in that case, I am going to write opening balance. So what is that opening balance type? Will be integer, and that will be 7 digit, not more than that. Okay. And then we have AOD date, account opening date, right? And what type is it? It is a data type. Data type is date. Then we have a type of account, savings account. It can be some other options, right? So in that case, A type, and this is also a varchar. And the length of that varchar is 10. Now we have a status, that account status. This account is active account or the account is close account. So this active account is also varchar, the data type, and the length is 10. Now comes the constraint part. Here we need to use two constraints. But wait, why do we need to use two constraints? Because one is your primary key and second one is your foreign key. There comes the foreign key concepts, right? Okay, so we have already talked about what is foreign key. Foreign key is basically that that particular key, like the customer ID, is already a primary key in customer table. Now in this table, this customer ID is not a primary key, but it is an attribute of the account table, right? So in this case, our customer ID can be a foreign key. But wait, why do we need to use a foreign key? Basically, this actually makes the connection between two tables. When we are going to write the query, that time we will understand how this foreign key concepts works, right? So now we need to write constraint, and then the constraint name for my account number will be account number PK. That's a primary key. For that I am using PK. And then we have written primary key and which attribute you want to make a primary key, right? So my case is account number. Okay. Then I am going to actually write my foreign key concept. So in that case, I am going to write, okay. So in this case, my constraint name, I have given account customer ID FK, right? So we are not going to use this constraint name anywhere, but yeah, it's a way of declaring the constraint in the table. Then we have written that foreign key. The key name is foreign key. But which one you want to make a foreign key? Obviously the customer ID, because this customer ID attribute is present in account and as well as customer, right? And for the references, you need to give a reference to your table. Okay, see, this is why I am making this as a customer key. See references that my customer table has this customer ID as a primary key, right? So this is the actual scenario. How can you start using your key concepts in the table, right? Now let me just execute this part. Let me just create the table. Okay, both the table, I can just execute one at a time. Okay, fine. Let me just write this, use demo. Okay, let me just do that. Okay, so let me do one thing. This table is not created. I'm going to create the account one first. no, you got an error. Why you are getting the error? Because your customer table does not exist in your database, right? If this customer table does not exist, how can you give the references, right? So yes, whenever you are going to write any foreign key or any key concept, be sure you are actually maintaining all the rules, right? Let me just do that. Okay, I'm going to execute this. No. Okay. Oh my god. See what I have done. I have not select all the part. For that, it's going to give me the error. Be sure whenever you are working with MySQL, if you have a minor mistakes with your syntax, you will get an error, right? Okay. Now my customer table is created. Now I want to create my account table. Yes, my account table is also created. But wait, I want to see what are the table I have in my database. So again, I'm going to use the same command, right? Show what? Tables. Right? Okay. Let me just execute this. Yes, you can see I have the table of account and customer both. Now we need to do one thing. What? Anyone can guess? Yes, we need to actually insert our data. If we don't have data, how can you see what are the records it's going to provide? So I have already written down the data and I'm just going to copy paste it. Okay, fine. So let me just take this all data over here. So yes, I am going to just copy it. Okay. So you can see for customers what values I have. I have C001, almost same. Ramesh Chandra Sharma and this other thing. Now in the account, what we have, the account number is A001, customer ID is C001, and the branch ID is B001. Then the opening balance is 1000. The date of opening is this, and this is a savings account. This is active, right? Now let me just execute this part as well. All the values we have. Yes, you can see all the data are already inserted. Now I am going to use a select command for each of them and I'm going to check this data is inserted or not, right? Let me write select. Star from where? First one I want to check from customer, right? Customer table. Let me do that. Yes, this is all inserted, you can see, right? Now what I need to do, I am going to check select star from where? From account. Let me just execute that. Okay, so in this case, you can see both of the table are full with the data. Now I am going to use a inner join, right? How can I do that? Let me just write it down over there. I need to write select. So what I just want the first name of all the customers who are present in both of the table, right? So I'm going to write select if name, right? Comma, maybe account number as well. So in my case, account number was written as, so here I am going to do the inner join. But what I want to take, I need to take account number and what else? I need to take the first name, right? So let me check how can we do that using inner join, right? So let's get started. So first I need to write what? I need to write select this because this is like basic command if we want to fetch any data, right? Now what we need to do, we need to write which column or which attribute we want to fetch. For my case, I want to fetch if name, right? And then comma, and if name is from customers and account number is from account, right? So AC number, right? Let me just write down AC number. Now I need to write what? Okay, I have selected two different attributes from two different table. Now I need to write from where? From, I am going to say the first table is my customer table, right? Okay, customer. Now I am going to write what join you are doing. I am doing inner join, right? Inner join. And then this is the syntax when we are going to write inner join. Then we are going to write from customers inner join and which table? That account table, right? I have written account. Okay, now I need to provide which key are going to actually going to merge the table, right? Or not even merge, it's going to help to inner join the table. In this case, now I need to write on, okay, and what? That is customer, right? This is basically taking the table name customer dot cust id, right? If I am not wrong, the cust id was my, yes, cust id, right? Be sure that whatever spelling you are writing, otherwise you will get an error. Is equals to from now which table? From now account table dot and then cust id, right? Let me just execute that. Yes, we got it. So we got Ramesh. Ramesh has 2 account, Avinash has 2 account, Rahul also have 2 account, Chitresh, Amit. But how can you sure that your data, whatever the data you have get, it is right? So we can use count variable and we can check how many data we have in our customer table and how many of data we have in our count table. And let's see what count we get over here, right? So how can we do that? We need to write select count and maybe you can write star over here. It doesn't care. It will just check all of them from customer, right? Same from select count, then maybe star from account, right? Okay, so first one, let me just do that. Okay, so first customer I have for 10 and for account, let me just try. We have 10. Here I need to check this part. Okay, so the same query will be same, but here sorry, I'm going to write if name and okay, so I want to count the if name. Shit, what I have done to write if name from, right? Let me just check. But here also we get 10. Why? We have the repeated value. Maybe for this case we are getting 10 all the time. But if we do it manually, let me just go back to the insert value. Yeah, you can see we have Parul, we have Naveen, we have Chitresh, right? But here we don't get any value called, let me just go that, yeah, we also have Parul, Chitresh, let me just check it manually. Ramesh we have Avinash, okay, Amit we have, Nisha we have, you can see we have Nisha. Let me just try that Nisha we have, but we don't have Nisha over here. You can see we got Ramesh twice, Avinash twice, Rahul twice, right? So in this case, we do not have anything called Nisha. So you can see from that, whatever the data we got, this both of the customers is present is customer table and as well as account table. So this is the concept of inner join, right? So now we will go back to our presentation again and let's have a look at what are the other types of join we have, right? And how can we implement them and how can we use them to sort out data? Okay, so let's go back to the presentation. Now we are going to talk about what is left join and how we can actually do the left join in MySQL. So what is left join basically? The left join helps to fetch all the records from the left table and the matching records from the right table. As you can see in the image that A table is basically, you will get all the records from A table and from the B table, you will only get the matching records, right? So let's go to MySQL Workbench and let's have a look at how we can actually implement this, right? Let's go to the MySQL Workbench. So here I'm going to do these things from the scratch and we will make our own database and we will use those database and then we will make a table So according to that table, we will fetch our data using live join, right? So let's get started. First, we are going to use a command called create, right? From create command, we need to create what? We need to create a database. So we are going to write create database, and then my database name is my database 2, right? So this is my database name, that my demo database 2. Now I need to execute that. For executing that, you need to select the command and just press on this run. Okay. So yes, you can see your database is created. Now what you need to do, you need to use that particular database. So for that, I am going to use command and then my demo database 2. The same particular, maybe for my case, I am using my demo database 2. For if you want to use some other database, you can go for using the same command, that what particular database you want to use for your particular operation, right? So I have used my demo database 2. Then just click on execute button, right? Yes, this is also executed. So you can see you got a message when you write create database my demo database 2, that one row is affected. So that means your database is created. But when you write that use my database, my demo database 2, that time there is no row affected. That means there is nothing is created or inserted. What actually happened is just your command says, okay, from this I'm going to use my database 2, my demo database 2. Whatever the table you are going to create on this, whatever the data you want to insert, it's going to take in that particular database only, right? Now what we need to do, we are going to create a table called customer. What are the attributes have in that table? It has customer ID, first name, middle name, last name, city, mobile number, occupation, date of birth, and lastly we have the constraint, that is primary key. So we all know why we use primary key. So we use primary key to reduce the data redundancy, right? So if you look at the table attributes, so cast ID is basically a varchar, right, which can contain character type, okay, or the number as well. The length of the varchar is 6, right? Now it comes to first name. When I write f name, and this is also a varchar, and when we are putting the limitation, like the what will be the length of your first name or customer ID, because we want to manage our memories as well. So if you use a high number length for a particular attributes, then in that particular case, maybe your memory is occupied, but you are not using it. So what's the point of actually wasting the memory, right? So in that case, we use f name, varchar is maximum 30. So we can assume that anyone's name, some person's name cannot be more than 30 character, right? So in that case, we use 30. For middle name, again, we are using 30. For last name, again, we are using 30. But for the city, we are using 50, because we know that city name cannot be a 30 character, right? So for that, we are using 50. Now comes the mobile number. So we all know mobile number character should be 10, right? So we use varchar, that is 10. Then comes the occupation, that is also 10. Lastly, we use date of birth, but the type of that date of birth attributes is date. So that is comes with MySQL, right? Then we have written constraint customer name, cast ID PK. Basically, you are giving a constraint name to the particular table, right? So if you don't want to use constraint customer custom ID PK, that is the primary key, so you can directly write after this that primary key. This one you want to make a primary key. But this is a good practice to use a constraint and then the constraint name, and then which one you want to make that particular constraint. So for my case, I want to make cust ID as a primary key, right? Now, we want to just execute this part. Let me just execute that. Yes, you can see 0 rows affected, but this is actually created. Your table customer is created. Now, what you need to do, if I want to see what are the tables is actually created in my database or not, it's like we are actually going to use the same database or not. So in that case, we are going to use a command called show tables. Let me just execute that. This command we use to check what are the tables we have in our particular database, right? So let me just execute that. Yes, you can see our customer table is created, but it does not have any values in it. But yes, there is a table structure called customer is there in your database. Now we are going to make a table called branch. So basically here we are trying to make a database management system that is for bank.
right? So it's a very basic one. Later in the section also, we will gonna do some good projects, and maybe 2-3 projects we are going to do to understand how you actually can design your database and how you can start like making your own tables, and what are the constraints you are going to use, and what are the constraints it's really needed, right? So yeah, we will do in the later in the section, but here we are just going to make a very small like portion of a bank management system, right? So here we have branch. We know that banks are actually having their own branches. So here we are going to store all the branch details, right? So what are the attributes we have in the table called branch? So we have BID, that is branch ID. Again, the branch ID cannot be a big number, so we took 6 as the character that of varchar type. Okay, then the branch name, that is can be 30. Okay, so we use varchar 30. Then which city that particular branch is currently situated, so that city name. Then we use a constraint that is branch BID PK, that is we want to make BID, that branch ID, as a primary key, right? So in that case, I have said constraint branch BID PK, that is primary key, and this is which attributes I want to make a primary key, that is BID, right? Then what we did, we actually create one more table. Before that, let me just execute that. Yes, you can see our 0 rows is affected, but your table is created. Again, if you want to check your table is created or not, again, write show and then tables. Just don't forget to put the semicolon, because it is one of the most important syntax in SQL. So if you don't maintain their syntaxes, you will get an error. Okay, you can see we got 2 tables, that is customer and branch, right? Yes. So this is how actually our database concepts works, right? So we made 2 tables. One is customer and second one is branch. Now we are going to make one more table, that is called account. But what are the attributes we are going to add on that particular account table, right? So account table will be connected with branch as well as connected with customers as well, right? So let's have a look at what are the attributes we have. So in account table, we are going to have account number, that is one of the most used number, you can say that everyone needs to have the account number. Then we are going to have customer ID, right? So that is already we have in customer table as well. Then we are going to have branch ID, right? So branch ID also we have in branch table. Then we will going to have other data like what is the opening balance. Then maybe the opening balance can be 0, or someone start with their opening balance with 1000, right? So we want to make a proper data for that. Then AOD, right? What is AOD? The account opening date. Okay, so at what date you have open your accounts, that type will be date type, right? But if you see in the opening balance, we are going to use the type of opening balance is int, right? So we are not going to use varchar, because obviously the amount we are going to like use for the opening balance, that should be int, right? Then it's we have a type, your account type, that can be savings, that can be other options, right? Then account type. Then we have a status, that is account status, that it is active or you just terminated your account, right? So this is the status column or status attribute we have. Then we are going to make our constraints. So what are the constraints we are going to make? First, account number PK, that is the primary key we are going to make for account table, that is account number, right? So in my account table, account number will be my primary key. Then we are going to have a foreign key. So we all know the concepts of foreign key, right? So if you want to fetch data and if you want to join 2 tables together, that time this foreign key concept comes into the picture, right? So first we are going to attach 2 tables together. One is account number, that is account table, and second one is the customer table. How we can do that? For that, you can see in the customer table as well, we have customer ID. In account, we have customer ID as well, right? In both of the table, we have customer ID. So in that case, our customer ID will be our foreign key, right? So yes, so we have foreign key for both of the table, and we are going to make this as our foreign key, right? Now we are going to attach 2 more tables, that is account table and the branch table. But how we can do that? If you look at the account table, you can see we have BID, that BID column or the attributes. as well as in the branch table also we have BID, right? So both of the cases we have BID and we will take BID as a foreign key, right? So this is how we are actually making the relation between different tables, right? So you need to have a proper relation between tables to fetch those data. Okay, so now we are going to execute the account table. Okay, let me just execute that. Yes, you can say 0 rows affected, and what it's going to say, it's already your table is created. Now I am going to use the same command that what are the tables I have in my database right now. So show tables and then semicolon. So always put the semicolon. This is when I started my journey in MySQL. I used to get lots of error because of this. I used to forget to put the semicolon. So never forget to put the semicolon, right? Yes, you can see we have 3 tables over here. One is customer, one is branch, one is account, right? Now we are going to add some values to these tables to see how left join works, right? So let's see how we can start putting our data into the tables. Now we are going to insert our data into customer table. But how we can do that? First, we need to write insert into command and then which table you want to put your data, right? My table is customer. First, for my customer table, I want to add some data to that particular table. For that, I am going to write insert into, then the table name, that customers. Then I am going to put the values, the data I want to put. Then values C001, that customer ID. Then the name is Ramesh. The middle name is Chandra and the last name is Sharma, right? And he's belonging from Delhi. His number is 95431985, right? And the occupation is service and his date of birth, right? So this is how we are going to insert all the data. I am trying to put some of the data basically to understand how this slave join concept works. Then we have the second value, that is Avinash. Now, if you look at this, you can see there is a null. I have no data for this. So if you see, I can put null in some of the columns, but if you want to put null for your primary key, that is not allowed. You will get an error. So let's have a look at if I want to make maybe I want to put a data, right? First, I'm going to put some, like the data is going to take, and I want to try that as a null value for a primary key. Is it going to take or it's going to give you error for that, right? So let's have a look at that. First, I am going to insert first 2 rows. Okay, so first 2 rows are fine. There is no null value. Yes, so this is inserted. You can see 1 row is affected, 1 row is affected, right? So this is how we can actually put our data in a particular table. Now, what I am going to do, I am going to write insert, then into, then which table I want to insert, that is customer. And from there, I need to put what? I need to put values, right? So values, and from there, I am going to write, maybe my primary key will be null, okay? From there, I am going to write Shima, and middle name for R will be Kumari, okay? So from there, I am going to write, okay. So if you can see, I have, just a second. Okay, so if you can see over here, I have written the primary key is null, then the name is Shima, and then the middle name is Kumari, and then maybe Sharma, the last name, okay? Then I am going to write, this is Kolkata, okay? Then the number will be 98765, okay? 213, okay? So this is how we are going to add the phone number. Let me just add that. Okay, now I am going to write the service is, she is a service woman, and yeah, then from there I am going to write the date of birth. I'm just copy pasting it, just going to change the data. Okay, so maybe it's gonna be 1 and it's gonna be 18. Let's have a look at, and again, don't forget to put the semicolon. Now I am going to try to add it, but you can see customer ID cannot be null. You can see that what we are actually saying in that time, your primary key cannot be null. So as you see, my primary key is null. For that, it's giving me an error code. Now, if I want to add the same contact or the same data twice, maybe already I have inserted this, right? So how we actually check the data? How can you fetch all the data from your table? We know we are going to write select star from where your table name, that is customer. Okay, right. So let's have a look at what are the data we have in our table. So you can see Ramesh and Avinash is already there. Now what I'm going to do, I am going to again want to insert Avinash, right, with the same key. Okay, you can see error code duplicate entry C00002. Okay, so from here you can understand your primary key cannot be null, your primary key cannot be duplicated, right? So in this case you have to put a emphasizing in this case is because you have to understand how this primary key concepts works, because if you want to go for any interview, that time they will focus on how much you are good with the constraints, because when you are going to use the big data set, right, you need to make a relation between them. You have to be very sure that what are the relation you are putting over there, because they will be all connected, and from basis on that only you can manipulate data and you can fetch your data, right? So now what we are going to do, we are going to insert the raised data. Okay, let me just execute that. Yes, you can see all of the data are already inserted in my table. Now I am going to write select again star from customer. So basically I want to see what are the data I have, whatever the data I have already inserted to my table, it is already properly inserted or not. Okay, so now I am going to execute that. You can see Ramesh, Avinash, Rahul, Parul, Navin, all Shankar, all are inserted. Okay, if you can look at it, customer ID is not null for anyone because it's not gonna take any data if your primary key is null, right? Now we are going to insert data for branch. Okay, so for branch we have BID, the branch ID, then the branch name, and the where your branch is situated, which city it is. Okay, so in that case your BID, the branch ID, is your primary key. So already I have explained that how your primary key works, but again I am repeating this because if you keep if you keep remembering this, okay, primary keys is this, and for primary key we are not allowed to give any null value, or primary key, for the primary key we cannot give duplicate value. That will basically help you to remind all the constraints, because we have multiple constraints, but most important constraint, if you ask me, then I should say primary key and the foreign key are the most important constraint. You need to understand it, right? Now I am going to insert all the value into my branch table, right? Let me just execute that. Yes, you can see all of them are inserted. Now again I am going to write the same command to understand how whatever the data I have actually inserted to my table, it's properly inserted or not. Select star from where the branch, the table name, okay, and again the semicolon. Let me just execute that. Yes, you can see I have branch ID P001, 2, 3, 4, 5, and the branch name and the city, that is all of them are in Delhi and one of them is Mumbai, right? Now you can see our branch table and our customer tables is filled with the data. Now we are going to fill our account table with the data. You can see our account table primary key was account number, and from there your customer ID, then branch ID, then the opening amount you have, right? Then the date of opening of your account and what type of account you have, savings account you have or any other type, right? And then your account status, that is active, you're suspended or terminated, anything, right? So for most of the cases I have savings account, and most of the cases my account is active. Some of the cases I have suspended and the terminated, right? Let me just insert them in the table called account. So in that case, if you want to execute multiple time at a time, what you need to do, you just need to select that part and just click on execute. So all of them will be executed, right? Okay, and one more thing, be sure in that whatever the sequence you are putting your data, in the same sequence you have attribute in your table. Otherwise, you will get an error. Let me just show you how you can get an error if you are going to give in order is not same, right? So maybe in the last one, it's already inserted. We are going to see that it is inserted or not in our table. But before that, I want to show you that, yeah, if you are not going to make the proper order, okay, you will get an error. So insert into account and then values, I am going to write 1, 1, So our primary key is not same. And here I am going to write C004, but I am going to change the order over here. Okay. So after this, maybe I am going to write. Okay. Let's have a look at it's going to tick or not. But yes, I need to change. No, I don't need to change this because the branch ID can be same, right? Yes, you can see error code cannot add or update child or foreign key constraint fields because the thing is that you are not maintaining the proper order. If you are not going to maintain a proper order, obviously you will get an error. So always, whenever you start working with MySQL, be sure these are the part you have to remember. The semicolon part, the proper ordering, whatever the ordering you have given in the table when you are creating the table, right? And when you are inserting the data in that particular table, be sure that order is same. Otherwise, you will get an error, right? Now we are going to check that is the data is already inserted in our account or not. For that, we are going to use the same syntax, select start from what account, which table, right? That is account. Then the semicolon. Let me just execute that. Yes, you can see I have account number A001 and the customer ID is C001 and branch ID is B001, opening balance 1000, and the status is active, A type savings and AOD, right? All of your data is already inserted in your account. Now we are going to perform our left join concepts. How our left join wants. In that case, maybe we want all the data from the customer ID, okay, all the data from customers who are actually there in the account. Okay. So in that case, let's have a look at how we can start doing that. Now we are going to make our SQL left join. How we can do that? Before that, what we can do, maybe if you have a lots of data and if you want to make sure that your data is fetched properly from the table or not, you can use a count function, right? So we basically use count function to understand how many inserts of how many rows you have in your table, right? So for my case, if I write select count and what you want to count, maybe I want to count the customer ID from customers, right? So as it's a primary key, you know there is no null value is there. So whatever the count you have, whatever the data you have, you will get the proper count of that, right? Let me just do that. Yes, you can see you have 10 data in your customer table. Now, if I want to do the same thing with the account table, what we can do, we can write account number as account number is our primary key, right? Let me just copy that. Okay. Now I am going to write count, account ID, and from account, which table you want to have that count. You can see both are 10. Okay. So these are the, like for my case, maybe this is 10. For your case, maybe the customer ID will be large, but the account number will be less because we all know that maybe you have the database, you took the data from the customer, but they did not open any account in your bank particularly, maybe. So in that case, maybe you have a large number of customers in the data in the table, but as a account, like who has the account in your bank, that time you have less number of customers, right? So in that case, maybe you can check, okay, I want all the customers from my table and the customer who has actually account number. So what it will happen when you are going to use a left join, so you will get all the result from customer, right? But for the account, you will get only those customers who are matching with the customer table, right? So in that case, what I have written, select, okay, star basically is you want all the data, all the columns from your table, right? So select star from where? Star from the customer table. So I want all the data from the customer table. Then I have written left join. So the join will be left join. Then from which, like with which table you want to join. So for my case, I want to join with account, right? So select star from customer. So I want all the data from customer, which is like similar with account, right? Which are matching with account on which key you want to save, which attribute. So we all know customer ID is the foreign key for customer and account, right? Because customer ID is already there in a customer table and customer ID is also there in the account table. Then I have written customer.cast ID is equals to account.cast ID, right? Let me just execute that. Yes, if you look at it, you can see I have customer ID, if name, last name, CT, mobile number, all the thing. Okay, so you can see over here I have AOD and all. But if you can look over here, right, they don't have any account number. Okay, but still the customer is already there. The customer data is there. But maybe you want to say, okay, I want only those customer, right? I want only those customer who has the account in my bank. So in that case, you need to change the order. I am going to write account. Okay, select star from account, left join, then customer. Okay, now, okay, customer. Now I am going to write what? I am going to write, okay, account, our table name, same. You are just swapping the places, okay? So you can see the difference between them. And you will understand the left join properly as well. You can see, okay. So here you can see all the data, okay? But here, if you see account number, every one of them has the account number. And customer ID without account, you didn't get any data who does not have any account, right? So in this case, you want all the customer with the account in your bank. And before that, when we are using the customer in the like when we have the customers, that time it was giving all the customer irrespective with the customer has account in your bank or not, right? So this is the concepts of left join, how you can actually get all your data according to your users. Maybe sometime you want all the customer, maybe they have account number or not, you don't care about it. Sometime you want a customer who is actually your customers, basically they have their bank account with you, right? So this is how we are going to use left join. Now let's go to the presentation back and let's have a look at what else we have, what are the other joins we have in our MySQL. Now we are going to talk about what is right join. So we have looked into left join, we looked into inner join. Now we are going to talk about right join. So what is right join? The right joins help to fetch all records from the right table and the match records from the left table, right? From the image itself, you can see you will get all the data from the B table, but you will get only the matching data from the A table. So basically, you can take it as an opposite of left join, right? So we are going to see how we can actually implement this concept in MySQL Workbench. So let's go to MySQL Workbench to let's have a look at how we can actually implement this, right? So these are all the ways it's actually help us to use our relational database. So if you don't work with relational database, then you cannot make the relation between two tables and you cannot fetch all the data, right? So here, this is the picture when actually this relational database management systems help us to fetch data, right? So let's have a look at the MySQL Workbench. So here, already we have 3 tables, right? So I have shown you how you can actually check how many tables you have, right? So first, again, I am doing these things every time and I'm repeating these commands because if you actually get familiar with these commands, actually it will help you to do all the data fetching, data manipulations things, right? So if you want to see your tables, what are the tables you have? So maybe we are doing a course over here, but maybe when you are doing these things and maybe you are not doing the whole course at a time, that time this is recap is always gonna help you, right? So now I am going to write show and what I want to see what are the tables I have in my database, and always use the semicolon in your query because this is the syntax of MySQL. Let me just run it. Okay, you can see I have customer, branch, and account. Okay, so now what I want my all the customers, right? I want my all the customers who has the account, who doesn't have the account. So if anyone has the account, please show me that as well, right? So in that case, what we are going to do, right? We are going to write select star from account, right join customer, because first one is select, star is basically what are the data you want. Star is basically stands for you want to fetch whole table irrespective of any attributes. You want all the attributes from your table. Select star from what table you want, that is account. Then I said right join. So I want the join should be in right join, and then which table you want to join. So in my case, I want to join with customer. So customer on, then which foreign key you have for particular joining for particular that to table. So for my case, I have customer ID. So customer ID. Okay, I have attribute customer ID in customer table as well, and customer ID in account table as well, right? So I have written customer.cust ID is equals to account.cust ID, right? So this is where your foreign key actually help you to merge two tables. Okay, now let me just execute this command, and we will change as well to see the difference between them. Okay, so you can see what I have got over here. I got all the customer ID. You can see I got all the customer ID. Okay, I have got all the customer ID, and we got all the matching data we have in our data, right? That account number. Now you are going to say, okay, I got all the account, I got all the customers, but now I want only those customer who has the account, right? So we are going to change this order, right? Now I am going to write select star from customer, right join account. Okay, then I am going to write what? Account dot cust ID and customer dot cust ID. Let me just execute this one. Yes, you can see I got it. Okay, so only I got those customer who has the account in my bank. Okay, so the customer I have in my database, but that customer does not have the account number, they are not going to show. So the concept we have learned that you will get all the data from your right table, right? But you will not get all the data from your left table. So basically, right table is going to help you that all the data you will get, but from the left table you will get all the matching data, right? So this is where, and this is how this right join concept works. Now we will go back to the presentation and we'll have a look at what are the other join we have in our MySQL. So we have learned about how right join works, right? Now we are going to talk about the other join techniques we have in our MySQL. So in that case, we have a concept called full join. But what is full join, right? The full outer join helps to fetch all the records from both the table, whether there is a match or not. So from the image itself, you can understand and you can see that if if you have two tables like A and B, and you want all the data from both the table, that's irrespective of their matching in the data or not, right? But wait, why do we need to have a data like that? So sometimes if you want to see, or if you want to just this merge two table and to understand what are the data you have, so that time we actually go for using full outer join. So this join does not check for any similarity in the both of the table. They just take all the data from both of the table and just print them out, right? So this is the concept of full join. Now we will go to MySQL workbench and let's have a look at how we can actually execute our full join concepts and how it's going to help us for manipulating and fetching our data. So here we know we have tables of customer, branch, and we have a table called account. Now we are going to use the same technique. So if you can have a closer look on this, so the main syntax for joining is same. That what is differ the concepts, right? Whenever you're going to use inner join or left join or right join, or you want to use a full join, right? So in that case, your syntax will be same, but what you need to remind what are the concepts behind that. What will happen if you use right join? What will happen if you use left join? And what will happen if you use inner join, right? If your base is clear, what are the joins and how these joins are working? So it's just a one syntax you need to understand and you need to remind to write your query, right? And also do let us know in the comment what you feel about this join and what are the problem you have faced when you go for using the full join and right join, left join, or this is a confusing thing, right? So if you are a beginner, if you start learning SQL, so obviously I do believe that what join should you use? It's actually a very complicated thing. Okay, but when you start using these things like quite regularly, that time it is quite okay that you know what are the things you want, what are the data you want to fetch from your table. So that time you can easily identify which join will work for you. But if you are just a beginner, if you start your career in SQL, So in that time, you really need to have some time and you need to give some more time to understand what are the join concepts, right? And how they are going to help you to manipulate and fetch your data. Now we are going to talk about full joined account. So in that full joined, first you need to write select, the normal command, and every time if you want to fetch any data, you have to keep that in your mind. You start with select, right? So select is the command. It's just if you want to fetch anything from your data set, you have to use that. Select star. Star is basically all the attributes you want, irrespective of anything, right? Select star from which table, right? So customer table. Select star from customer. Then you need to write which type of join. So if you actually break this query into few parts, so you can see, first you need to write select command. Then what are the attributes you want to go for? So for my case, I want all the attributes. Then from which table you want to take them, right? So select star from customers table. From customer table, I want all the data. Then what type of join, right? It's a right join, left join, inner join, or it can be full join, right? So I have written full join. Then you need to write which table you want to join in the previous one, right? So in that case, you are going to write account. So I want to merge two tables, that is customer and account together. From there, I have written on, right? This is the syntax you need to remind. On, then your foreign key, right? So we all have a foreign key to add two tables, or to, making a relationship between two tables. So in that case, we have written account dot customer ID. So customer ID is our foreign key. Account dot customer ID is equals to customer dot customer ID. So let's have a look at what we are going to get after using full outer join. Okay, so I got an error, but why I got the error? Customer dot cust ID, right? Okay, let me just do that. Okay, so here I am going to write this. So we were getting error when we are trying to write select star from where the table name, the account table, right? So basically we were getting the error when we are trying to do a full outer join using full outer join keyword. But why? I will answer you that why we are getting the error. Let me do that again. So select star from account, then we need to write, if you're going to write full outer join, and then we are going to write the which table you want to join. So basically it's a customer table. So from there on, and the same foreign key concepts, right? Yeah. Yes. And then the semicolon. Okay. But we are getting an error that outer is not valid at this point, at this position. But why? Or if I'm going to remove this as well, it will give me an error, right? So maybe something is not there. Yeah. So why we are getting this error? So basically after MySQL 4.0, I mean, they are not gonna use, or they are not gonna support full join technique directly. So if you want to do full join, you need to use a union concepts. So what does this union stands for? So what we do, we just need to write select star from account, the table name, and the left join. Maybe you can do, I mean, we are basically doing the normal union concepts. We are taking the left join and we are taking the right join. So basically it's going to be a full join, right? But directly it's not going to take the full join concepts from MySQL 4.0. Okay, so this maybe they can ask you in the interview that why we cannot use full outer join or full join in MySQL. Yes, we can do that, but we actually need to use some other concepts, because from MySQL 4.0, they don't support full join directly. That full join keywords, right? So what we are going to do, we are going to write select, then star. What are the attributes? I want all the attributes from which table? The account table, okay? Then I am going to do the left join first. So if you're going to do left join, you will get all the records from the left table. So left join, then the customer, the table name, then the foreign key concept you have, account.customer ID is equals to customer.cust ID, right? Then we are going to write union, okay? The normal union concepts. Union, then Select star from account, the same thing. Now we are going to use right join, right? Then right join customer, the table name on account.customer ID, the foreign key concepts. Now we are going to write the semicolon. Don't forget to put the semicolon. Okay. And please do let us know in the comment that what you feel about. And did you ever also get the same error like the way we got? Okay. So basically doing that because I just want to show you why we were getting the error. Okay. So if you are going to use higher version from MySQL 4.0, that time you need to use this technique. Yes, you can see it's already worked and we got all the record. Okay, so if the customer does not have account, then also we get the record, and if the customer has account, so then also we get the record, right? So basically what it does, it's the full outer join concept is basically you just want to take all the data from particular two tables, okay, irrespective of any condition, irrespective of any matching, right? So this is what full outer join concept stands for, right? Now we will go to the presentation again and we will have a look at what are the other join concepts we have in our MySQL. Now we will have a look at what is self-join and how we are going to use self-join concepts in our MySQL. Before start the self-join concept, let me just introduce you what is self-join. A self-join is basically helps to join a table with itself only. But why do we need that? Because there is some time we need to combine the data with the other data in the same table and the table by itself only. In that case, we use self-join. We can perform self-join using table aliases. The table aliases actually help us not to use the same table name twice with a single statement. But if we use the same table name more than one time in a single query without table aliases, it will throw an error. The table aliases enable us to use the temporary name of the table that we are going to use in the query, right? So now we are going to see how can you actually use the self-join concepts, right? And what are the examples of self-join concepts, right? So let's go to MySQL Workbench and let's have a look at how we can implement this concept. So we have a table called student table. In the table, we have few attributes. We have student ID, name, course ID and duration. Student ID is obviously varchar and name is also varchar. So we give the length of varchar 30 for name and for course ID we give 30 as well. And the duration of the course, right? So here we are going to execute the student table. So we need to write create table and the table name that is student and then all the attributes. Let me just execute that. Yes. Now what we are going to do, we are going to insert the data. So inserting data, again we need to use insert command, that insert into, then where you need to insert, that is student table. Then you are going to provide all the values. For my case, the first student ID is 1, then the name of the student is Asif, and the course ID is 2, and the duration is 4 hours, right? So this is how we are actually going to insert all the data in the student table. Let me just execute all the data we are going to insert. Yes, it's already inserted. Now we are going to use the self-join. But wait, how we are going to use that, right? So we are going to get all the result, that is student ID and the name, from the table where student ID is equal and course ID is not equal, right? So basically from the table itself, you want to understand that a particular student is enrolled for how many courses, right? So in that case, if you look into the data, you can see Asif is actually enrolled for 2 courses. One course is 2 and second course is 1, right? Atul is also enrolled for 2 courses, that is 1 and 3. But for the case of Jasmine and Aditi, they don't enroll for the multiple courses. So basically from this data, you want to understand how many students are actually enrolled for multiple courses. That time we are going to use self-join technique. But how we are going to use that, right? First, you need to write select always we are going to use that, right? Then we are going to give a alias name. The alias is s1 dot. Then we are going to what you want to have. If you want to have student ID, you can give student ID, and if you want to get the name, you can actually go for doing that as well. So s1 dot student ID, comma, as1.name. So I want both the student ID and name. From where? From the student table, right? And then I am going to give a alias, the concept we have learned in the beginning of the session, right? In the beginning of the tutorial, we have learned how we are actually use this alias concept. So basically giving a temporary name to a table. So in this case, we are going to give as1. Now, for the student as2, the second temporary name, because we are going to use the same table, and this is why we need to give two different alias. Otherwise, it's going to give an error. Then we have written where, the where clause we have learned in the beginning as well, that now we are going to give a condition, and based on the condition, this join is going to happen, right? What is our condition? The student ID will be same, but course ID will not be same. So in that case, we are going to write as1 first alias dot student ID is equals to as2 dot student ID, and the second one is as1 dot course ID, that is not equals to, this sign is basically used for not equals to. So not equals to as2 dot course ID, right? So let me just execute that and let's have a look at what we are going to have. Yes, you can see this Jasmine and Aditi is not there in our table, because you can see Asif, or maybe we are going to write, okay, so I just want to see the course ID as well. So in this time, we have written course ID, right? Let me just execute that. Yes, you can see we got the student ID, name and the course ID. So Asif is basically enrolled for course 1 and course 2. And Atul is actually enrolled for course 3 and course 1. Right? This is how, if you want to get data from your one table and you have no other option, like, if you want to get the name that who are actually enrolled for multiple courses, that time you really need to go for using self-join. And self-join is one of the most used technique and one of the most favorite question for the interviewer. They are going to ask you about self-join. So it's very necessary that you are actually have a quite a clear idea about self-join. Right? So now we will have a look at, we will almost see all the joins we have in SQL. Now let's go to presentation and let's have a look at what else we have in our MySQL tutorial. Now we are going to handle a problem. But what problem it is? So if you have 2 or more queries, how can you handle them? Right? Do I need to write 2 separate queries? Or what will be my way of doing that? Right? Suppose you said, okay, I have a customer table or I have a demo customer table. So I want all the customer whose age is more than 45, and I want in the customer table that those will be updated, right? So how can you do that? So doing that, we need to use a concept called subquery. Now we are going to look at what is subquery. Subquery is a SQL command again, which is nothing but a select query that contains another query inside. Oh my god, but how it works, right? It's not that complicated. Go with one by one. What is subquery? What are the types of subquery we have? What are the parts we have in subquery, right? Let's go and let's have a look at how many parts we have in subquery. So basically, we have 2 parts. One is inner query, one is outer query. So we have 2 parts in subquery, right? We will do the demo on that as well. Now, first, we are going to look at how the subquery executes. Yes. So first, whenever you are going to give an inner query, it gets executed. Then, it will take the result from the inner query, because in SQL, you cannot hold your data, right? So, suppose you want to take a, output from one particular table and you need to use that to the other particular table. So in that case, you need to go for using join or else in the subquery, right? So again, first it will execute the inner query, then it will hold the data of the inner query, then the output of inner query added to the outer query, right? So whatever the result you get from inner query, it will be added to the outer query. And then outer query will get executed to get the final result, right? So at the end of the your execution of outer query, you will get the final result, right? So this is the process of how subquery executes. Now we are going to talk about what are the types of subquery we have. We have two types of subquery. One is nested subquery and the second one is correlated subquery, right? So what is nested subquery? So nested subquery first executes the inner select query, right? It will obviously the like way we saw. So it first executes the inner select query and then within the returning values executes the outer query. So if you look at it, don't think about all these complicated terms. Think of first you execute a query, you got an output. From there, that output you are going to use for the next query. So that your next query will be your outer query. Now comes the correlated subquery. So a correlated subquery reads every row in a table, right? It's gonna read every row you have in your table and comparing values in each row against related data. Okay, so first it will read all the rows in the table, then it will compare each row, right? Each row with each other against the related data when your data is related. So this is the two types of subquery we have, right? Now, what we are going to do? We are going to do in MySQL workbench and let's see how can we do the subquery. Yes, because there are lots of things we can do with subquery as well. Right, now for the subquery, I am going to take these things again. So what we can do for subquery, let's start with the simplest one, right? Okay, so, right. What we can do? Yes. Right, we can insert customer. Maybe we can make a demo of customer or demo of customer table, and with the filter data we can make a table as well, right? So maybe here, let me just copy this, right? So why I am making the separate file? Because I don't want this to be very, like already we have done the join in the previous one. So here I just want to make it in a clear picture. So here what we are going to do. Okay. So I have a table called demo of customer, right? Demo customer. Here I am going to make a table again with the same structure, right? Okay. Now, but we are not going to add all the data from that particular demo customer. Here, my table name will be customer. Okay. Let me just create this out. Okay. Yes. You can see it's already done. So again, if you want to check your table is created or not, show tables command. So these are the basic commands again you have to understand. Yes, you can see customer and demo customer. Now I want to insert data, right? The same command we are going to use, insert into, right? Then where you need to insert? I need to insert my customer table. Then your inner query starts. You need to write select, right? This is your outer query, insert into customer. Then your inner query starts, right? So your inner query, you are saying select star. So basically you want to select all the thing from data of customer. Here you can write demo customer, right? Where age is greater than is equals to 45. You want all the data. Maybe you are making this for the senior citizens or like, the age range is like greater than 40, right? So in that case, you say insert into customer. So basically insert all the data to my customer table, select star, right? So select all of them from demo customer. So your table name was demo customer. So select all the data from demo customer where we use where clause where age is greater than is equals to 45. Let me just execute that. Yes, you can see 5 rows affected. Duplicate 0, warning 0. Now I want to see what is inserted in my table customer. So again, I am going to write select star from customer. Let me just execute this command.
Yes, you can see that I have 5 data in customer table from demo customer 1, 4, 7, 9, 10. These are the customer ID. So if name is Ramesh, Parul, Amit, Abhishek, Shankar, right? Whose the age is basically 45, 46, 76, 67 and 19. Right? So all the age we have that is greater than or equals to 45. Right? So this is how you can use insert command with the subquery. Right? Now we are going to use the update command. Okay? So maybe I want to update the age. Okay? So in that case, what you need to write update. So basically, whatever the command we have learned so far, I am just trying to use those commands in subquery. Right? So if you look at the query, you can see there are 2 particular parts you have in your subquery. So some of the cases, maybe you will have 3 queries at a time. So these are known as subquery, right? So I have written update. So I want to update something. Update in where? Update in customer. Update customer set age is equals to maybe 45 or age plus 2. I just want to make them plus 2 too. Where age in we use in for what? Okay. Let me just show you why do we use in. I think we have done this, but still, just for the recap from demo customer, where age in 45. Okay. Right. But we got the error. But where we got the error? Because we can use this in, right? This in over here. In is basically when your age is equals to 45 or it's like there is a range you have. Okay? Greater than 45 or less than 45, right? Greater than is equals to 45. Let me just execute that. No, it's not. Does not exist. Okay. I need to change of demo customer. Again, you have to be sure that what are the table you have, right? Otherwise, you will get the error. Yes, you can see this is done. So let me just tell. Okay. Now select star from customers you don't need to do. Okay. Yes, can you see? My data is updated. That is, my age becomes first one was 45, it is 47. Then it was 46, it's 48. Then 90, Shankar was 90, now it's 92. Right? So this is how our update commands work with subquery. Right? So we have learned about insert into, we have learned about update. Now we are going to delete some data. Okay, so how we can do that? So for that, I said delete from customer where age in. So if you look at this, why we are using this in? So in is basically the range of data set you have. So if you want this to check it out, okay. Let me just do that. Control B. Okay, let me just put the semicolon as well. Okay, I again don't have data of customer. I need to write demo customer. Okay. Yes, you can see we have this. So we have a range of data, right? We don't have one particular data. So I say delete. Then now delete from my table customer where age in, your age is in. Select age from data of customer is greater than is equals to maybe 60. Right? I want to delete all of them. Yes. Okay. Again, the same problem. Demo customer. Right? Let me just execute this. Yes, 0 rows affected. But why 0 rows affected?
let me just go over here. Right, we have customer. Okay, so here, if you can look at here, you can see select a star from demo customer. Right, let's have a look at what are the age we have over here. Yes, we have 45, 32. Yes, right. Now, what I want to do, I want to see from here. All right, let me just do that. I want to see what are the ages we have when the age is greater than or equals to 67. I think 2, 3 data we will have. Yeah, 3 data we have, right? Now, what we need to do, I say delete from customer. Yes, let me just try this out. Okay. Okay. No, but why? Again, why I am doing this? Suppose you want to delete from a particular table and you are giving the condition to that particular table, right? It will not work out. So what you need to do, right, select age from demo customer where age is greater than is equals to select age is greater than is equals to 60, right? Let me just do that. Yes, it's going to execute it, but we don't have any data which is actually greater than is equals to 60. That is age from demo customers. I give that condition that, okay, if you have any age, right, like this, if you have age that is, let me just print the name as well, right, you will understand, identify the data itself. Yes, if you can look at that, we have Amit, Abhishek and Shankar. Okay, suppose if we are going to look at select star from customer, the same thing, right? It will be the same thing. Okay. This will be customer. Okay, let me just do this. Amit, Abhishek, Shankar, right? So basically what we are saying, okay, first let's check that if there is any data we have that is greater than is equals to 60 or not. If we have any data, then please delete them from customer, right? So this is basically where delete from customer, where age in, your age will be, like the range of age will be demo, like it will take the data from demo customers where age is greater than is equals to 60, right? So basically using this subquery, you can insert the data, you can delete data, you can update data as well, right? Yes, now we are going to use one more technique. What is that technique? So if I come to here, so you can see, let me just use this part, demo database. This is also only you are using, right? Okay, so here what I said, select star from customer, all the data I want from customer, where customer ID, my customer ID. So if you write this, select a star from demo customer, right? Let me just execute that. Yes. Okay, so just write over here, use demo database, right? So maybe I am using the separate file. So, okay, I see, right? I have written down DO database, no, demo customer. Let me execute that. Yes, we have this. Now, what I said, select all the data from customer, where customer ID in, select distinct customer ID from customer, where age is greater than 25. Okay, so how it's gonna work? Okay. Just let me just execute one query first to make you understand how it's gonna work. So, okay, write it over here. Select distinct. What is distinct stands for? If we just don't write distinct, right? We are going to write select customer ID from customer where age is greater than 25. Okay, let me just execute that. Yes, we have this customer IDs, right? Comma if name, if I'm going to write, okay.
Yes, you can see I have customer ID, F name, and these are the customers we have greater than equals to greater than 25 age. Right? Now I said select star from customer. Okay, where customer ID in. This will be your condition. Let me just execute that. Yes, you can see I got all the data. And if we just remove distinct. So distinct is basically getting a distinct value. So there is no duplicacy. You can see we got it. Age is 47, 48, 78, 69, 92. So this is how your subquery works with select command. From both the cases, we are going to use select command, right? And in is basically it will go with the range of data set. So if you write is equals to, it will work with only one data, right? Okay. Now what we are going to do, we are actually learn about all this, this how this delete works, how this update works, how this select works, and insert into as well, right? So these are the quite of nested query as well as correlated query. So we do have lots of other options, like later in the tutorial we are going to make some project and we are going to feed data in a complex table as well. That time you will understand more easily how these concepts are working, right? So yeah, so these are the all about subqueries we have in SQL. Now we are going to talk about operators. It's any operator which is used with clause. So what is this any operator? The any operator only feeds the values if any of the subquery values meet the condition. Yes, so we already learned about what is subquery and how we can start using subquery. Suppose you have two query and you have used the subquery concepts, and from there you just used any operator which is gonna give you, if your one query meets any condition, it's gonna give you the result for that. So let's go to MySQL workbench and let's have a look at how this any operator works with subquery. So as we are using the database that is called use demo final one. So let me just use the same database we are using for joining the table. And if you want to see how many tables you have in the database, again, we are going to use show tables command. And from the show tables, let me execute that. Yes, you can see we have this tables in that particular database. We have account, we have aged customers, we have customers, data of customers, right? Now, maybe I want to say, hey, I just want to make a new database, right? So as we are doing the like subqueries and the tables, right? So I am going to use my demo final one, right? Let me just create the database. So anytime we create the database, we write the command called create database and then the database name, that is my demo final one. Now, as you can see, we have created the database. Now we are going to use the same database, that is called use demo final one, right? When you execute this command, your MySQL workbench will understand, hey, I just need to use the current database we have created right away, right? So this is how you can specify your MySQL workbench that which database you want to use for your particular project. Now, if you say, hey, I just want to see, like, we just make those databases and I just want to see how many tables we have. According to the, like, new database, we did not create any tables in that. Let me just do that. Yes, you can see tables in my demo final one is 0. There is no table we have created so far. So every time I am using one command and I'm showing how to create the table, how to make the relationship between them, because it's really important to understand how this RDBMS concepts works and how you can start creating your databases, right? And creating your tables on that particular database. So the same table we are going to use over here as well. That is called data of customer. When we have creating the create table data of customer, we have some attributes called customer ID, first name, middle name, last name, city, age, mobile number, occupation, and DOB, right? And whatever the varchar and int we have written, that is the type of your attributes or the column. So when we are actually storing the database in MySQL, we use a tabular format, right? So in the tabular format, we have rows and we have columns. So this your attributes will be the rows, right?
your attributes will be the columns. Okay, so you can see we have created one table, that data of customers. So if you just click show tables, you can see this data of customers is already updated, that hey, in the new database you have created one table that is called data of customers, right? Let me just insert the value. Again, for inserting value, what you need to do, just write insert into command and then your table name, then the values, right? And then your value, whatever the value you want to give. But be sure you are giving this value in a proper sequence, the same sequence you have written when you have created the table, right? So these are the main syntaxes you have to remind when you work with the SQL. Now, if you want to say, hey, I want to see that my data are already inserted in the table or not, you just need to write select star from data of customers, right? So we all aware of this like commands, right? As we also work with subquery, we work with joins and all these things. So it's like, it's a very basic commands over here right now. Okay, so now what we are going to do, as we already are like got this average, sum, count and everything, now we are going to make one table called account table, right? So in the account table, we are going to again write create table. The table name is account, right? You will have account number, customer ID, right? BID, branch ID, opening balance, and all these things. And again, the constraint, when the constraint part comes, so you have to be sure that, okay, my one constraint is the primary key and second one will be my foreign key. So as a quick recap of primary key and the foreign key, so primary key basically help us to sort our data. So, it actually helps us to reduce the data redundancy. There will be no repeated data. It will make sure for that. And when we use this foreign key concept is basically we use for making a relationship between two tables, right? So these are the main two key we use when it comes to RDBMS, right? So now what we are going to do, again, I want to see how many tables I have in my database. Is just a reconfirmations that your table is actually created. Show tables. Yes, let me just execute this. Yes, you can see data of customers is already there and account table is also there. So you have two tables. Now, if you want to insert them, the same thing, insert into which table and then your values with the same sequence, right? Let me just execute that. Yes, it's also got executed. Now, if I do write select star from account, you can see I have my account number, customer ID, branch ID, opening balance, account opening date, a type and a status, right? So this is how our whole concept works. Now we are going to use, okay, so now we are going to use what? We are going to use our any operator, right? So to do that, what we need to do, we can write yes, you can see over here, I have written one query for this, okay? So let me just make it big little. So for that, you can see my screen. Okay, so you can see if I write the same query again, select star from data of customers, we have this. Now what I said, hey, I want all the customer ID, that is select cust ID from account, that will be from our account table. So let me just go through over here, select star from account. So basically you will get every data you have in your account table, right? So I am going to use to subquery over here. What? So first one I said, hey, just give select customer ID, the customer ID we have from account, where we are using a where clause, where cust ID. Your customer ID is equals to, will be any, like any one of them will going to, use this particular condition, right? And any, then I said select cust ID from data of customers where city is equals to Delhi, right? So what it's gonna do, so first it's gonna take all the customer, like as we know it starts from the inner query first. So it's gonna take select customer ID, all the customer ID from data of customers where city is equals to Delhi. Let me just execute this particular query first. You will understand what you will it will return, okay? So when you say, hey, I select customer ID from data of customers, the data of customers where city is equals to Delhi. So you will get all the customers who are belonging from Delhi, right? Now what we are going to do, we are going to use this particular data to our outer query, right? So you can see we already in any, it's like any condition, like any customer you have, then only it's like if you have only one customer, then also it is gonna give you that result, right? Now if we say this customer ID from account, so this customer ID should need to be stay in account as well, right? Let me just execute this query. So we got 1 2 3 4. Yes, can you see we have this much 1 2 3 4, but this many time it is there in the count as well, right? You can see this, right? Yes. So this is how this customer ID is, when this customer ID is there in account table, it's gonna return you the query that, hey, I have this I have this data which is already there in data of customers and they are belonging from Delhi, and also this customers is there in the account table. So this is from also account table, they are from Delhi, right? So this is how our any is gonna work, right? This is how our any operators work. Now if I said, hey, what I got, let me just execute this. Yes, we got all the customer ID. Now if you say, hey, I just want to see the all details the customer has in the account, how can I do that? It's a very simple one, right? Your query will be same, but in the case of customer ID, you just need to write star. It's gonna give all the data from account table, which is the same way you have in the data of customer who are belonging from Delhi, right? Yes, you can see. So if you have this customer ID 11, so they have two accounts, right? So this is why you are getting this record for 2 times. For 2, for 3, 3, and for 4, you can see what we have. We have this 4 ones. 3, it's also 3, the customer ID 30003 has 2 accounts, C0002 and C0001 is also have 2 accounts, right? So this is why you are getting the same customer ID for twice, okay? So this is how the whole concept works, okay? Can you see? If here we got 4 only once, but for 3, 2, 1, the C0001, C002, we got how many times? 2, because they have 2 accounts, right? So this is how this any clause works, right? Now we'll go back to our presentation. We will have look at the next operator we have, and then we will again come back to MySQL workbench to understand how these operators are working. So basically for each and every time what we are doing, we are learning one concepts and then we are coming to MySQL workbench to see how these concepts are working, to make your doubts clear. And we are trying to make a data set or trying to make a table every time, because you can revise as well. If you have any doubt on that, it will be cleared out. Okay, so this is how our whole concept is working in this tutorial. So again, if you have any doubt, do let us know in the comment. For that we can help you out to solve your doubts. We will love to, we will be very glad to solve your doubts as well, right? So let's go to presentation and let's have a look at what operators we have next. Now we are going to talk about all, right? All is also an operator which is also work with the clause only, right? So these operators is gonna work with the where clause or the clause or some conditions itself, right? So the all operator only feeds the values if all the subquery values meet the conditions. Okay, so what actually it wants to mean by that? So basically for any, if you can look at the queries, it's like any conditions for one row. It's like if your condition is satisfied for one particular row, then also it's gonna give you a result. But in the case of all, if your one row it's not going to match, I mean maybe 9, you have total 10 rows and from 9 it's gonna match, but for 1 it's not going to match, it's not gonna give you any results, right? So this is how this all query works. So let's go back to MySQL workbench and let's have a look at how we can use this all. So whenever you're going to use all and any, be sure what you want. You want for your full table will be, it's gonna use the same condition, it's gonna match all the conditions, then only you will get some results. But if it's gonna use any operator, in that time you can say, hey, if it's gonna match only one rows itself, it's gonna give you an answer, right? So whenever you're going to choose your operator, be careful, and to some extent you have to have a proper understanding that how your operators are working, right? So let's go back to MySQL workbench and let's have a look at how this all operators works. So we are going to use the same table again, the data of customer and the account table. So we are going to use the same query itself, right? So maybe we are going to say, hey, I just want to see all the customers ID and your all the data, all the customers should belong from Delhi, right? How we can do that? So obviously, as our all the customer is not from Delhi, we are not going to get any results. I hope you understand that how this all operators and any operators works. So basically what I try to do that using the same query and using different operators, we'll try to make you understand what is the difference between all operator and any operator. So when you put the all operator, you will get no results. But why? Because your all customer is not from Delhi. You have different customers from different city. Right? So in that case, what you will get no results. So, but if you put any, you will get the results because some of the customer are from Delhi, some of them from Chennai, some of them from Kolkata. Right? So this is how your all and any operators works. But what is view? View stands for virtual table, which is based on the result set of an SQL statement. Right? But why do we need view again? Just wait. Just let's have a look at why do we need view. So normally in view, it contains row and columns, which is like a real table. It's like a real table if you're going to create a view. The fields in a view are from one and more real tables in the database. So maybe you want to say, hey, I want to make a table from different attributes from different table. But it will not be a real one. But it looks like a real table. Yes, that time we go for using view technique. Right? So let's go and let's have a look at how this view are working. Okay, we again came to the SQL workbench. Okay, so if you look at creating view, you need to write create view. The first, command that create view, and then you have to give a view name. So aged customer, right? So I just want to say before 40, like after 45, the customers are not in a young group. Right? So you make, okay, this is the aged customers. The view name will be aged customers and select. What after that you need to write as, okay, as a alias, right? Then you need to write select first name, age and city. You want first name, age and city from data of customers. Okay. So where age is greater than 45. Okay. So I said, hey, I just want to create a view which is the age is more than 45 and I want to see all the customers. Right? It will be like a real table, right? Let me just do that. Yes. Now, as we say, this view is already created. Now we need to talk about aged customers, right? Select star from aged customers. It's already like a table. If you can look at Parul, Amit, Abhishek, Shankar, they are actually more than 45 and they are going to be in the view. So Parul is age is 46, Amit is 76, Abhishek is 67 and Shankar is 90. So this is how your views are going to work. Let's have a look at the data of customers and maybe we can make some more view. Okay, we can start with the city. For city, the Delhi one, we want to see all the Delhi customers, right? So here, if we can write the same one and just let me just try this out. Create view, Delhi customers, right? I want to see all the Delhi customers as select if name a city when, okay, city is equals to Delhi, right? Let me just create this view. It's already created. Now I need to write select a star from Delhi customers. Again, it's not case sensitive. Okay. Can you see all the Delhi customers you got? Ramesh, Avinash, Rahul, Parul. They all are from Delhi. Yes. So this is how your view works. But if you write this show table, see, maybe you can say, hey, I just want to see the tables is already created or not. Let me just execute this. Can you see? This view is already there. These are tables, but this is views, right? This is the views, okay? So whatever you have created, it looks like real table, but it is views. This is not like real table, okay?
Yes, so this is all about, we have learned about views. Now what we are going to do, we are going to do a demo SQL with Python. Right, so let's go to MySQL workbench and let's have a look at how we can do and how we can connect SQL with Python. Right, so if you just like install Jupyter Notebook, that time you will get an interface like this. And if you want to create your own notebook using Anaconda or this Jupyter Notebook, you need to click to new, from there Python 3. Right, if you click over there, can you see, you will get your first notebook over here. The same way I have make my notebook. So what you need to do first, you need to have a connector. If you ask me why, because Python needs a MySQL driver to access the MySQL database. So that time if you want to install this in Anaconda command line itself, you need to write conda install -c Anaconda MySQL connector Python. And if you want to do this in a pip install, you can do this over here itself, pip install MySQL connector Python. Right, now as you have already done the connection, right, your connection is done. Okay, so if you want to check if your connection is actually, the driver is already installed, now you need to connect the MySQL. Start. If your driver is already installed, now if you want to check that connection is working or not, for that you need to do something. What you need to do? So what you need to do, you need to import mysql.connector, this library. After that, what you need to do, mydb, your the variable equals to mysql.connector.connect. So basically you have to call this function to connect your MySQL, right? So mysql.connector.connect will help you to connect your SQL database with Python. So now if you ask me this host and user ID and password from where I got it, so if you go to MySQL, right, and if you go to file, right, not the file, if you go to this home button, right, can you see this is the root you have, the user is basically root. So I have written this is the root, right? Host, if you look at over here, your host is localhost, right? So I have written localhost over here. Now comes the password. Whenever you are installing MySQL, I have shown in the MySQL installation as well, you have to give a password. For my case, password is 12345678, right? So in your case, whatever the password you are going to give, you need to write that. Now I want to check, I am printing mydb. Why? I want to check is the connection established with the SQL with Python. If it's there, then you will get that connector.connection.mysql object and this, right? Okay, let me just do that. Yes, can you see it's already connected to my SQL. Right, now what I want to do, I want to create a table. So mydb.cursor. Now we are going to see how can you connect your database with MySQL. As we have talked about the connector, we already installed over here that pip install MySQL connector Python. Right, if we just re-execute this part, you can see this is already the connector of the MySQL will be there. After that, what we are going to do, we need to import mysql.connector. After we use this import.mysql.connector, then we need to use a variable, the variable called mydb. I have shown you that already my host name is localhost, user is root, and password is 12345678. I have given. So basically, normally in default, all the cases, the host will be localhost if you don't change it, and the user will be root. But the password is always changeable as the password, whatever the password you are going to give for your particular database or MySQL workbench. Now, if you can see, database equals to SQ. So let me go to MySQL workbench. So here you can see I have created a database called SQ, and I said, hey, use SQ. Right? So my database name is SQ, and I have put them. Repeat. So my database name is SQ, and I said my database, hey, use my database, that is SQ. Okay, now what we are going to do, as we have done this database name, let me just execute this. So can you see we got this? So here, as we have done the MySQL connector Python, it's already requirements already satisfied, it's showing. And here, yes, if I just put this, can you see we got this? There is no error over here. Now what we are going to do? Now we are going to use a my cursor. So we will talk about what is my cursor. So before that, if you can see, we have done this MyDB variable. Under this, we have defined everything, our database name, MySQL user, password, everything. Right? Now, what we are going to do, we are going to call a variable called myCursor. Right? But why do we need cursor in MySQL? Okay, so right. So cursor is basically like a, it's just like a object, right? And it's basically help you to go through all the databases you have, or all the command you are providing for execution, for inserting data. The cursor will help you to do that. So basically, as we were talking about the cursor of MySQL is basically a connector which is used to execute the statement to communicate with the MySQL database, right? It basically helps you to communicate with your MySQL database, right? And using the methods of it, what you can execute SQL statements, right? Fetch data from the result sets, call, and procedures. And you can create cursor object using cursor function. As you can see, we have used cursor function or the method of the connection object or classes, right? So this is how this dot cursor function works, right? It helps to establishing the connection with MySQL database. Now, if you look at it, we are going to call a function called dot execute. So why do we need dot execute? So myCursor dot execute basically we use for execute a command. So what command we are using? We are using a command called create table customer, right? So create table customer is basically you have two attributes. Your one attribute is name, which is type of varchar, right? And one attribute you have called address. The varchar again is 255. Okay, so this is how we are using it. So here we have written the same, the command we know to create table customer, and then you have provided in the bracket, in the round bracket, what are the attributes you have. Let me just execute this one. Can you see it's already, okay. It's saying it's already exists, if I am not wrong. Yes. So what we can do, already we have made this. So if we want to see what are the table you have, show tables, right? Let me just execute this. Okay, you have a customer table. Now I said, as I want to make a customer table in this data set, now I want to drop the table. Okay, drop table customers. Okay, let me just execute this one. It's dropped, right? Now if you put on this show table, you have no table over here. If we go back to again the Anaconda, so what you are saying that, okay, we are going to create a table called customer. Let me just execute this. Okay, can you see it's already executed, right? Now I will do the same thing I have done using show tables, right? To check whether you have table in your database or not. What to do? Again, you need to use myCursor, a variable, equals to mydb.cursor. So why we are using mydb? Because the connection you have made with the MySQL with Python, that is the variable under the variable mydb. So mydb and dot cursor, it's help you to again establish the connection. Now, what I want to execute, if you need to execute any particular command or query, in that time you need to use dot execute function. So I have written myCursor dot execute, then show tables. So basically it will help you to show the table. Now I have used a for loop. If you ask me why, because for x in myCursor, print x. Maybe you will have more than one table, right? That time you need to use a for loop to see what are the tables you have. If I'm gonna execute this, can you see you got only customers, right? And let me just try one more thing. Maybe I am going to write my cursor. Okay, right? So okay, in my cursor, what it's gonna return, it's returning my SQL cursor show tables, right? From here, if you can look at over here, that my cursor, that time whenever you are using a for loop, that time it will fetch the table name, right? It will fetch the table name you have in your database. I have one table called customers. Now, if I'm going to execute the next command, which is an alter command, what I'm going to change in my table? I said alter table. The query we have alter table, then the table name, that is customers, add column. I want to add a new column, that is ID, right? The column type will be integer auto increment. So it will take a auto incremented value. If whenever you are going to put a new record, it will take 0, 1, 2, 3, 4, 5, 6, 7, 8, right? You don't need to put it manually. So auto increment, then primary key. So we know what is primary key. So primary key is basically a unique key, or you can say a key which is basically help you to reduce the data redundancy, right? And it also helps to make a relation with the other tables. So it's basically the part of a key in relational database management system, right? Yes. So in this case, it will be your new column. Okay. Now what we are going to do, we are going to insert value to our customer table. How to do that? The same way, we have a variable called SQL is equals to insert into where you need to insert in the table called customers. There you will be having a attribute name and address, and the value percentage is for the value, right? Now if you see the value we gave, that John and Highway 21, that is the address and the name. So I said my cursor dot execute SQL and value, the query and the value we are providing. Then mydb dot commit. Dot commit is basically help you to execute or insert the data in the your database, right? And when we talk about that print mysql dot row count record inserted, right? It will show you how many rows are actually commit. Okay, how many records you have put in your database, and then it will come record inserted, right? Let me just execute this part. Okay, can you see one record inserted is showing as we have given one value, right? Now if you want to insert a multiple value, what you need to do? First you need to write the command, that is SQL insert into customers. Then you have to provide the attribute name, that is name and address. And then you have to give the value, that percentage is. Then I am giving us lots of sets of value. Can you see? We have used a square bracket over here, right? And we have given lots of value like Peter, Amy, Hannah, Michael, Sandy, Richard, Susan, right? We have these names and the data to insert that to our database. Now we will do the same thing. My cursor dot execute many. So whenever we are going to use execute many, whenever we have a lot of data to execute in one time. So in that case, we are going to use one function called execute many. Okay. And then what we are going to do, SQL, we are sending SQL and val both. Then mydb dot commit. So we are going to say, okay, you just already executed using my cursor, and then we are going to use mydb dot commit. And if you use the same one, that my cursor is dot row count, it will give you a row count and was inserted, right? That will be your text. Can you see 13 was inserted? Yes, this is how you can insert data to your database from Python. Now let's go to MySQL and let's have a look at, are they really there? Are they already? So now we are going back to MySQL database and we will have a look at, are they really inserted to our database or it's not, right? So it's a both side validation from MySQL and Python as well, right? So let's go to MySQL and let's have a look at that actually this 13 records are inserted or not. And the commit function, basically you can say it allows you to perform multiple queries at once, okay, and automatically roll back the changes if one of them fails, right? So this is the reason why we use .commit function. So let's go to MySQL. As you have seen that we are going to use SQ database, then show tables. Right? Can you see? We actually have the customer table over here. So we have created customer table through Python. Now what we are going to do, we are going to write select star from where? From customers, right? So as we know why we use that. So we use it to fetch the data from a database. That select command is basically used to, select the data, all the data from the particular table. So we use select star. Star basically you want all the records to be returned from customer table, right? Let me execute this. Can you see the total 13? So we will count, like if you want to count, right? Total 14 will be there if I am not wrong. So we are going to use a predefined function, that count function, to check how many records we have in our database. Right, let me just execute this. Can you see 14 is there? So you actually can confirm, okay, whatever I have inserted through Python, it's already inserted to my database. So our database and Python is connected. Now we can do any program, we can do any, sort of query, we can use this. I mean, basically you can directly use your database using Python. So maybe you have a website and from there you want to put some databases and you want to check. I mean, you are taking the data from website's front page and you want to take them and you want to store them to the database directly using Python. You can do that, right? Now again, let's have a look at what else we can do. The same thing, that select star from customers that we have done in the MySQL. Can we do that? So yes, we can do that. You need to write mycursor.execute and then your query, that is select star from customers. Then my result is equals to mycursors.fetch all. It will fetch all the data you are going to get. Right, and from there you are going to write for x in my result, as we need to use a for loop to get all the record one by one. Then you say print x. Can you see it's executed all the data you have got? So maybe if you want to write over here, select star from customers, what you will get? The same thing you will get, right? And if we write count, right? The same thing we have done over there. What we will get on this? Can you see? You got 14. Yes, so this is how this whole scenario and whole, this concepts work, this how you actually can do all the query. If you know how to write MySQL query and if you know how to connect MySQL with Python, you can start making your own website and you can start, connecting your database with Python. Now comes mycursor.mydb to check where this where conditions works in the SQL, like we use where clause to give some condition, like according to that condition we are going to fetch the data. So we can check that is where clause is working over here or not. So we have written again my cursor equals to mydb.cursor, the same procedure. For the query, we have written select star from customers where address equals to Park Lane 38, right? So why want all the data if the address equals to Park Lane 38? Then all that my cursor dot execute and then your command. And then my result is equals to my cursor dot fetch all. So if you just look at it, can you see you got joined, that is highway 21. Okay, sorry. I am so sorry. You got the answer, that being Park Lane 3811, right? This is your answer after putting the where clause in your query. Now, if you put the pattern matching, right? You want to weigh, the weigh word should be there in the address, then only it will return all the data. So that time you need to use like function, right? Or the like keyword basically. So like keyword will help you to do the pattern matching. If you say how and why we are writing this percentage. So basically this percentage sign are basically the way, after the way, right? After the way word or before the way word, there can be anything. But this particular way, this WAY should be there in the address. So we have written select star from customers where address like way, right? Like percentage way. So you can see high the high is before there in way and after 21, right? There is one way, side way, right? So that is the thing. So the way particular keyword is there in the address, and we use like function for that, right? Then we used order by. So why do we need order by? Order by is basically nothing but is giving you your data in an ascending or a descending order. So you said, hey, I want all the customers' name which is in an ascending order. So in default, it makes your data in an ascending order. So ascending order through which column you want. So in this case, I want the name. The name column should be in the ascending order. Now, if you say I want my name to be in the descending order, you are going to use order by clause itself. But what you need to do, you need to use writing DESC. So DESC, if you look over here, this DESC defined you want your data in a descending order. Let me execute that. Can you see? You got William, Central, Vicola, Vicky, Susan, Sandy. Last me you got Amy, right? So yeah, this is all the queries we have learned about SQL, and I have shown you a few examples that how can you actually connect SQL with Python.
After diving into SQL and learning how to integrate Python with MySQL, it's time to think about how you will apply SQL in your upcoming project. We would love to hear your ideas. Share them in the comments below. Next up, we'll look into the transformative impact of generative AI in data science. Generative AI, including tools like ChatGPT, is revolutionizing the way we approach data-driven tasks. We'll explore why generative AI is so crucial in today's data science landscape for analyzing the data. Excited to see how generative AI is changing the game? Let's jump in and get started. Generative AI is transforming data science, creating new possibilities by generating synthetic data, enhancing predictive models, and automating tasks. This technology is particularly valuable in areas like data augmentation, where it fills gaps in datasets, improving model accuracy. Looking ahead, generative AI is set to automate more of data science, freeing up professionals to focus on strategic decisions. Through APIs, companies across industries can easily integrate generative AI, harnessing its power for tasks like content creation, data synthesis, and advanced analytics. In healthcare, finance, entertainment, and marketing, generative AI is already making a significant impact, driving innovation and efficiency. As it continues to evolve, generative AI will redefine how we generate, analyze, and interact with data, making it cornerstone of the future of data science. Having looked at the importance of generative AI in data science, if you want to expand your knowledge about its tools like ChatGPT and how it can be used for data analysis, make sure to check out our full tutorial on Data Analyst. The link is given to the right in the corner. Don't miss out. Next, we'll turn our attention to data science projects, where you will learn how to apply your skills to real-world problems. Ready to put your knowledge to the test? Let's get started.
Google Colab, I hope you all know how to do Google Colab. So Google Colab, I'm not going to show you how you are going to use Google Colab, right? Okay, so what is this data all about? As we know, beer is one of the most democratic and consumed drinks in the world. Not without reason, it's perfect for almost every situation, right? From happy hour to large wedding parties. If you just think about it, you already feel like having a beer, you are not alone, right? The truth is that around the world, thousands of people consume drink regularly and also in different situations. But have you ever stopped to think about which countries are the most consuming beer in the world? Did you? Okay, the first one of the came to your head was Germany. Well, no, that is not so. The answer to the question is resounding that according to the research by the Japanese beverage company Kirin, the country has topped the per capita beer drinking table for 23 consecutive years in 2015. The most recent years for these statistics are available. Right, the seasons ranked 142.4 liters per person. Can you even imagine? Right. Yes. So that's the equivalent to 250 pints, right? On every 35 hours. But given that minors are unlikely to be contributing to the figure, it's safe to assume the average beer drinker probably guzzles quite a bit more. Snapping at the Caesar Republic's hills are the usual pretenders. Australia and Germany
come third and fourth. Poland 6 and the Ireland 7. There are some surprises, however, in the second place in the lofty ranking, which we will put down to the hot climate and the larger number of polymarks. Right. So this is the whole data set is all about we are going to talk about, right? So in the data sample were collected from in Sao Paulo, Brazil, in the university area, and where there are some parties with group of students from 18 to 28 years of age. So this is the data set we are going to talk about. Okay. The data set used for actively 7 attributes being targeted with a period of 1 year. Okay. Right. So this is the data set we are going to talk about. So this data set you will get in the Kaggle itself, right? Beer consumption or beer data set in Sao Paulo, right? Now we are going to use some of the libraries. We are going to use NumPy, Pandas. Why do we use NumPy? NumPy is a numerical Python, right? So we use NumPy for numerical purposes. We are going to use Pandas for data manipulation. We are going to use datetime to make our data into converting to datetime. So yes, now what we are going to use? We are going to use Seaborn and Matplotlib. Why we are going to use Seaborn and Matplotlib? For the data visualizations. And scikit-learn we use for confusion metrics and machine learning purposes. Right? Now what I have done, I have taken this data to the Dropbox and I have already saved over there and I am just fetching from the link. Right? So for that we are going to use wget function. So wget function we are going to use because it's help us to fetch the data from any given link. So you can see over here, let me just execute this and this. Okay, so in the beer data, we are going to make a variable called beer data where we are going to use pandas and we are going to use read CSV function to read the CSV data. So as you can see in the beer data variable, we got our data. If we can use head function. So when we use head function, what we do in the head function, we get first 5 rows. It will return you first 5 rows of your data set. Let me just execute this. Okay, so this is our data. Now, if you want to see what are the columns we have, right? So just to try to see what are the columns we have, just put dot columns, right? If you just write dot columns and then you will get what are the columns you have. I have data, temperature media, temperature minima, temperature maxima, precipitação, final day semana, all these things, right? So yes, we have these columns. Now if you want to go for doing the dot shape, this dot shape is going to say how many rows and how many columns you have. We have 941 rows and 7 columns. Now comes the data evaluation, or you can say exploratory data analysis part. Now we are going to use dot describe function. In the dot describe, what you will get in the dot describe is going to give you count, min, standard deviation, maximum, 25% IQR, 75% IQR, 50% IQR. So this is the what we are going to use dot describe function to describe your data set. Okay. Now what we are going to do, we are going to check is there any nan value is there or not. Fine. So we are going to check is there any nan value or the missing value is there or not. To check that, we are going to use dot isNA function. So we have our data beer data, then we are going to use dot isNA function to check is there any nan values is there or not, and then we are going to use dot init, right? Let me just execute that. They say no, there are no missing values are there. Your data is actually good to go. Now there is for the null columns, again if you want to see what are the null values you have and the percentage, right? So number of null values and percentage you will get over here. Now if you say, hey, if I have any nan values, then please drop that. How to do that? Beer data drop any, then in place equals to true. It's basically we use drop any function to if you have any rows with nan values, then please drop it. We don't want that. Now we are going to, as you can see, there are lots of strings are there, right? If you can see, there is a comma, right? What we can say, hey, I don't want comma, I want to make them as dot, right? So we use dot replace function to make those comma to point, right? So this is how we are going to use beer data dot replace comma, that is going to replace with dot. Rejects is equals to true. These are the rejects we called as, and in place equals to true. Let me just execute that. Now, as we have data, in that data, we are going to make those data as a, let me just print that via data dot height, right? What's gonna give? It's gonna say when you have data, these datas are basically date, right? So we just change those data to what? Date. How to do that? Called pandas dot. Okay, we are going to do pd dot to date time, right? So we are going to do what? We are changing our data columns. Okay, we are changing our data columns to date time, right? So for that, pd dot date time, and which column, which particular column you want to change to date time. Now, as we can see, the date time is we are going to use to date time. Now, as we are saying that days, what do we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And we are trying to figure it out that in what day the beer consuming is high. Okay. Now, as we can see the days, okay, days is like Monday, Tuesday, Wednesday. We are going to make a column called days, right? Okay. Now, in the day, what we are going to do? We are going to use a lambda function. What lambda function we are going to say? We are say beer data, that the data one that we have make this to date. So we are going to say days dot weekdays, right? So whatever date, as it's already a date. So if your date is saying, okay, this is a date. So what are the weekdays? Make it weekday. What are the weekend? Make it weekend. Okay? So if you go and check this out now, let me just execute this. Yes. If you can see that, I don't know if you can see the full one or not, because of my picture is timing in the corner. So maybe I can do one thing. Beer data dot columns, right? So you can see there is a data is there and there is a day is also there. So 2015, this a little one is coming one. If you can see, 20150102 was a Friday. Right? So what you have done with the lambda function, you make those data or the day into the weekdays or weekends, right? So this is how we are going to do that. Now, okay, now what we are going to do, we are going to say, hey, we are going to use a Seaborn, right, to visualize our data. So in the Seaborn, what I said X will be X, we need to give the data. So X will be day and Y will be consumer day cerveza. What is consumer? Is basically how much consuming you are beer, how much beer you are consuming, and here you are giving the data is equals to beer data. Let me just execute this. Okay, can you see? If you just look at this graph, you can see the Saturday and the Sunday has the most consuming beer. Like if you can see in the graph, so can you see the Saturday and Sunday has the most beer consumed, right? As it's the weekends. And if we look at the Friday, Tuesday also there is a little high. Maybe after Monday, it still is there. So yeah, Saturday and Sunday is the highest, right? So this is how you can understand that, okay, beer consuming in Saturday and Sunday is really high. Then we are going to use a machine learning concepts. Before that, we are going to drop data and day, right? Okay. And we are going to make it numeric. This data and day, we don't make this two is as a numeric, but other whatever we have, like maximum temperature, like according to temperature, if the temperature is too high, you don't want to have beer, right? Okay, right. Now what we are going to do, you can see we are going to make it numeric because we are going to use all the data. Now what we are going to do, we are going to say train, trace, repeat from sklearn. Sklearn is basically a scikit-learn where we are going to divide our data into training part and the testing part. In the training part, whatever the data we are going to show, we are going to use our model. Our model will not know about the testing part. So what we are going to do? To do that, we need to write scikit-learn.model selection, import train, trace, repeat, right? From there, we are going to drop one column, that is the liters. Right, according to all the attribute, we are going to try to figure it out how much the liter, what will be beer consumption, right? So we are going to drop that particular column. So after that, X will have all the attribute, Y will have only the beer consumption. What is the total beer consumption? So this is our label data. This will be your label, right? Now what is the total consumption? From there, if you can see, we are going to make 4 parts. One is X-train, X-taste, Y-train and Y-taste, right? From there, we are calling a function called train taste fleet and we are giving our whole data, X, Y. And you said, I want 20% data to be test data and random state equals to 42. What is random state? Random state is basically, it can take any random data. There is no fixed point. First 80% will be your training and the last 20% will be your testing. Any data can be taken for training, any data can be taken for testing, right? This is why we use random state. Now we are going to import linear regression. As you know, the consuming beer liters can be a continuous number that will not be 0, 1, true, false, right? So it will be linear regression. So we import linear model from linear regression, that is from scikit-learn, and we call linear regression function. Let me just execute that. Then we feed our model. So we are going to feed our data using X-train and Y-train, right? So in that case, let me just feed means you are train your model with X-train, train value of X and Y. If you can look at here, we are going to predict the X-taste. We are going to give only the attributes. According to that, it's gonna give you, okay, you gave me X-taste. So if you can look at it, Y, great, right? This is the beer consuming array you got, 25.60, right? And if you look at the Y-taste, right? No, Y-taste. So what Y-taste will have? Y-taste will have the actual beer consumptions. Can you see our model is working really good? It's saying for this is 25.6. This is also giving 25.64. For the next one, it's giving 27. For the here, it's giving 31. Right? So basically, X-taste is like the prediction is basically going to give you what will be the beer consumption. And if you look at the score, I mean the accuracy with the new data, that is 74%. You can increase that as well, right? So this is our full demo. How can you predict beer consumption using machine learning? As we were talking about linear regression, so linear regression is basically a regression type where you can, the way we did, right? Independent variable, dependent variable, and we talked about that. Now, as we already talked about the prediction of beer consumption, I hope you like this demo. In this part, we are going to talk about credit card fraud analysis using logistic regression. In this part, we are going to do an end-to-end project using logistic regression to find a transaction is a fraud transaction or not, right? So in this case, we are going to use a data set from Kaggle itself, and we have uploaded this data set to Dropbox. Now, if I just want to show you the data set, so in this case, let me just show you what we have in the data set. But before start with the data set, we just need to understand that what are the things we have in the data set. So always look into the raw data to have a good understanding of your data, right? It's too big. Let me just download it. Okay. Right. So here it's not getting downloaded, but it's already there in my local system itself. So if I go here and let me just write credit card. Right. Let me just open the dataset to make you understand what we have in the dataset itself. Because we have talked about, we have few types of datasets. One is continuous type dataset. Your dependent variable will be continuous type. One will be your dataset will be categorical dataset. So you have classes. So here we will have two classes. One is the transaction is a fraud transaction or the transaction is a normal transaction. So it's a big file. It's a big CSV file, that is comma separated file. So it is taking little time. So when it's going to be open, and I will show you what are the columns we have in our dataset. Basically in the dataset, we need to check few parts, that is dependent variable, independent variables, and what is the type of your dataset. So this, your dependent variable is a continuous type or your dependent variable is a categorical type, right? So in this case, our data will be categorical as we will have two class, right? So it's almost 92%, yes. So if you just look at the data set, you can see we have time column
Then we have v1, v2, and so on. And lastly, we will have amount column, and then we will have class column. So the amount is nothing but the what is the amount of the transaction you have done, and class is 0. Basically, this is a genuine transaction. If the class is 1, do we have anything 1? If we have 1, then the transaction is a fraud transaction, right? Let me just check. Do we have? Did we just missed one? Okay, so if we have 1, so that means that transaction is nothing but the fraud transaction. Let me just check more. No, I don't get it right away, but it's fine. So let's go to Anaconda and not Anaconda. Let's go to Google Colab and let's have a look at how to go with the dataset, right? So I have just uploaded the dataset to Dropbox, and there you will get this shareable link. And in the shareable link, you can use in the Google Colab itself. Now, if you just look at what are the libraries we have imported NumPy, Pandas, Matplotlib, then matplotlib.pyplot. This is .pyplot is nothing but it's a MATLAB, right? You can directly use the MATLAB function. So this is why we use .pyplot. Then we have model selection, that train trace split from scikit-learn to split your dataset. Then we have classification report just to check what is the report accuracy. Then you have confusion matrix. We will talk about what is confusion matrix. Then we have import the logistic regression, as we are going to use logistic regression. And from there we have matrix and Seaborn, right? Seaborn is also a data visualization library, right? So this is the dataset link, right, from the Kaggle itself. If you just click on here, you will just redirect it to Kaggle website itself. It's a open source data. Anyone can use it, right? So this is all about the data, right? You can see this is the dataset, right? So you can directly download it from Kaggle itself. Just click on download, your dataset will be downloaded. Now, if you don't want to upload your dataset into Dropbox, then how to upload directly? Here is a box sign you can see. Click over here. Here you will get an upload option. Just click over here. It will redirect to your local system wherever you will have the the dataset. Just suppose technical support data I have. Just click over here and then open. It will automatically upload the dataset, right? Let me just do that. Right, so you can see your data is already here. But be sure this data, whatever the data you have uploading in Google Colab, it will stay for only 12 hours. After that, it will be recycled, right? So whatever the work you are going to do in Google Colab, make sure that you have downloaded. Right, now we need to use the .read CSV function from Pandas. So .read CSV function, how it's works, it's nothing but it's going to read the comma separated values, right? So in this case, you have to give the path for your dataset. But wait, from where we will get the path? We have just uploaded the dataset. So here you can do one thing. If you just hover over this dataset you have, and you will get a 3 points over here. Just click over here, you will get the option for download. If you want to delete the file, delete. Then rename if you want to rename the file, and copy path. So if you just copy the path and if you just put the path over here, it will automatically read the .csv file. Right? It's automatically reads. Right now, if we talk about the dataset, it contains 285000 rows and of the data and 31 columns we have. The most important columns are time, amount, and the class, that is fraud or not fraud. Right? And if your class is equals to 0, it's not a fraud transaction, it's a genuine transaction. If your class equals to 1, it's a fraud transaction. Now, if we just want to see the first 5 rows of our data set, how to do that? You just need to use data df, where we have actually, if you can look at the variable, we have stored our CSV file, that is data df. And if you just write data df dot head, you will get the first 5 rows of your data, right? Can you see time, v1, v2, v3, v4, and so on, and amount and class, right? You have. Now, if you want to check the shape of your data, how to do that? You just need to write data df dot shape function. It's going to return you how many rows you have, how many columns you have. So we have total 284807 rows and 31 columns. Right? Now, if you want to check the describe, so where to use describe? And one more thing I want to show you, if you want to check the columns, so data dot
column. So basically it will return you what are the columns name you have in your data set. Sorry, it will be data df, right? So what are the columns you have in your data set? So these are the 31 columns I have in my data set, right? Now, if you want to check the describe, so describe is nothing but it's going to return you some statistical information about your data set. So particularly for this 3 columns, I want to check the statistical information of my data set. So in this case, I have written amount, time and class, right? Can you see the list I'm providing here? And then we have using dot describe function. So if I just click over here and just execute it, you can see we have total count of the data, you have the rows, then you have the mean value, right? What is the mean of your total column? Then you have standard deviation, then you have minimum amount you have in your data. Then we have IQR, that is interquartile range. So interquartile range, if you want, if you just divide your data set in 4 different parts, first quantile, second quantile and third quantile and so on. So this is 25%, 50%, 70% and max. So this is all you will get about if you just use dot describe function, right? Now it's just columns is already done. Now we are going to check, is there any missing value do we have in our data set? As we have talked in that as well, this missing value, if you have missing value in your data set, it's not going to provide a good prediction for your data. It's always give you some, arbitrary predictions, and it's also not perform well, right? So in this case, make sure that your data does not have the type of the missing value will be really less, right? So in that case, to check with missing value, what we need to do, we need to use one function that is called dot isany function. Let me just cut this part, right? If I just use datadf dot isany, that time you can see it's going to provide me for each and every rows and columns, right? Maybe for each and every index itself, it's going to give you, is there any null value is there or not. But looking at this like this, it's not possible to, you can see the most of the cases is false, but maybe there is a true, maybe you will not able to find it out. That time we are going to use a function called dot any. So dot any function, what does this dot any function? It's going to check for each and every column, is there any null value is there or not. Is there any null value, it's going to return you true, otherwise it's going to return you false. Normally it returns the boolean values. For time there is false, for all the cases you can see there is false, so we can say there is no missing value. Now if you want to again reconfirm it, we have done a manual job, right? So what we have done, we have used the columns, and we have actually making a data frame here. Here we have columns, that datadf dot isany dot sum. Is there any that what is the sum of the dot, null functions we have, or not the null function, not the null value basically we have. Then we have if you have then dot index, then number of null values, right? So what is the number of null values you have, then values, then percentage. So basically we want to check what is the percentage of the null value we have. Now if we just print it, so what we will get columns, the column name, we have the number of null values, that is 0, and lastly we have percentage. What is the percentage of null value we have? So here you can see this is all as 0, right? So we can say the null value percentage is 0 for this particular data set. But normally for the real time cases, you will not get a data which has 0 null value. So always you have to try to understand how to find it out the null values and the missing values as well. So now if you want to check the last 10 rows of your data from the class itself, you just need to use dot tail function. Can you see? We got it. Now we are going to check the percentage of total number of fraud transaction. And what is the percentage of genuine transaction you have in your data set? So for that, what we have done, we take a variable called nf count, and this is equals to 0 because it will work as a counter, right? Now what we have done, we have written not fraud equals to data df, and then you want class, okay? So whenever, let me just add one cell over here. So whenever we try to get particular cell, like a particular column from your data set, that time what we have done, so we try to take the particular column name, right? So for my case, I am going to take class.
right? So you can see what it actually have. This class is nothing but your outcome, and it is a dependent variable or on other columns you have. And in here you can see it's not fraud equals to, we take the whole class, right? So now what we are actually trying to do, we will try to count all the one, right? It's not fraud. So basically we will try to count all the zero, like how much zero you have in the particular column, and divided by the total number of records you have into 100. So that's how we can actually understand the percentage of genuine transaction in your data set. So in this case, what we have done, you can see not fraud equals to data df class. Now we have used a for loop, and we have written that for I in range length of not fraud. So it will go the length of not fraud. Like for this, you can, if you want to see what is that, let me just write it over here. So not fraud, right? If we can do this two particular is over here, and if we just write one more code cell, let me just execute that. Now what we are going to do, we are going to say not fraud, okay? And here we have used length function, right? So you will get nothing but the length of the not fraud. So total number of rows you have in your data set. So you can see this is 284807, right? So now what we have done over here, we actually, your for loop will walk till this part, right? And if said if not fraud of I, not fraud of I is basically the value you have, not the index number, 0 or 1. So not fraud of I equals to 0. If it's equals to 0, then please increase the counter. My counter is nf count over here 0. It will count 1 plus 1 plus 1, right? Then what we have done, we have done that the percentage. So you got that nf count, right? Here you got the nf count. So now you know how much, like if I just write here after this, if I just, okay, let me just break it in few parts for that you can understand what actually we are trying to do. So here, right. So in this nf count will have all the count of 0 you have in your data set. So you can see 284315 records you have, they are 0. Basically, they are the genuine transaction. Now what I have done, I just want to understand the percentage. So nf count divided by total number of records you have into 100. So for that, you will get the percentage of total not fraud transaction or the genuine transaction. So 99.82 percentage of data set you have, that is a genuine transaction. Now we will count the fraud transaction in the same way. Again, we will take a counter over here. From there, you can see the fraud equals to, we take the class again, and what we are doing, we are writing fraud of I equals to 1. So we will try to understand how much like data or rows we have with class 1, right? So that basically nothing but your fraud transaction. Okay, so let me just do this as well. Right. So in this case, you will get the if count 492, right? It's a very negligible, but yeah, there are fraud transaction you have in your data set. So now if we just try to find it out the percentage, so it's nothing but 0.1%, right? So this is how we have understood that what is the percentage of genuine transaction you have in your data set, and what is the percentage of fraud transaction you have in your data set. Now, if you just need to plot it, right? How to do that? In this case, you have written plot data equals to pd.dataframe. You have created a empty data frame over here. Now you have written plot data fraud transaction equals to fraud. So the fraud you had, right? Now you just give plot data genuine transaction, right? Genuine transaction equals to not fraud. Then plot the data. So here what we have done, if you can look over here, right? So not fraud, it will become your if count. And this will be less, I think, right? And it will be nf count if I'm not wrong, but it's, yeah, right. So here you can see one thing, your fraud transaction will be, so you basically try to understand your fraud transaction and your genuine transaction, right? So in this case, what you have done, if we just remove this two part, right? Let me just do that. And let me just write plot.head. So basically you can do it, otherwise you can skip it as well. That's not the problem. Plot data. No, it's not coming. Why? Acha, okay. Fine. Why it's not coming? Because this F count is nothing but your total number, right? And this is how basically you can skip this part. There is no point of using. But yeah, if you want to make a data frame out of it, or if you just write the transactions, maybe you can write the transactions and you can use the data df class, right? Now, if you just try to print it, you can see the only like the class column you will have in this particular data frame. Now, what we need to do, we try to understand and visualize our data. How to visualize our data? We try to understand that what are the data are actually going to help us to understand what is the bar plot. We actually do bar plot to understand visually that what we have done, the calculation that is right or wrong. So in this case, what we are going to do, we are going to write plt dot, you can say plt dot title bar plot for fraud versus genuine transaction, right? So you can use bar plot or you can use count plot as well, right? So you can see what we have done. We have written x equals to fraud transaction, y equals to genuine transactions, right? And what we need to do, we basically try to give the data set over here. So here you can see what we have done. We were working with that bar plot, but now I want to have a count plot, right? So count plot over here will work as like, it will automatically count. Otherwise, you need to do all the count by yourself. So in this case, what we have done, we have written plt.title count plot for fraud versus genuine transaction, right? So now for 0 is genuine and 1 is fraud transaction. So if you just write SNS from Seaborn, basically if you write SNS.countplot, you can see this is the all about count plot. Show the count of observation in each categorical bin using bars. So you have two bin over here, 0 and 1. And a count plot can be thought of as a histogram across the categorical instead of quantitative variable. The basic API and options are identical to those for bar plot, so you can compare counts across nested variables. Input data can be passed in variety of formats and including the vectors data represented. At least there is no point of understanding this, but now you can understand. It will automatically count how many 0 you have in your data set, how many 1 you have in your data set. So what I have I have written that x equals to class, then data equals to data df, your data set, then palette equals to blues, I want the blue, and then age color equals to w, right? So you can see for in this case, whenever I try to execute it, for that you can see the 0 is the high, 1 is almost negligible, right? So you can see and you can say, okay, whatever the percentage we have, find it out, it's quite right, because in the bar graph in the count plot itself is showing the same, right? So as for the graph, we can see the ratio of genuine transactions and higher than the fraud transaction, right? So now if you want to check the plot, normal plot, how to do, you just need to write maybe for the x and the y, I just want to check between amount and time. So in this case, I have written data df amount and y equals to data df time. And then I have written plt.plot xy, and the title will be plt.title time versus amount. Right. So in this case, you can see this is the relation between amount and time. And this graph, we try to plot the relationship between time and amount. You can see this is the time and this is the amount. Right. X equals to, x equals to amount. So these are the 5,000, 10,000 to 15,000 is your amount and this is your time, right? How much time it takes to do the transaction. Now, if we just try to understand the amount distribution, where the amount is high, where the amount is what is the distribution of your amount you have in your data set, that time again, we are going to use Distplot, right? So Distplot is kind of a histogram type of a thing, you can say. So here we are going to try to do the amount distribution. So in the amount distribution, what we need to do, we try to understand the distribution of the amount in our data set. So here we are going to use Seaborn Distplot. So you can see we have taken only the amount column. Now, what we have done, color equals to red. I just want the distribution should be looks in red. So in this case, if you look over this, you can check, You can see from the amount distribution curve, it's shown that the number of higher transactions are very low. Obviously, so you can see this is the high transaction are really low. Most of them are in between 5,000, right? And so there is a high probability for huge transaction to be fraud, right? So this is the high. If you see there is a 25,000 and more like amount is high, so at that time there is a chance that your transaction is a fraud transaction, right? So now we will talk about the outlier. So for outlier, we can use box plot and we can use scatter plot as well. So we try to understand, because of this problem, we need outliers, because those transactions in a high, high amount, that time there is a chance that these are the outliers, and these are the cases where we need to find it out that, okay, these are the cases for my transaction can be fraud, right? So in this case, we try to use scatter plot. So that dot scatter, if you just call dot scatter and if you just give it your your scatter plot will be plotted using your data set. You can see this 25,000 only one dot here. So these are your data points. Most of the data points are from 0 to 5,000, and after 10,000 also you have, but after 10,000 all of our is your actually outlier, right? So in this case, we need outlier to understand the the fraud transactions behavior. And now if we talk about the correlation matrix, yes, there is a concept of correlation to understand the correlation between two different variable you have in your data set. So in this case, correlation matrix equals to data df dot core if you write, and if you just plot it with the figure size I have given 14,9, and if you just write a Seaborn dot heat map, it's nothing but it's going to give you the the correlation between two different variable for time and time. You can see it's you can see this is quite white. So this is the color range is also here. When it's quite white type of a thing, it's the high correlated. When it's near to black or blue and something like that, it's the correlation is low, right? So this is how you can understand the correlation between two different variable you have in your data set. So correlation matrix helps us to understand the correlation between two attributes, right? So now, yeah, it's pretty much about the data set. We have done the outlier analysis. We try to understand our data. We try to understand the fraud transactions. Now what we need to do, we just need to split our data for machine learning. So splitting our data is nothing but you can split your data at 80 and 20% or maybe 70-30%. It's up to you. So 80% for training, 20% for testing. So when you do the model training, that time your model will not see your testing data. So it will be a new data for your model, right? So for that, you can see for x equals to df, data df dot drop. So we try to have all the features in x, and the outcome column, the class column, the dependent column for others will be stored in y, right? After that, what we have done, we use scikit-learn to split our data. We have used, we actually split our data in 4 different parts. X-train, X-test, where you will have all the features. Y-train, Y-test both will have the class, right? And train test split function you have to call, and then you need to pass your X and Y. Then you have written test size equals to 0.2. That is nothing but 80 and 20%. If you write 0.3, it's nothing but 70% and 30%, right? And random state equals to 42, because we try to say that there is no hard and fast rule that first 80% will be for testing, will be for training, and 20% for training testing, right? So it's like randomly it will take the data and it will just make your testing and training data set, right? So yeah, it's pretty much about the X train, Y train. Now if you just want to check the shape of X train, you can write X train dot shape. Right? What you get? You get this 2, 2, 7, 8, 4, 5, 30, right? And if you just do the X test, you can check your shape like this. I will get an error. Okay. Right. For testing, you can see 5, 6, 9, 6, 2, and this is 30. Right? So this is how your X train, X test, Y train, Y test works. Now, if we are going to use logistic regression, we talked about logistic regression. For scikit-learn, what you need to do, you just need to call the function, right? Because there are a lot of, all the, you can say all the machine learning algorithm are already implemented in scikit-learn. So what we need to do, we just need to call logistic regression function, and you can see this is the logistic regression function we have called. Now if you want to train your model, you just need to call dot fit function, and you will provide x train and y train, right? Let me do that. Now if you want to check what is the prediction for your model, that time what you need to do, you have to use dot predict function, and this time you are going to give your only the features, and we will try to find it out what the class, right? So whenever you try to use ypred, and we are going to use give the logistic regression dot predict x test, and if we just code here ypred, right? So here we will get all the cars 1 0 0 0 0 0. So now if we try to understand the accuracy, we need to call one more function, that is logistic regression dot score, and you have to pass x test and y test, right? So now if we just try to understand what is the accuracy, let me just print it. So accuracy is 99.85%. So yeah, your model is working pretty cool and pretty fine. And if you want to add few other things, you can, right? And one more thing, I just want to explain that what is confusion matrix. So whatever the accuracy we have done over here, there is one more concept from those matrix as well, you can find it out. So in this case, we called confusion matrix. In confusion matrix, we have few parameters. That's positive, negative, true positive, false positive, true negative, false negative, right? So what is positive? Observation is positive. For example, the transaction is true. Then observation is not positive. For example, the transaction is not genuine. Then we have term called true positive. What is true positive? The observation is positive and is predicted to be positive. That is true positive. So both the cases is positive. Now comes false positive. So here you can see observation is basically negative. The predicted value is positive. Then your model is not perfect, like working well. Now comes false negative. So observation is positive, but your predicted is negative. Again, your model is not working fine. Then comes true negative, when the observation is also negative and the predicted is also negative. So when you're have more true positive and true negative, your model is actually working quite fine, because what your model is quite understanding with the new data that whatever it needs to be done, right? So the formula for accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative, right? So this is known as confusion matrix. And if you want to do this confusion matrix, if you want to check the confusion matrix, you need to write, and you also again need to import matrix, and after importing matrix, you need to call dot confusion matrix function, and you have to give y test, that actual class, and then ypred, that is actually predicted by your model. Now if you can look over here, this is your confusion matrix. And if you want to do the calculation of accuracy the same way, and you will get that 99.85% accuracy. With this percent of accuracy, your model is saying whatever you have done, it's right, right? So this is how we can actually start working with logistic regression. And I hope you understand that how can you start working with your new project on logistic regression.
Let's have a look at the interview question, what you can actually expect when you go for any interview for a data scientist, right? So first question is how to handle missing value imputation for quantitative values. So this is the part of again our exploratory data analysis when you are actually handling your unstructured data. So basically there are four options we have. Maybe replace them with mean, replace them with mode, replace them with median, or none of them. So your answer will be over here, that replace them with mean, right? Now let's have a look at the second question. How will you compare two quantitative variables? So your answer will be, we can compare them using correlation. Change of any one variable can affect the other variable, and it can be done in scatter or dot plots graphically. So we use scatter plot or dot plots basically to understand and to visualize your data. Now let's have a look at the third question. What is DER model and what are the methods dependent on it? So what is DER stands for? So basically DER is decision estimation rank. So decision is basically stand for to decide like yes or no, risky or not is not risky. Estimation is basically how much and when the variable are estimated, and rank stands for ranking them accordingly. Priority is what is more risky. Statistical techniques, machine learning and advanced analytics techniques are dependent on the DER model. Now let's have a look at what is forward regression. So forward regression is one of the automated mechanism of model selection. It starts with a variable and keep on adding variable till it reaches threshold. Now let's have a look at what is stepwise regression. So it is one of the automated mechanism of model selection that it starts with a variable and to some point it starts dropping variables. So these are the two types of regression we see so far. Now let's have a look at what is VIF and in what range it varies, right? So VIF stands for variance inflation factor, and VIF assess whether factors are correlated to each other, that is multicollinearity, which could affect p-values and the model isn't going to be as reliable. If VIF is greater than 10, problem of multicollinearity occurs, right? So this is how we actually go for using VIF, that is variance inflation factor. Now let's have a look at what is Fisher exact test. So Fisher's exact test is a statistical significance test used in analysis of contingency tables. Although in practice it is employed when sample sizes are small, it is valid for all sample sizes. Now let's have a look at what is correlation and what are its measures. So basically correlation is a process to measure whether two variables are related or not. Scatter plot is the graphical way of representing the relationship. Measures of correlation like strength of relationship and Pearson's correlation. Now let's have a look at what are the types of simple and multiple regression. This is one of the most important question when you go for any interview. So what is simple regression? So in simple regression we have two parts. One is linear and one is non-linear. And under linear we have continuous and linear regression. And in non-linear we have Poisson, logistic, multinomial, ordinal regression. And when we come for multiple regression, we have linear and non-linear. Now let's have a look at what do you mean by mean squared error. So basically mean squared error measures the average of square of the errors. That is average squared difference between the estimated values and the actual values. Now we came to the 11th number question. Is R square goodness of fit? So what will be your answer? R square is a goodness of fit measure for linear regression models. So this statistic indicates the percentage of variance in the dependent variable that the independent variables explaining collectively. For instance, small R square values are not always a problem and high R square values are not necessarily good. So this is how we can see the R square is basically goodness of fit. Now let's have a look at what is the difference between RMSE and R squared in statistics. So RMSE is the square root of the variance of the residuals. It indicates the absolute fit of the model to the data, how close the observed data points are to the model's predicted value. Whereas R squared is a relative measure of fit. RMSE is an absolute measure of fit. In addition, adjusted R square more than 0.75 is a good value for showing accuracy. In some cases, an adjusted R square of 0.4 or more is acceptable as well. Now comes the what are the state of art techniques in pattern recognition and machine learning. The two fundamental problems in machine learning are statistical analysis and algorithm design. The former tell us the principle of mathematical models that we establish from the observation data. The latter defines the condition on which implementation of data models and dataset rely. On the basis of the survey, pattern recognition techniques can be categorized into 6 parts. This includes statistical techniques, structural techniques, template matching, neural network approach, fuzzy model, and hybrid models. Now let's go to the next question. What is the difference between general linear models and generalized linear models? Now we will have a look at what is general linear model. So general linear model is a special case of general linear model, and generalized linear model is an extension of general linear model. This is quite tricky, right? So basically general linear model is a special case of general linear model, but generalized linear model is an extension of general linear model. In general linear model, response variable need to be continuous, but in the case of generalized linear model, response variable can also be categorical like yes or no, right? In general linear model, distribution of residuals is expected to be normal, but in the case of generalized linear model, distribution of residuals can be non-normal, that is like binomial for logist models. Now we will see the link function is a simple identity function like f of z equals to z for general linear model. But in the case of generalized linear model, include a link function that releases the mean of responses to the linear combination of predictors in the model like logic function, inverse function, etc. And the least square method is used to estimate the parameters of the model in the case of general linear model. And for generalized linear model, least square method is used to estimate the parameters of the model. So both the cases, the least square model is used basically to estimate the parameters of the model. Now let's have a look at what are the best application of linear regression. So basically linear regression can be used to optimize the business process. But before going into the answer, let me tell you what is a regression. So regression is basically finding out a relationship between two variables. So let me give you an example that what actually want to mean by that. Suppose sales of ice cream is decreasing in the season of winter, but when we have a season summer season, that time sales of ice cream is increasing. So we can say there is a direct relation between season and the ice cream sale. To establish those relationship between these two variables, we need to use our algorithm. So that time we go for using maybe linear regression or some other algorithms, right? So this is actually stands for regression. So now let's have a look at what's the best application of linear regression. So already we said that linear regression can be used to optimize a business problem. Suppose a baker and estimate the right temperature for its oven to increase the shelf life of its cookies. Or maybe in VPOs or KPOs, we can analyze the relationship between the wait times of caller and the number of complaints. Or maybe we can take some other example like imagine you want to estimate the demand of your customer or you want to predict the sales of a particular items in the future. That time also we can go for linear regression. Or the last example can be insurance companies rely heavily on regression to understand the number of claims at any given time. Popular use of polynomial regression. So these are the use case or business application of linear regression. Now let's have a look at what are the assumption of linear regression. This is one of the most asked question for an interviewer. So what are the assumption we have for linear regression? The regression model is linear in parameters. The mean of residuals is 0. Homoscedasticity of residuals or equal variance. No autocorrelation of residuals. The x variables and the residuals are uncorrelated. The number of observations must be greater than number of x. The variability in x values in positive. The regression models is correctly specified. So these are the assumptions we need to take when we go for linear regression technique. Now let's have a look at what are the consequences of violating linear regression assumptions. So if you are going to violate the linear regression assumption, what will be the consequence? Whenever we violate any of the linear regression assumption, the regression coefficient produced by OLS will be either biased or variance of the estimate will be increased. So this is the problem you are going to face when you are going to violate the linear regression assumption. Now let's have a look at what are the limitations of linear regression modeling in data analysis. So, linear regression modeling is one of the ways of specifying cause-effect relationship and predictive relationship in the data analysis. Variation in the data, both dependent and independent variable, it requires enough variation in the data. Assumption of deterministic independent variables independent of random error. This assumption is applied in many types of regression techniques. These are the limitations of linear regression modeling in the data analysis. Now let's have a look at how is least square different from linear regression analysis. So in linear regression is the task fitting a straight line to the data, whereas the least square is the objective or cost function used to complete the task. Find the straight line that minimizes the sum of square of the residuals. These are the other cost function that could be used to fit the straight line. Minimize sum of the absolute error, for example. So this is how least square is different from linear regression analysis. Now let's have a look at how is hypothesis testing used in linear regression. So hypothesis testing in linear regression can be used for following reasons. If statistics can be used to check whether the parameters of the linear regression equation are equal to 0 or not. That is, whether the model is appropriate or not. T-test can be used to check the significance of the individual parameters. Other methods like forward selection or backward selection also use hypothesis testing for selecting the variables. So this is how hypothesis testing are used in linear regression. Now we will have a look at, can we use categorical values in linear regression? Yes, we can, but you must use dummy variables. Suppose you have a categorical variable with k levels. You would assign a categorical variable in -1 levels. For example, suppose the categorical value is gender, which has 2 levels. Then you would have a single categorical variable. You then define 2 levels with a binary variable. It will have a value of 0 if the subject gender is male. If the subject is female, we assign the value 1. This is properly depend on you that you want to, if you want to make gender male equals to 1, you can go for it. And if you want to make female equals to 0, you can go for it. It's up to you. In this case, the base case is males. The regression coefficient of the categorical variable is the difference in the mean marginal score between females and males. Now let's have a look at what are the advantages and disadvantages of linear regression. So linear regression is an extremely simple method. It is very easy and intuitive to use and understand. A person with only the knowledge of high school mathematics can understand and use it. In addition, it works in the most of the cases. Even it does not feed the data exactly. We can use it to find the nature of the relationship between two variables. What is the disadvantages of linear regression? By its definition, linear regression only models relationship between dependent and independent variable that are linear. It assumes there is a straight line relationship between them, which is incorrect sometimes. Linear regression is very sensitive to the anomalies in the data, or you can say it's an outlier of the data. Another disadvantage is that we have a number of parameters than the number of samples available. Then the model starts to model the noise rather than the relationship between the variable. So these are the advantages and disadvantages we have when we go for linear regression. Now let's have a look at what's really linear regression slope formula. For example, for some simple linear regression, given x that the random variable and y the response that dependent variable, the slope estimate is given by the ratio of covariance between x and y by the variance of x. So in the formula we can see covariance of x and y divided by variance of x. This is how we are going to calculate the regression slope. Now let's have a look at why logistic regression considered a linear model, right? So logistic regression is considered a generalized linear model because the outcome always depends on the sum of the input and parameters. Or in the other words, output cannot depend on the product or quotient, etc. of its parameter. Logistic regression is one of the basic and popular algorithms to solve a classification problem. It is named as logistic regression because its underlying technique is quite the same as linear regression. The term logistic is taken from the logit function that is used in the method of classification. And I want to add one more thing for logistic regression. Always logistic regression work with a discrete value, right? So when your data set is a discrete data set, that time you should go for logistic regression. But when your data set is a continuous data set, you should prefer to go with linear regression. Now let's have a look at what are the advantages of logistic regression. So logistic regression performs well when the data set is linearly separable. Logistic regression is less prone to overfitting. But what is overfitting? So let me give you an example of overfitting. When your model works fine with the training data, maybe you will get a high accuracy when you are using training data set to your model. But when you are giving a unknown data to your model starts giving a very bad accuracy. But why does it happen? Because your model does not learn from the data. It starts reminding your data. This is known as the overfitting of the model. So this regression, this logistic regression is very less prone to overfitting, but it also can overfit in high dimensional data set. You should consider regularization, that is L1 and L2 techniques, to avoid overfitting in these scenarios. Logistic regression not only give a measure of how relevant a predictor, that is a coefficient size it, but it's also direction of association, positive or negative. Logistic regression is easier to implement, interpret and very efficient to train. Now let's have a look at what are the disadvantages of logistic regression we have. So main limitations of logistic regression is the assumption of linearity between dependent variable and the independent variable. In the real world, the data is rarely linearly separable. Most of the time, data would be jumbled maze. If the number of observations are lesser than the number of features, logistic regression should not be used. Otherwise, it may lead to overfit. Logistic regression can only be used to predict discrete functions. Therefore, the independent variable of logistic regression is restricted to the discrete number set. This restriction itself is problematic as it is prohibited to the prediction of continuous data. So these are the disadvantages we have for logistic regression. Now let's have a look at how do you interpret concordance in logistic regression. In case of logistic regression, we may fix our cutoff value. However, for the calculation of the concordance, we do not fix the cutoff value. Concordance gives an idea about the reliability of logistic regression. Thought it is not sufficient to rely solely on it. What it does, it takes every 10 pairs from the actual data, assuming binary logistic regression, and checks all the cases where the model has thrown a probability for 1 greater than the probability for a 0. Higher the concordance percent, better the model is. Now let's have a look at what's the difference between logit and logistic regression. The logit is a transformation, logistic regression is a regression model. The logit transformation transfer on lines to logistic curve. Logistic regression fits a logistic curve to set of data where the dependent variable can only take the values 0 and 1. It can be generalized to fitting ordinal data. Now let's have a look at what does the bias term represent in logistic regression. So in logistic regression, the predictors are assumed to have a linear relationship with the log odds of the success outcome. For example, if beta 1 in equation above is 3, then the log odd would be increased by 3 on average for each increase in 1 unit of x1. To see what the bias term beta 0 represents, simply set all xi to 0. The resulting log odds in the bias term. In other words, the bias term is the default log odds for the case of all predictors equals 0 or equal to reference value for categorical predictors. So this is what a bias term represents in logistic regression. Now let's have a look at, so is there an error term in logistic regression? Yes, two error terms can be defined for logistic regression. One, log loss or cross entry, which is equal to negative or maximum likelihood. You can use the output of the logistic regression to classify the data and compute the classification error of the model. You can use either of them, but the second one is more meaningful. Why is collinearity a problem for logistic regression? So basically, multicollinearity is a common problem when estimating linear or generalized linear models, including logistic regression and cost function. It occurs when there are high correlation among predictors, variables, leading to unreliable and unstable estimates of regression coefficients. Now let's have a look at what is C parameter in logistic regression. The trade-off parameter of logistic regression that determines the strength of regularization is called C, and higher values of C correspond to less regularization, where we can specify the regularization function. C is actually the inverse of regularization strength lambda. Now let's have a look at how is predictive modeling used in logistic regression. So logistic regression is a predictive modeling algorithm that is used when the y variable is binary categorical. That is, it can take only two values like 1 or 0. The goal is to determine a mathematical equation that can be used to predict the probability of event 1. Now let's have a look at which feature selection methods are better in logistic regression. The benefit of logistic regression is that it is parametric and has regression coefficients. You could then use L1 or L2 regularization. This penalizes more features with non-zero coefficients. L1 takes the absolute sum of coefficients while L2 takes the square sum of weights. L2 penalizes higher weights, so meaning it's encouraged more features with similar coefficients, whereas L1 could have a skewed set of coefficients a few higher and many lower. Now let's have a look at why is logistic regression so important for machine learning. Because logistic regression is the building block of machine learning and deep learning. Understanding it should be a first step of anyone who is starting their journey in data science. In machine learning, it is used for binary classification tasks. The logistic function f of x is equals to 1 by 1 plus exponential of minus x squishes the input and returns an output which is between 0 and 1. Hence, it gives the probability of a sample belonging to a particular class. Now let's have a look at, does scikit-learn support ordinal logistic regression? Yes, run an ordinal logistic regression like a multimodal ridge regression using MORD scikit-learn library. Now let's have a look at how can you improve the precision and recall of a logistic regression model. Improving precision and recall are the next step after trying multiple models. The purpose of precision and recall is not to be used to improve a model, but to evaluate one. The model with better parameterization will usually have better precision and recall. If you can train with less bias and variance, you will have better precision and recall and thus better F1 score. They are harmonic. Now let's have a look at what is log likelihood in logistic regression. It is the sum of the likelihood residuals at record level. The natural log of error that residual is calculated for each record, multiplied by -1, and those values are totaled. The total is when used as a bias for deviance 2 into L1 and likelihood exponential of L1. The same calculation can be applied to a naive model that assumes absolutely no predictive power and a saturated model assuming perfect predictions. The likelihood values are used to compare different models, while the deviances test, naive, and saturated can be used to determine the predictive power and accuracy. With logistic regression, accuracy of the model will always be 100% for the development dataset. But that is not the case once a model applied to another dataset. Now let's have a look at how do you evaluate a logistic regression model. So first comes the model evaluation. Model evaluation is a very important part in any analysis to answer the following questions. How well does the model feed the data? Which predictors are most important? Are the predictors accurate? So the following are the criterion to assess the model performance. First, AIC. In simple terms, AIC estimates the relative amount of transformation lost by a given model. So, the less information lost, the higher the quality of the model. Therefore, we always prefer model with minimum AIC. Now comes the ROC curve, receiver operating characteristics. So, ROC curve illustrates the diagnosis ability of a binary classifier. It is calculated and created by plotting true positive against false positive at various threshold settings. The performance matrix of ROC curve is AUC, area under curve. Higher the area under the curve, better the prediction power of the model. Now comes the confusion matrix. In order to find out how well the model does in predicting the target variable, we use a confusion matrix or classification grade. It is nothing but a tabular representation of actual versus predicted value, which help us to find the accuracy of the model. Now let's have a look at what is the difference between neural network and logistic regression. So neural network and logistic regression are different techniques or algorithms to do the same thing, classification of data. Logistic regression is a statistical approach while neural network mimics the brain's neural network concept. When we use sigmoid activation function in neural network, it behaves like logistic regression. Does logistic regression require independent variables to be normal distributed? No. You can get the theoretical guarantees on model performance for logistic regression without any assumption on the distribution of the variables. However, ALERT is typically trained using stochastic gradient descent and does benefit from normalizing the variables to have the same standard deviation. Otherwise, SGD can take much longer to train. That might be what paper is referring to when they say ALERT requires normality for the continuous variables. Now let's have a look at how do I deal with missing data when running a logistic regression. Lot of data, maybe greater than thousands of data points. It's safer to ignore if it's really only 10% than to do anything else or use random forest or something instead of logistic regression. Moderate data, thousands of data points. There are several simple methods for missing data implementation, and they will work reasonably given only a small portion of your data is affected. Small data, for small data set where it's going to be hard to learn anything from, I would consider either choosing a more advanced method that deals with the problem of missing data or to actually build a model based on some sort of domain knowledge or assumptions.
We have reached the end of our journey through data science. We have understood what data science is and have explored the data science lifecycle. Along the way, we have also discovered how different roles like data analyst, data scientist, and data engineer fit into the industry. We have covered important Python libraries and basic statistics which helped us in understanding the different type of machine learning, including supervised, unsupervised, and reinforced learning. We also covered SQL, including commands, views, stored procedures, and joins, and so how Python connects with MySQL. Our look into generative AI that showed us how these technologies are shaping the future. Finally, we talked about data science projects and common interview questions to help you get ready for your career. If you enjoyed this video, don't forget to subscribe for more. Keep learning, stay updated, and continue growing your knowledge in data science.